Hi, in this section we will learn about the following. What are functions? How many different types of functions are there in C language? And simultaneously we will see the examples of each type of functions. Let us start with understanding first of all what do we mean by functions. In the introduction part of this course, we have seen what do we mean by structured programming and what are the advantages of structured programming is. With the help of structured programming, the program can be divided into small blocks of codes or small chunk of codes that will perform a specific task. We name this block of code as a function. Say if we want to perform some task repeatedly, we write down the code using some name and we can call that code again and again based upon our requirement. Now what is the advantage? As we have already gone through the advantages of structured programming, I'll just brief them here. Using structured programming, programs are easier to read and learn. Programs are easier to maintain. Once the program is divided into functions, the complexity of the program gets reduced. Application programs are less likely to have errors. It is user-friendly when we divide the program into functions and debugging is easy. These are some of the advantages of structured programming we have already seen in the introduction part of our course. So structured programming allows us to divide the program into small block of codes and each block of code performs a specific task. We name these block of codes as functions. Here there are 5 functions. Main program is divided into 2 functions first, function 1 and function 2. Function 1 is further divided into 2 functions, function 3 and function 4. Function 2 is having another function within that, function 5. Now, function 1 is calling function 5. Function 4 is calling function 2 based upon the requirement. So it is easier to read and learn as well as it is easier to maintain, and moreover the complexity of the program is reduced and they are less likely to have errors, and it is user friendly for the programmer and debugging is easy in such a programming style. Now let us see how many different types of functions are there in C language. Functions are divided into 2 main categories: predefined functions and user-defined functions. First, let us start with predefined functions, also called as built-in functions. They form a standard library, so we call them as standard library functions as well. C standard library are inbuilt functions in C programming. So there is a huge set of library functions are there. One among them we have already came across, stdio.h. There are many such library functions are there. The prototype and definitions of these functions are present in their respective files. We call them as header files. The extension of such files are .h. How to use these header files in our program? We need to call the preprocessor directive, that is, using #include, we can include the header files in our program. Example, printf is a built-in function available in a header file stdio.h. scanf is also a predefined function whose prototype and data definition is available in stdio.h. Similarly, strcpy, getchar, string and character functions. Now, how do we use printf statement in our program? If a programmer is using any built-in function in our program, we must include its corresponding header file in our program using #include file name. Similarly, if we want to use sqrt, square root function, sine function or power functions, we must include the header file math.h in our program using #include preprocessor directive. Let us come to user-defined functions. Now C allows you to create functions according to your needs and requirements. Based upon our requirement, we can create a function of our own and we can call that function. Such functions are called user-defined functions. Let us have an example of user-defined function here. The first line is using a header file which contains the prototype and definition of printf and scanf statements used in the program. The second line specifies the function prototype. Whenever a user-defined function is used after main function, then a prototype must be defined such that this prototype specifies and tells the compiler that the following function is to be created after the main function. So at line number 15, we see the same function definition over here. And what we are doing it over here is not to be worried at this particular point of time. When we come for user-defined functions section, we will see this working in detail. That is, in the next video, we will see the detailed working of user-defined function. So this is just an example to understand how exactly a user-defined function is. Here, the user-defined function name is swap, having two parameters, int x, int y, returning nothing over here, so void is the return type. From line number 16 to line number 21 is the function body. Similarly, from line number 5 to line number 14 is the main function body. So this is just a brief about what is a function, how many types of functions are there in C language, and small examples to understand what exactly we mean by built-in or predefined functions are, and what do you mean by user-defined function. That's all regarding functions. We will see the remaining topics in the coming video. Thank you. Hi. In this section, we will learn about the following. First of all, what are user-defined functions? What is function prototype? What do you mean by function definition? And how to call a function? And at the end, the parameter passing mechanism used to call a function. Let us start with understanding, first of all, what do we mean by user-defined functions. In the last video, we have already classified the types of functions, where we have seen what is a built-in function is and what is a user-defined function is. Let us quickly recollect a user-defined function. C environment allows us to create our own functions based upon the requirements of a problem. So these functions which we created in a C program are commonly known as user-defined functions. The example also we have gone through it, the same example here. We are now going to see this example in detail. There are three things every function will have. Function prototype, function call, and function definition. Function prototype is optional if the function definition is provided before main function. Here in this example, we are providing the function definition after main function. Therefore, function prototype is required in such cases. So the second line specifies the function prototype. The program execution starts from main function, declaring two integer variables, giving a message to the user to enter two numbers, and reading the numbers in variables a and b. Now, here, before calling the function at line number 10, we are displaying the values entered by the user before calling the function. A value is %d replaced by a value, b equals to %d replaced by b value. When the control comes to execute the statement at line number 10, that is a function call, the function name used is swap. It is a user defined name. Any name we can use it in place of this name. And we are passing two parameters to this function. And the parameters are separated by using a comma operator, and comment tells it is a function call. When a control comes to execute the statement at line number 10, which is a function call, Compiler already knows that there is going to be a function with a name called as swap, which we are going to use in our program later after the main function. So compiler searches for its equivalent function definition, which is encountered at line number 15. So directly control comes from line number 10 to line number 15 to execute the function definition. Here, the purpose of using this function is to swap two values. Let us say A contains 10 and B contains 20. 10 is copied into variable X and 20 is copied into variable Y. So X holds now 10, Y holds now 20. We are using one temporary variable at line number 17, which is assigned the first value of X, that is 10. Next, line number 18, X equals to Y. So X takes the value of Y, that is 20, is assigned to X. And at line number 19, we are assigning the value 10 to variable Y. So X now contains 20, Y now contains 10. When we use a printf statement to print the values of these variables, you will get output as A equals to %d replaces the value of X, that is 20, and B equals to %d replaces the value of Y, that is 10. So here the values are swapped. Once the function completes its execution, the control goes back to the main function once again. So the control goes to line number 11. The immediate statement after the function call, which prints after swap terminates, is the message, and printing the values of A and B. A equals to %d, B equals to %d. We will see what exactly the output of this one when we run the program in the practical session of this functions coding. So time being, A equals to, you will get original value of A, and B equals to, you will get original value of B only, that is 10 and 20 respectively. Because the parameter passing mechanism we are using over here is call by value, also called as pass by value. Let us see in detail what are function prototypes, what is a function definition is. Here is function prototype. A function prototype is simply the declaration of a function that specifies the function name, parameters, and return type. This doesn't contain the function body. A function prototype gives the information to the compiler that we are going to use this function later in the program after the main function. Obviously, we don't require prototype if we are using or if we are providing the definition before main function. So here the function prototype is not needed if the user defined function is defined before the main function. Let's see the function definition. Function definition contains the block of code to perform a specific task. The task of swapping two numbers, we have declared a temp variable and we have performed the swapping of two numbers that is carried out in function definition. In our example, swapping two numbers and returning nothing. Let us see the syntax of using function definition in C language. Here is return type. In our example, it is void since we are not returning any value, followed by there is a white space in between return type and function name, followed by the function name. It is a user defined name. Any identifier name is valid over here. We have already gone through the rules of giving the name of the identifier. A valid identifier name can be given over here, which should start with an alphabet or underscore and can contain numerical values, can contain hyphen, can be a length of 32 characters or more with some compilers, followed by left parenthesis, then the arguments or parameters. At the end, right parenthesis is closed. Then the body of the function is placed within flower braces. Here, function definition flower braces is must. Let it be a single line of statement to be executed in a function definition. It is mandatory to have flower braces here. Let's see how do you call a function. Control of the program is transferred to the user defined function by calling it. Syntax of calling: just use the function name without any return type here. There in the function definition we have used the return type. Even in function prototype also return type is required. So function call does not require any return type, and it is not correct to give the return type when we call a function. Function name followed by the parameters or arguments. Even here the type is not required, that is data type is not required, only the arguments or the variables. Example, we have seen this function name swap a comma b. Swap is the name of the function, left parenthesis, a comma b are the arguments separated by comma operator, and at the end semicolon specifies a statement in C. Here it is a function call. Now, how do we pass the arguments to a function? Passing arguments to a function. In programming, arguments refers to the variables passed to the function, also called as parameters. In our example, we have seen two variables a and b are passed during the function call swap a comma b, which is referred to be as actual parameters. The parameters x and y, which accepts the passed arguments in the function definition, these are called as formal parameters. And actual parameter name and formal parameter name can be same or different. So what are actual parameters? Actual parameters are those parameters or variables which are provided in the function call, whereas formal parameters are arguments or parameters which are specified in a function definition. How many ways are there in which we can pass the parameters in C language? There are two parameter passing mechanisms supported by C language: pass by value or call by value. Second one is pass by reference or call by reference. What do we mean by pass by value is? Pass by value means that a copy of the data is made and stored by way of the name of the parameter. So a copy is stored at calling function and another copy is placed to the called function. Main function is calling swap, main function as a calling function and swap function as a called function. Pass by reference, a reference parameter refers to the original data in the calling function. So here is calling function. So our calling function in our example is main function and swap is called as called function. So value will not be copied here in the second parameter passing mechanism. So a reference is made, thereby the original data is referred. Now how it is referred and how the copy is passed, everything we will see in detail when we come for the examples of each one, that is pass by value and pass by reference one. To understand pass by reference, we need to understand the concepts of pointers. So once we cover the concepts of pointers, then we will see this parameter passing mechanism in detail. That's all regarding user defined functions in C language. In the next video, we will see the practical program section in which we will use user defined functions. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will see a practice program on a concept called as call by value. As we know that there are two parameter passing mechanisms C language supports. First one is call by value and second one is call by reference, also called as call by address. So in this program we will demonstrate how to swap two numbers using this mechanism call by value. Let us try to understand the scenario here with the help of this example. Here is the main function calling one function called as swap. Main is a calling function, swap is a called function. As the function name is encountered or function call is there, control goes to this function, executes the set of code over here. What we will do here in this swap function, we will swap A and B using a temporary variable. It is something like this. A and B are the local variables for main function. So memory will be allocated something like this. For A, some memory address. For B, some memory address we will assume. When swap is called with A and B, this is the parameter passing mechanism we are using over here is when swap function is called with these two values A and B, we are actually using call by value mechanism here. We are passing values. These two A and B here are called as actual parameters and A and B here are called as formal parameters. The values of actual parameters are substituted into formal parameters. For swap function, again two more memory locations are created with the name A and B. We can use the same name for actual and formal parameters or we can use different names as well. As the function completes its execution, these memory locations will be destroyed or removed. So value 20 is now copied into this A and value 30 is now copied into this memory location B. We are using this temp. So for temp, one more memory location is allocated. First statement temp assigns A will copy 20 here. Second statement A assigns B will copy 30 from this memory location into A's memory location. Last statement B assigns temp will copy down 20 back here such that the values are swapped here. Remember, these two values A and B are swapped only for this function swap. That means that this is swapped only within the existence of this function only. Once the function terminates and the control comes to the main function back again,
Here this A and B remains 20 and 30 only, because we are passing the values. Whatever changes we do it for formal parameters will not reflect it in actual parameters. That's what we are demonstrating with the help of this swap. This will give you a clear picture that whatever changes you do it in this function with formal parameters, this changes will not reflected back into actual parameters. So this is the example what we are going to use. Let us quickly see the program. Okay, we required two variables. So I'll declare two variables A and B. Initialize, or you can read the values as well. Call swap function with A comma B. Let us try to write down the function. Swap function takes two parameters, int A, int B. We required a temporary variable, so I'll declare a temporary variable here. Then swapping takes place with these three steps. Temp assigns A, then A assigns B, and the last step is B assigns temp. This is the message we are printing in swap function. But our main purpose here is whatever changes we do it here, is it reflecting back into the calling function? For that reason, we will have a print message before and after calling a function. This is the message before calling the function, and this is the message after calling the function. So one time we are trying to print the values of A and B before calling the function, then calling swap, control comes here, swaps the elements, control comes back again here and tries to execute the last printf statement. Let us see whether the values changed over here or swapped over here will have a impact or reflection into the calling function or not. Let us build. Here you can see the first output. Number one is 20 and 30. This is before calling swap, and this 30 and 20 within the swap, and 20 and 30 is the same value as calling a function after swap gets executed. That means that here the values does not get affected. So these values doesn't get affected because the actual parameter memory locations are different and the formal parameters memory locations is different. We will give a message clearly before and say after, and say after. Save, build and run. Can see the output clearly. Before calling 20 and 30, within the function it's swapped here, and after the function call again 20 and 30. So what do we learn with this concept is, whatever changes we do in formal parameters memory location, if call by value mechanism is used, this will not have reflection back into the actual parameters. That's all regarding call by value parameter passing mechanism in C language. We will see the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about the following. First, what are storage classes? How many different types of storage classes provided by C language? Then, we will try to understand the typical memory layout where the variables are stored or placed time to time. And at the end, the terminology related with storage classes, that is, what is scope, lifetime, initial value, and location of a variable with respect to storage classes. Let us start with understanding what do we mean by storage classes. Storage classes are used to describe the features of a variable or function. It gives the visibility and accessibility of a variable in the memory and helps the programmer to know where exactly the variable is and how long a variable will be in the program. This is the classification of storage classes provided by C language. First one is auto. This one is the default storage class. Extern, something referred to be as globally available. Static, whose value is retained. And register class, the CPU registers are used to store the data. We will see these 4 storage classes in detail by the end of this section. Let us first try to understand how exactly the memory layout will be and what are the basic elements of the memory layout. Whatever typical memory you take it, that is in the main memory, the lower address to higher address contents are as follows. First, the text, that is the code section. Whatever program we write down as a source code using .c extension, that will be residing in the area named as text. It is also named as code section. Here are the basic elements. Then above code section we have initialized global data. There are two types of data, that is local to the function and global. Globally available data can be accessed by any of the function in a program, whereas local data can be accessed only by the function in which it is declared. Uninitialized data will be available in the BSS part of the memory structure, which is referred to be as block started by symbol. So whatever variables which are just declared and not initialized are placed under this section. And once the variables are initialized, they are moved immediately to initialized data section. Then the area above this part is the heap memory. Heap memory typically grows from bottom to top as the memory is allocated by the user. This memory area usually is used for allocating the memory at runtime. Like functions are there, malloc, calloc, realloc, which are used to dynamically allocate the memory. So heap memory will be allocated. Then we have in the opposite direction, stack memory will be growing from top to bottom, and before that we have the higher address memory location is occupied by the command line arguments and environment variables of a program. We will have a separate video for understanding command line arguments. So this is a typical memory layout of the main memory. The features to be considered or the terminology which we are going to see in this particular section when we take what are the storage classes are, we need to understand the following terminology. First thing is the scope. Scope of a variable is the visibility or accessibility in which the variable is located. The lifetime or extent is the time period the variable spent throughout the program execution. That is, how much time a variable is accessible. That is the lifetime of a variable. Initial value, the value assigned for the first time to a variable, and location is the place in the memory. The features basically include the terminology what we have just seen, the scope, lifetime, initial value and the location, which helps us to trace the existence of a particular variable during the runtime of a program. Now here, let us try to apply these features to the storage classes provided by C language. Each one, let us start with the first one, that is auto. By default, a variable declared in C program is by default a auto. If we want to explicitly declare it as auto, then we can use a keyword auto before the data type. So the scope of an auto variable will be local. That is, it is available within the limit of a function in which it is defined. And the lifetime, once the block in which it is specified or a function in which it is specified is exited or terminated, then the lifetime will be over. So it is till the end of the block in which it is declared. Initial value for automatic variables are garbage values. So if we don't initialize anything, a garbage value will be assigned. And auto variables are located in the stack memory area. Let's come for the second type, static. Its scope is also local to the function in which it is declared or to the block in which it is declared. And how long it exists is till the end of the program. If this variable is declared in a function, if that function also terminates, then this variable of type static will be alive even though the function terminates. And by default, a initial value 0 is initialized to static type of storage class. And static variables are available in the data segment in the memory. We have seen data segment is available above the code segment, that is text. Let us come to the third type of storage class, that is register. Register is also local to the function or a block in which it is declared. So it is not accessible outside the function or outside the block in which it is declared. And its lifetime is till the end of the block. Once the block completes or ends, the variable of type register also no more available. Similar to static, register is also initialized with a value 0. And the most important point regarding the register storage class is here, where it is located. We have just seen the memory structure, typical memory structure of main memory. It is nowhere located in that memory structure, but there are separate memory structures provided to store this type of storage classes, that is called as CPU registers. CPU registers are faster in access when compared to normal memory structure, and these are used in loops indexes. Say for example, for I equals to 1 to 100, index I will be stored in CPU register such that for every iteration we need not go to the memory and access that memory location. So in general, CPU registers are faster in access when compared to normal memory structure. And there are some limited CPU registers are available with each processor. So we should not declare many variables of type register, but it is useful for a variable to be declared as registered if it is frequently used. Just example we have seen is an index I in a for loop or while loop or do while loop. And the last category of storage class is extern. It is globally available. Its scope is global. That means that these type of variables are declared above the main function, which are said to be global. So variables which are declared using extern keyword within any function, not only above the main function, they are global to all the functions in a program. What do you mean by global is the accessibility of these type of variables can be anywhere in the program, not only in the function in which they are declared. So the scope of this type of variables is global. Except this, all other scopes are local. And the lifetime of this type of variables are till the end of the program they exist in the memory. And if you don't initialize a value, by default a garbage value will be initialized, and they resides in the data segment of the memory structure. So these are some of the basic concepts regarding storage classes in C language. Let us quickly recollect. Storage classes provides accessibility and visibility of a variable in our program. There are 4 types of storage classes provided by C language: auto, static, register and extern. By default, if you don't declare any type, the default one is auto. If we want to declare it with a keywords, static we can declare, then we have the following properties. Similarly register, similarly extern. So except extern, all are local, whereas extern variables are global. Their accessibility is in any of the function in a program. That's all regarding storage classes in C language. We will see the remaining topics in the coming videos. Thank you. Hi. In this section, we will learn about the following. First, let us try to understand what are recursive functions. Then, how does recursive functions works? Then, how a particular problem is solved using recursion. Then, what is stack overflow error during recursion process? Then we will look at an example using recursive function with its detailed working, and at the end we will see the most important concept of tracing the recursive function. Let us start with, first of all, understanding what do we mean by recursive function. Normally, a function is a piece of code which can be called by another function. So we call a function which calls another function as a calling function, and the function which gets called is called as a called function. We have already gone through this scenario in the last video in our user defined functions. Here a calling function as well as a called function is the same. That is, a function that calls itself is known as a recursive function. And this process or the technique what we used over here to call the same function is called as recursion. So recursion is a technique or a process of calling function by itself. One most important concept regarding recursive function is every recursive function must have a terminating condition, also referred as a base case or base condition. Without terminating condition, a recursive function can get into an infinite loop. That means that if we don't provide a base condition or a terminating condition, then there is always a chance of calling that function repeatedly, just like an infinite loop. Let's see now how does recursion works. Here in this example, main function is calling recurse, control goes to the function definition. Once it reaches the function definition, within the body of the function, we are calling again the same function. We call this as a recursive call. Now, how long the process has to continue? Because when we are making a recursive call, the function is entering the body, again it is executing the statements. When it encounters the function call, again the control goes to execute the same function. Then there must exist a terminating condition using which the function must terminate. So it is just like an infinite loop without a base condition. Here, first time, main function is the calling function, recurse is a called function for the first time. Then once the control goes to recursive function, then recursive function is calling again recursive function with the same name. So control goes back again to the top of the function to execute the body once again. So here in this scenario, called function as well as calling function, both are same. This is how recursion works. Let us say a particular problem is there, then how that particular problem is solved with the help of a recursion process. The basic idea is to represent a problem in terms of one or more smaller problems and also add one or more base conditions, that is terminating conditions, that will stop the process of recursion. So here if a problem is given to us, we represent that problem as a collection of one or more small problems. Then we can identify one or more terminating conditions using which we can stop this particular process. Example, say if we want to find the factorial of a number n, then if we know the factorial of n minus 1, then we can find the factorial of n. For example, to find the factorial of 5, we must know the factorial of 4, and to find the factorial of 4, we must know the factorial of 3. Similarly, to find the factorial of 3, we must know the factorial of 2. And to find the factorial of 2, we must know the factorial of 1. Yes, here we know that if n is either 0 or 1, the factorial of such numbers are 1 only. So the base condition is reached now. That means that we have reached into a base condition when n equals to 0 or 1. We know the factorial of 0 or 1 is 1. That means that we came to the base condition of this particular problem. So here the factorial of a given number n can be further divided into something small problems like factorial of 5 is nothing but 5 multiplied by factorial of 4, and factorial of 4 is nothing but 4 multiplied by factorial of 3, and factorial of 3 is nothing but 3 multiplied by factorial of 2. Similarly, factorial of 2 is nothing but 2 multiplied by factorial of 1. Once we reach either 0 or 1, we know that the factorial of 1 or 0 is 1. So we start substituting the values of factorial of 1 as 1. Then the result is again substituted back. Then the result is substituted back. So on up to the first function call. Let us see what do we mean by stack overflow error in recursion. First of all, what do we mean by a stack? The memory area stack which grows from higher memory address to lower memory address. This memory area is used when recursion is implemented in a program. Stack follows LIFO property, that is last in first out. Can also be known as last element inserted will be the first element to be coming out from the stack. Now, when does stack overflow error occurs in a recursion process is if the base condition is not reached or not defined, then the stack overflow problem may arise. That means in a situation where if base condition is not reached in a program, then it may goes into infinite loop. Then a function call will be done repeatedly such that the contents of the stack will be filled in such a way that the stack memory will be full. Whenever stack is full, it is named as stack overflow. So it is the programmer's responsibility to make sure that we reach the base condition whenever recursion is used so that we can avoid such type of stack overflow errors. Let us see an example program. Sum of n natural numbers using recursion. In this program, we are finding the sum of first n natural numbers recursively. Line number 2 specifies the function prototype, which says that a function with a name sum takes one parameter of type integer and is returning a value of integer type. Program execution starts from line number 4. Once line number 10 is encountered, that is a function call sum with one parameter, that is the number. The control goes to line number 16 to execute this function. This time main function is the calling function and sum function is the called function. Now take an example here. let n equals to 3. At line number 17, the function body starts execution by checking the first condition. If n not equals to 0, 3 not equals to 0 is true. Enters the block, executes the statement, return n plus sum of n minus 1. Now here, if we recollect the basic idea, the problem is divided into one or more small problems. So here sum with n minus 1 is called by adding the current value of n. This condition at line number 17 is called as the base condition or terminating condition. Let us see the working once again. When a function is called once again with sum of 2 as a parameter, again the condition at line number 17 is checked, 2 not equals to 0. Again control comes to execute the statement at line number 19 by trying to add the value of current n plus again one more function call with sum of 2 minus 1, that is 1 this time. Again 1 not equals to 0, condition is true, enters the function, executes the statement at line number 19 by saying n plus sum of 1 minus 1. This time the parameter passed is sum of 0. 0 not equals to 0 is false. Else statement will be executed, that is return n. Now this type of function call seems to be somewhat confusion, that where it is returning the value. The value is returned into a stack memory. Once we see the tracing part of it, then the concept of this execution will be clear. Let us see here the detailed working of this particular program. We call this one as the tracing of the program. First time when I say main function is calling some function with a parameter 3, control comes to execute the sum function and the condition checked is n not equals to 0, return n plus sum of n minus 1. This time sum of 2 is called. So again 2 not equals to 0 is true, return n plus sum of 2 minus 1, that is 1. So this time sum of 1 as a parameter is called. If 1 not equals to 0 is again true, return n plus sum of 1 minus 1 is 0. This time, last time, 0 not equals to 0 is false. So when the condition is false this time, return n. What is current value of n is 0. 0 is returned to the previous function call. And from here, in the stack, n value is 1 and value return here is 0. So 1 plus 0, that is 1, is returned back to the previous function call. That is, here the current value of n is 2. So 2 plus return value is 1 added and the result 3 is returned back to the previous function call. That is 3. Current value of n is here 3. 3 plus 3 is 6, is returned back to the first function call, that is from the main function. So 6 value is returned and the result is stored in a variable result. Now this is just the tracing part of the function. Let us try to see how the memory will be. Here is the function, sum function. Initially, stack is empty, and remember stack follows LIFO property, that is last in first out. So when stack is empty, we are taking n value as example as 3. 3 not equals to 0. Yes, return 3 plus sum of 3 minus 1, that is 2. Where it is placed? It is placed into the stack like this. Again the control goes to the function sum. This time current value of n is 2 plus sum of 2 minus 1 is 1 is called. So here you can see the contents are placed one above the other, so that if you want to remove anything, the last one inserted will be coming out first with the property LIFO. This is second function call. Now sum of 1 as a parameter, 1 not equals to 0, yes true, return n, current n value is 1. So it is now going to be 1 plus sum of 1 minus 1, that is 0. Now this is the third function call. When 0 is passed as a parameter, 0 not equals to 0 is false. When this one is false, else part will be executed and return n. What n it is returning? Current value is 0. So this 0 is returned to the last function call, that is here. 0 is returned here to the last function call, and then the current value of n, that is 1, is added, 1 plus 0, and the result is returned back to the previous function call, that is sum of 1. So here it is, 1 value is added to 0 and it is returned to sum of 1. Now 2 plus 1 is 3. 3 is returned to the last function call. So here it is, 3 is returned. 3 plus 3, 6 is returned now from the stack. This is the final result which is popped out from the stack. Since the stack follows LIFO property, the last element which was inserted into the stack, the contents was popped out first, then the second last contents, then at the end the last contents which were placed here popped out are the contents which are placed first into the stack are popped out last. So the value return 6 is to the calling function in main, and we print the result 6. So the sum of natural numbers with n equals to 3 is 3 plus 2 plus 1, or 1 plus 2 plus 3, which results into 6. This is just a simple example to understand how recursive function works, what is recursion, and how stack is used as a memory structure whenever recursion is called. Remember, we are not creating a stack here as a separate data structure and allocating the memory. This memory, stack memory, is allocated from the memory area stack, and it works with a property called as LIFO property. That's all regarding recursive functions. We will see the remaining topics in the coming videos. Thank you. Hi, welcome to the demonstrating session of recursive functions, which is also called as recursion in C language. Here we are going to demonstrate the same program what we have seen while learning the concepts of recursive functions, that is finding the sum of n natural numbers. Those who have already seen the last video of recursive functions, we have seen the tracing part of the program, but here we will see by executing the program, and simultaneously we will trace out the output also. The function prototype tells the compiler that we are going to use the function sum with one parameter and it is going to return an integer value. Once this function sum is encountered, then the control goes directly to execute the function definition at line number 16. Till this point, the calling function is main function and called function is sum function. So here, normal function call this one is, a function is calling another function. Once the control comes to execute the sum function with one parameter as n value substituted as the value passed by the parameter for sum function. Let us take an example of n equals to 3. The base condition here, that is the terminating condition, is n not equals to 0. Without this base condition, this program might enter into an infinite loop because we are calling the sum function again with different parameters. So if there is no base condition, there is always a chance of the program getting into an infinite loop. For the first time, 3 not equals to 0 is true. Return 3 plus sum with parameter 2. Again the control goes back to the function definition at line number 16 and sum with 2 is called. 2 not equals to 0, again true. Return 2 plus sum of 1. Again the control goes to line number 16 to the function definition with parameter 1. 1 not equals to 0, again true. 1 plus sum of 1 minus 1. This time 0 is passed as a parameter. When 0 is passed as a parameter, 0 not equals to 0 is false, else part will be executed and the value return here is 0 to the last function call. So 0 plus 1 is substituted to the previous function call, then 1 is returned and 1 plus current value of n with the next function call is 2. So 2 plus 1, 3 is returned back. Now the n value is 3, 3 plus 3, final 6 is returned back to the main function and sum equals to percentile d, value gets substituted as 6 over there and the result is going to be printed as sum equals to 6. Let us build the project. As there are no errors or warnings, we will proceed with running the program. Enter a positive integer is the message. Once a user enters the number here, we are calling a function here in printf statement. So this time say I am passing number as 3. Control goes to this particular function to execute here. As we have just now seen the tracing part, final value return is 6. That 6 value is now substituted here in place of this percentile d. So you are getting the output as sum equals to percentile d, that is sum equals to 6 over here. Let us run with another input value, say 5. So sum of 5 natural numbers are 5 plus 4 plus 3 plus 2 plus 1, that is nothing but 15. How do we trace this one? Let's trace this value 5. First time 5 not equals to 0, true. 5 plus sum of 4. Next time the function call with a parameter 4, 4 not equals to 0, true. 4 plus sum of 3. Then so on it goes on up to 1 plus sum of 0. When n value is 0, 0 not equals to 0 is false, 0 is substituted to the last function call. So it is now going to be 1 plus 0, that is 1 is substituted. Then 2 plus 1, that is 3 is substituted. Then 3 plus 3, that is 6 is substituted. That is 4 plus 6, that is 10 is substituted to the first function call with parameter 5. So this time 5 plus 10, that is 15, is returned to the main function. I hope the tracing is clear. This is just a simple demonstration to demonstrate the working of recursive function. We will see various examples using recursive functions, from small problem solving to some big problems under recursion. That's all regarding recursive functions or recursion in C language. We will see the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about the following. What are variable length arguments in C language? What are variadic functions are? And what are the macros called as C variable macros? Then what do we mean by variadic term? And at the end, we will see the types of arguments in a variadic function. Let us begin with understanding what do we mean by variable length arguments in C language. Variable length arguments is a feature that allows a function to receive any number of arguments. We usually have a practice of passing arguments to a function when a function is called, but those arguments will be always fixed. In case where the number of arguments are variable length, then these are called variable length arguments in C language. There are situations where we want a function to handle variable number of arguments according to our requirement. Examples: sum of given numbers, minimum of given numbers, and average of given numbers, etc. In C programming, variadic function will contribute to the flexibility of the program that we are developing. To understand this flexibility, let us start with a basic example. Say, if we like to add two numbers, we might write a code like this. A function with a name add numbers taking two parameters or arguments, both are of integer type, and returning a integer type value. So the number of parameters here are 2. Further, if we like to add 3 numbers, we might write a code like this. Same function name or different function name might be, but here the number of parameters are, there are 3 arguments here. Earlier there were 2 arguments, now we are having 3 arguments. Same functionality it is doing. It is also summing up the numbers and returning the result. The only change what we have from the earlier function with this one is, earlier we were adding 2 numbers, now we are adding 3 numbers. As the numbers that we need to add grows, we can keep adding more functions with appropriate number of arguments, which represents the total number of arguments that we like to add. But that might get little bit cumbersome and hard to maintain as the number of arguments gets increases. Luckily, in C programming, there is a way to do this, that is with the help of a function called as variadic function, also known as variable arguments. The concept of this variadic function is already used in several inbuilt functions we have used knowingly or unknowingly. For example, in printf, when we want to print one number, we can write down a printf statement something like this. we have already came across this. Say printf in double apostrophes, first number is percentile d, then we have one parameter here. So this function is called with one parameter. When you want to print two numbers, we still use the same printf function like this. Now in this scenario, we are using two parameters. Same printf function, first number is percentile d and the second number is percentile d. So for this percentile d, the first argument value will get substituted, and for this percentile d, the second argument value will get substituted. So this time we are having two arguments. Earlier we had only one argument with the same function name. So this is already we have used this type of function. Same way in scanf also we have. If you want to read one number, only one arguments we will pass. Otherwise, if you want to read more numbers, then more number of arguments we will pass it. That is nothing but a variadic function. If you look into the stdio header file, you can see that this was implemented clearly using variadic functions. That means that printf will be there with one argument, printf function will be there with two arguments, three arguments, like that. You will be having one ellipsis clearly indicating that it is now going to take multiple arguments, something referred to be as variable number of arguments. Let us see what do we mean by variadic macros. In order to use these functions, variadic functions, we need to understand some macros. These are the list of macros which are available. The first one among this one is variable argument list. Variable argument list is used in situations in which we need to access optional parameters or optional arguments, and it is an argument list. So our list will contain some data that will be accessed after we declare our VA list. We will see the details of this one in the next video. Then we have variable argument start. This will connect our argument list with some argument pointer, and we will need to say how many elements in our function we have. Then next one in the list is variable arguments arguments. This macro is a macro that will get our data which is currently connected to the argument list. And next one is variable argument end. This one is used in situations when we would like to stop using some argument pointer. Then the last one is variable argument copy. Is used in situations for which we need to save our current location, something like a bookmarker. We will see all these macros in the coming video. All these macros are available in a header file called as stdarg.h, which we should be including in our code stdarg.h. Let us try to understand what do we mean by the word variadic. The word variadic tells us that there is some kind of change or variation is involved here. What is that one? The variation or change here is that we are dealing with unknown number of arguments for the function. So we are dealing with unknown number of arguments. So right now we don't know how many number of arguments a function will contain. And at the end, let us see how many types of arguments are there in a variadic function. There are two types of arguments in a variadic functions are there. The first one is a mandatory argument and the second one is optional arguments. In order to state that we have variadic function, we need to state three dots, which is called as ellipsis and denoted by here three dots. This indicates the second one, that is optional arguments, that is optional parameters. At least one mandatory argument is required. More than one mandatory argument can also be there, but at least one should be there. Make a note of this one. The order is very important in this case. That means that first we should have mandatory argument, then followed by optional arguments. You cannot change the sequence. That's all regarding variadic functions. We will see in detail the macros available in a variadic function like variable argument list, variable argument start, variable argument arg, variable argument end, and variable argument copy in the next video with a program as well. That's all for now. We will continue with the remaining topics in the coming videos. Thank you. Hi, in this section you will learn about the following: the list of macros used by variadic functions. Then we will see the working of each macro in detail. Then at the end we will see a program using this variadic function and the macros involved in this function. Let us start with the macros available in C language for a variadic function. A variadic function uses the following set of macros. We have already seen this list in the last video. The first one is a variable argument list, then variable argument start, variable argument arg, variable argument end, and variable argument copy. All these macros are available in the standard argument header file stdarg.h, which should be included in our code like this. This is the thing what we have already covered in the last video. Let us begin with the first argument, variable argument list. This macro is used in situations in which we need to access optional parameters and it is an argument list. List is nothing but collection of non-empty set of elements. So this list also contains a non-empty set of elements. So our list will contain some data that will be accessed after we declare our variable argument list. And the syntax to declare is variable argument underscore list, all in small cases, followed by space, then some argument pointer followed by semicolon. This declares a variable argument list. Then variable argument start. This macro will connect our argument list what we have defined with some argument pointer, and we will need to say how many elements in our function we have. In order to use this, we would write something like this. That is, the syntax to be followed is contains two parameters, some argument pointer, and followed by the number of elements. This means that we have already declared our list. So unless and until you declare the list, you cannot call the start macro. And we have passed the number of elements into our function. Then only you can specify here the number of elements. And the next macro is variable argument arg. Arg is a macro that will get our data which is currently connected to the argument list. And in order to achieve this task, we would need to know the type of our data. So to do that, we would write the syntax like this: va underscore arg, some argument pointer with some type. What type of data here? Say integer data, float data, double data, or a structure type of data, whatever it is. Here we need to specify as the second parameter. And the next one is variable argument end is a macro. Is used in situations when we would like to stop using the arguments list. One more situation in which we use this macro is when we need to reset our list position as well. So if we are accessing the contents of the list and we want to start the list again from the beginning, then also you can use this macro. This macro will be used like this with the following syntax. Simply with whatever argument pointer we have started the variable argument list, the same parameter should be provided for this macro. And the last one is the copy macro. Copy macro is used in situation for which we need to save our current location, something like bookmarker. If we are accessing the contents of the list and we are currently at say 5th element, we want to mark this element and we want to come back again to this element, then we can use this macro copy. In other words, if you are using the 1 2 arguments list, proceeding elements one by one, but later you would need to rewind your current position to some previous state, then you can use this macro. This macro will be used with the following syntax: va underscore copy with 2 parameters or arguments. Both the parameters are of list type. First one is destination and the second one is source. And at the end of this section, we will look at a program using variadic function. Here is a simple function. The name of this function is average, and it is taking one mandatory parameter over here. This one is a mandatory parameter, and here are the optional parameters. Optional parameters are specified using ellipses. And the first thing what we are doing it over here is declaring a variable list with a name pointer called as arguments. It's a user defined name. You can give any name. What this function is going to do is how many number of parameters we are going to pass it from main function. Then it will take and provide the average of it. Double sum equals to 0. Initialize 0 to a variable sum. And here we are starting the variable argument list with the first, this one as a parameter, and number what we are passing this one as a second parameter. So start takes 2 parameters. Same way arg also takes 2 parameters. Now here is the logic what we want to perform is placed between start macro and end macro. Once we have started this macro, then provide the logic of the code what we want to do. What we want to do, whatever the numbers we are getting it in the form of here type, what type of values we are going to get it is a double type. We take that argument, add it to a variable sum which is initialized to 0, add it to a variable, continuously add it and store it in a variable sum. When we end this macro operation, then we are going to perform sum divided by number, that is going to be return. So the return type is now a double return type. Here is the main function. Average is called for the first time. 3 is passed as a parameter and substituted here. These ellipses don't know how many number of arguments we are going to pass. This one will be substituting the number of parameters here. So 1, 2, 3. 3 arguments that will be passed as a parameter one by one here. One argument is given to sum and it is added. So initialize, say for example, initially sum is 0. When 2.2 is passed as a first parameter, this one is now going to take 2.2. When 32.2 is passed as a parameter, this will be copied over here, and 34.4 is going to be stored in a variable sum. And for the last time 6.3 will be your argument is going to be added to the value, and it is now going to take 40.7, which is going to be stored in a variable sum. When we divide this sum with number, what is the number we are having here is 3. So 40.7 divided by 3, whatever the average you are going to get it, that is going to be returned. Where it is going to be returned? It is going to be returned into this printf, and it is going to be displayed as average of 3 is equals to so and so. Same scenario here. This time this will be passed as the first parameter, and these are the variable parameters 1, 2, 3, 4, 5. You can see clearly here there are 5 parameters. There are 3 parameters for the first function call. Same function call we are making it 2 times here, one with 3 arguments, and for the second time we are passing 5 arguments. That's the advantage of having variable arguments in functions. A very useful feature of C language. We will see the implementation of this program as well. And here is the program implementation, what we have just now seen. Average is the function name, mandatory parameter, mandatory argument, ellipses specifying optional parameters, first macro, VA list with a user defined name, arguments. Same argument we are using it here. The number what we have passed as a parameter will be used over here in VA start. This initializes the argument to store all values of the number num. Now in this one we are providing the logic, sum up all the inputs. We still rely on the function caller to tell us how many are there as the parameter. So here is the only type what we are passing it. Arguments, we don't know how many number of arguments we are going to get it. And at the end, call va end to terminate the macro. Here is the function call. First function call average, second function call average with 3 and 5 as a parameter. Let us see the output by running the program. Let us build, and you can see there are no errors. You can run the code, and here you can see this is the first function call with 3 as a parameter. So you are getting output as average of 3 is equals to value substituted over here is 13.0, 2 zeros because of this 0.2f. Average of 5 is equals to 3.08 because of this 0.2f. This 2 decimals are, otherwise you will get continuously 8 decimal values. And here you can see clearly we are passing 3 arguments, and here we are passing 5 arguments. Hope the working of variadic function is clear. We will continue with the remaining topics in the coming videos. Thank you. Hi and welcome to another programming challenge. In this programming challenge, let us see the problem statement first. We need to find the GCD of 2 given numbers using 2 procedures, that is iteration as well as recursion. So the input will be given to you will be 2 given numbers. We need to find the GCD of these 2 given numbers using 2 different methods. Example, if the inputs are given as both 5 and 5, the result is 5. First of all, what do we mean by GCD? GCD is the greatest common divisor, also known as highest common factor. So what is the greatest common divisor among these two? Is 5 itself. Say first parameter or first input is greater than the second input. Then we see, is there anything common between these two? Yes, common thing is 4. Similarly, it may happen that the first parameter or first input may be less than the second parameter or second input. Then we will see again the same thing. Is there anything common between these two? Yes, common factor is 2. So answer will be 2. Let us consider an example here where nothing is common between the 2 parameters or 2 input values. Then the output should be 1. These are all the possible input values, and we need to get this particular output for each input values. Okay, at this stage I suggest you to pause the video and pen down the logic for finding the greatest common divisor, or if you want to proceed further for the guidelines to be provided, let's see for the first one, that is for 5 and 5. Very simple one. This one is check whether both the values are same. Then the GCD will be either the first one or the second one. Let us say if these 2 values are not same and first value is greater than second value, let us assume that this value is m and this value is n. First we will check if m is equals to n, then output can be either m or n, anything. But if m is not equals to n, here we know that they are not equal. Then what would be the procedure? Just check. If they are not equal, first find out, is there any common factor between these 2 things? How? Subtract the values of the smaller one from the greatest one, that is subtract it something like this. 12 minus 4 will be 8. 4 will be as it is. Are these 2 values are same again? No. Continue further. 8 minus 4, 4, and the second parameter remains as it is until both are equal. Once they are equal, we know that GCD is the same. Let us say in case the third category where first number is smaller than the second number. They are not equal even though. So here the scenario is they are equal, first case. Here they are not equal but m is greater than n. That is the second scenario. Similarly, here is the third scenario, even though they are not equal. Now we will subtract the values 8 minus 2, that is 6, and store it in the second parameter. 2 will be as it is, and continue. Since these two values are not same, subtract again. 6 minus 2, 4. Subtract again to get 4 minus 2, 2. Now since they are same, again GCD will be this one. But consider a last scenario where m is not equals to n, and here what is the third category? Here is m is less than n. This is the third case. So this particular situation is neither the first one nor the second one nor the third one. That means that there is nothing common among m and n. How do we stop the process over here is continue the process like 11 minus 3, that is 8. Then these two are not equal. Then again 8 minus 3, 5. These two are not equal. 5 minus 3, that is 2. Again these two are not equal. Then which one is greater right now is 3 is greater. So 3 minus 2 is 1 and 2 is here. Again now this became greater. So 2 minus 1, 1. 1 comma 1. Now we will stop the process since both are equal, and now you will get the GCD as 1. So this is going to be the fourth category or fourth case. With this particular solution guidelines, I hope we can get some solution. You can try out your own solution or you can watch the next video for the solution of this particular challenge. Thank you. Hello and welcome to the solution of the programming challenge to find the GCD of two given numbers using two different procedures, iteration and recursion. Here we are ready with the template program. Let's quickly recollect what exactly GCD is. GCD is the greatest common divisor between two given numbers. It is also known as highest common factor. For those who are not from mathematical background, let me just give a brief about GCD and HCF. Let us say I have two numbers, say m equals to 20 and n equals to say 5. First of all, we will check is these two numbers are same. If these two numbers are same, obviously GCD or the greatest common divisor will be the same number. But here these two numbers are different numbers. Then we will see, is there any common factor among this one? How do we check that one? Let's proceed further. As we know mathematically that there is a common factor between 20 and 5, that is 5 itself. So we will try to reduce the value 5 from the largest number, that is 20, and store the result back here and keep n as it is. Again we will check, are these two numbers are same? Not. Again continue the process. Here it is now going to be 15 minus 5. Again this number remains same. Are these two numbers same? No. How long we are going to continue this process? This process is going to be continue until both the numbers are same. So for the next time we will get both the values as 5 and 5. As we get these two numbers are same, we will say GCD is 5. Let us consider another scenario. Say for example, I have a number say 13 and I have another number say 4. As we know that nothing is common among these two numbers. So we will proceed subtracting these two values. 13 minus 4 will give you 9. This one remains as it is. Again 9 minus 4 gives you 5. This one remains 4 as it is. 5 minus 4 gives you 1. This remains as it is. Now 4 is greater than 1. This time 4 minus 1 is stored over here and this one remains as it is. How long we are going to continue this process? Until both the numbers are same. So for the next time, here you will get 3 minus 1 is 2, 1 remains as it is. Then 2 minus 1 is 1. Now you got these two values are same. So we will say the GCD is going to be 1 if the numbers are not having any common factor within them. So by keeping these things in mind, let us write the program. I'll declare two variables over here, say n1 comma n2 are two variables. You can declare any names and give a message to read the numbers. Okay, once we are done with reading the numbers, let's call GCD. Here I am calling a function, say GCD with two parameters, say n1 comma n2, and let us write a function over here with the name GCD. First we will write down iterative one, that is using a loop. Now I am using actual parameter values as n1 and n2 here and formal parameters as m and n, such that n1 value is copied into m, n2 value is copied into n. So we will iterate it using a loop while m not equals to n. Until both are not equal, we have to repeat the process until they become equal. So there are two possibilities inside if they are not equal. That means that m can be greater than n. In this case, we have to reduce the value of n from m and store it in m again. So I'll say m equals to m minus n. Otherwise in the sense m is not greater, m is not equal. That means that m is less than n. In this situation, it will be n minus m. These things has to be repeated, and at the end, when both becomes equal, and at the end when both m and n becomes equal, then we have to return the value. Says either you return n or you return m. Let us build and test. First input value 20 and say 4. Here we are reading in n1 only, so n2 should be the parameter 20 and 4. Here we can have a look. First n1 is 20, n2 is 4, and the result is this particular function call. Here we can see %d, this one refers to this n1 value. What we are trying to print over here is 20, first number. This %d is printing this n2, that is nothing but 4, and we got a function call over here GCD. Control goes to the function and evaluates the GCD of 20 and 4, and the result is going to be 4 over here. This %d refers to this one. This one is the function call, and when value is returned, it is printed over here. Let's test with another input 11 and 3. As we know that nothing is common between these two numbers 11 and 3, therefore the value returned is 1. How the values are going to be evaluated? First 11 minus 3, that will be stored as the first parameter 8 and second parameter remains as 3 only. Next 8 minus 3 changes to 5, second parameter 3 only. Next time 2 comma 3, next time 2 remains as it is, 3 minus 2 is now going to be 1. So this is going to be 2 comma 1. Next time 1 comma 1. When 1 comma 1 is there, both m as well as n are now going to store 1 only. So we are saying return n, that is nothing but 1 is returned. Okay, this is fine with respect to iteration. GCD for iteration or GCD using iteration is perfectly working. Let's have GCD for using recursion. I'll change the name over here. I'll call this one as GCD using iteration as I, and this one using R, and this one is GCD using iteration. Let's have the function for GCD using recursion. Same two parameters m comma n. Now here is, you must have the base condition first to be given. That is, what would be the base condition or terminating condition for a recursive function? If both the values are same, if m equals to n evaluates to be true, then we can say return either m or n. Else it might happen that if both are not equal, m might be greater than n or n might be greater than m. Let us check this particular condition first. If m is less than n, that means that n value is greater now. You can even check for m greater than n also. Then in this particular scenario, return call the function GCD using recursion by changing the first parameter. That means that we know m is greater, so m minus n, comma, the second parameters remains as it is. Let us say if it is not true, that means that m is not equal, m is not greater, that means m is less. We will call GCD function by keeping the first parameter as it is and second parameter is to be changed. Same logic what we have applied over here in iterative one. Let's see what is the common thing about these two. We are iterating till m is not equals to n. We are checking one condition over here. If both are equal, then we are returning n. Here also, if both are equal, then control will come to this return n and it will return m. Both are same. Otherwise, if m is greater than n, what we are doing it here? If m is greater than n, we are changing the value of m. That's what we are doing it here. We are changing this particular parameter. M parameter we are changing if it is greater. Else, second parameter is changed here. That is nothing but the value what we are changed over here. So n value is replaced and iterated into the loop. Here the parameters are changed. The first parameter if it is greater, otherwise second parameter. Hope the logic is clear. Let's try to run this one and check the output. Same input values. Now I am printing 2 times over here. Now you are getting output 2 times. 24 is 4 and 24 is 4. Okay. Let's give a different message over here using iteration and using recursion. 11 and 3. You can see a function call with first 2 parameters 11 and 3 is done using iteration and the value substituted is 1. Then the next function call is using 11 and 3 using recursion and the value return is 1. So let's quickly recollect the things what we have done here. We have read the 2 numbers to find the GCD. Then here we are calling GCD using iteration with 2 parameters n1 and n2. Control comes to this particular function and process it and finds the GCD and returns n value. That n value is now going to be printed over here using this %d. Similarly, GCD using recursion is called with 2 parameters. Control comes to this particular function and check the base condition first. If both are equal, return n value. Otherwise, it may happen that m is greater, then call GCD function recursively here. So what is the difference over here is we are iterating in a loop. Here we are calling the function. Same function is called using this GCDR function name. Therefore, it is called as a recursive function. Hope this matches the solution what you have generated. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another programming challenge. The problem statement for this programming challenge is we have to find the Fibonacci series for a given n number. First of all, what is a Fibonacci series is? A Fibonacci series will be of this particular form: 0, 1, 1, 2, 3, 5, 8, so on. How these numbers are generated? Those are from mathematical background knows the logic behind Fibonacci series. Those who don't know the logic, I'll give you some guidelines in the solution guidelines now. Example, Fibonacci of 5 is going to be 3 and Fibonacci of 8 is 13. If the input parameter is say 5, fifth number we are talking about. So what is the fifth number over here is 3. 8 is the parameter. Eighth number in the Fibonacci series is 13. This is going to be the eighth number. Like that, if I call Fibonacci of say 10, obviously this is ninth number, this is going to be the 10th number. But how these numbers are generated? I'll provide the solution guidelines for those who don't have any idea regarding Fibonacci series. But I suggest you, those who have some basic idea regarding Fibonacci series, to pen down the solution and generate the logic and write down the program. Let's continue here with solution guidelines. Fibonacci series is of this particular form. Let's say these two numbers are say A and say B. These two numbers are added and store it into the next one, say C. Then again, this one is treated as A and this one will be treated as B again. Then again, the sum of these two numbers, last two numbers, will be placed here and this one will be treated as the result C. Again, this one will be A and this one will be assumed to be B, and again 1 plus 2 is now going to be 3, which is said to be C. Again, this one will become A, this one will become B. Add these two values and store the result in C. Continue the process. So when Fibonacci is called with a parameter say 5, 5 means the fifth number in this particular series is, this is the first number, this is second number, third number, fourth number, and this one is going to be the fifth number. So that is going to give you 3 over here. Similarly, if I call Fibonacci with 8, eighth number is 13. How 13 is obtained? 5 plus 8, that is actually this one will become A, this one will become B. A plus B will give you here and store the result C. This is simple to understand. In both ways we can achieve this particular one, using iteration as well as using recursion. So all the best for the solution. For those who want to see the solution, you can watch the next video. Thank you. Hi and welcome to the programming challenge solution to find the Fibonacci series of a given number. There are many possible solutions for this particular problem. You can have an iterative solution or you can have a recursive solution. We will go for a recursive solution. So what are the requirements for the problem over here is, I'll be writing down a recursive function which takes one parameter. By taking that n value, it will sum up all the numbers till that number and return the number of that Fibonacci series. Let's begin over here. I'll give a message to the user. Once we have read the number, I'll just declare the required variables over here. Say n is the number which is to be declared over here. I have declared it. Let us call Fibonacci in printf itself. Here in this printf, I am calling the Fibonacci of percentile d, that is the given n number. I am calling this function and whatever value that is returned by this function, I am trying to print it over here. Let's quickly write down the function. Since it returns an integer value, I am using a name fib. You can use any name. It's a user defined name. And n is the formal parameter what I am taking. If you closely see here, n is the actual parameter and n is the formal parameter. You can give different names of these parameters or you can give the same name. Let's have the base condition over here. What would be the base condition? If n equals to say 1, if there is only one number, then return 0, because we know first number is 0 and we know that if n equals to 2, sum of these two numbers will be 0 plus 1. 0 plus 1 is now going to give you 1. Let us say if it is neither 1 nor 2, then else part will be executed and return call Fibonacci now with two different parameters, that is n minus 1 and Fibonacci of n minus 2. Let's say I'll place it into this one parenthesis. So what this function will do, let's first of all run and check what exactly the output is, then we will trace out this function as well. Okay, this function declaration must be here, so I'll just have a prototype of this function. Int fib takes integer as a parameter, that's all. Build and run. Enter the term, let's say term 5. Here we got the output, that is fifth term is 3. Let's run it for another input value, say 8. Perfect. Fibonacci of 8th term is 13. Now a small modification I want to do in this particular program is, as I run the program, I want to ask the user to continue for the next term. So I want to continue with a loop, or this particular process I want to repeat it. So I'll just place this one within a loop. Say for example, do while loop. Let us do some modifications over here. We assume that the number is always positive. But what happens if the number is negative? We are not doing any condition checking for that one. So if the number is greater than 0, then we will call this function. But what happens if the number is less than or equals to 0? We'll give a message to the user that enter correct input. Then we will ask the user, do you wish to continue? If yes, press 1, say for example. Then we will read the choice from the user and repeat until this choice is equals to 1. We need to declare this variable choice over here. So I'll declare a variable choice here. Okay, let's see now how this changes will work. Let's build and run. Enter the term. I'll enter it, say 5. I got Fibonacci of 5th term is 3 perfectly. Then again I am getting a message over here. Do you wish to continue? If yes, press 1. I'll press 1. I got again the same message. Enter the term. Say 8. The Fibonacci of 8th term is now 13. That means that again and again I don't need to run the program. I am just repeating the same thing using a loop, do while loop. Then again I want to continue, I'll press 1. Which term? Let's say 10th term. 10th term is 34. Similarly, 11th term 55. Let's begin with the first term itself, that is term 1. Term 1 is 0. Term 2 is 1. Term 3 is 1 again. Then I want to continue with term 4, 2. Term 5, 3. Term 6, 5. Like that it goes on. Term 7, then term 8, then term 9, then term 10. Randomly I want to give a number, say 20. I'll get 20th term. I don't want to continue. I'll just press another number other than 1. So it terminates the program now. Perfectly. So you can perform modifications according to your requirements. Here we have provided a do while loop to repeat the process, and we are checking one more condition over here to make sure that the number entered by the user is greater than 0. And the logic lies in this particular function. The base condition is, there are two base conditions. If the number is 1, then we return 0. If the number that is entered by the user is 2, then return 1. Otherwise, then we are calling Fibonacci of n-1 and n-2. Let's see how this one is going to work. Assume that I'm calling Fibonacci of 5. You know what exactly Fibonacci of 5 is? The series is something like this: 0, 1, 1, 1 plus 1. Actually 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3. Same way 2 plus 3 is 5, 3 plus 5 is 8, and so on. 8 plus 5, 13, and so on, the Fibonacci series. Let's say the input value entered by the user is 5. Control comes over here by taking this parameter from here to here. and the value substituted for the first time is 5. Condition check over here. This condition doesn't satisfy, even this condition also doesn't satisfy because it is 5, not 1, not 2. Fibonacci of n minus 1, Fibonacci of n minus 2 is called. That means that it will be calling the Fibonacci function 2 times like this. Fibonacci of n minus 1 is nothing but Fibonacci of 4 is called, plus Fibonacci of 3 is called, that is n minus 2. Again check the condition. Fibonacci of 4 is called. So this parameter is now 4. It's neither 1 nor 2. So then again function is called 2 times. Fibonacci of 4 minus 2, 3. Fibonacci of 4 minus 2, that is 2. Again this function will be called now 3. It is not equals to 1, it is not equals to 2. Then again it is called one more time. Fibonacci of 3 minus 1, that is 2, plus Fibonacci of 3 minus 2, that is 1. This time when you call this particular function with parameter 2, here the condition satisfies and value return over here is 1. Where the value will be returned? Value will be returned over here is 1. When this function is called with parameter 1, then 0 will be returned. So here the value return is 0. 1 plus 0. This 1 plus 0 is returned to this function called 1. And what about Fibonacci of 2 here? Fibonacci of 2 will be 1. So 1 plus 1 return over here is 2. Same way Fibonacci of 3 is called. So Fibonacci of 3 will be Fibonacci of 2 plus Fibonacci of 1. We know Fibonacci of 2 is returned is 1. So 1 plus this value will be 0. So finally this control will return a value 1 here, and then 2 plus 1 value return over here is 3. So Fibonacci of input value 5, that is, this is for Fibonacci of 1, Fibonacci of 2, Fibonacci of 3, Fibonacci of 4, and here Fibonacci of 5 is returned as 3. This is how the actual tracing of the function call, that is Fibonacci of 5, is takes place. That's how you got the output over here as 3. So we know that Fibonacci of 5 is 3. Same way, when I call a function Fibonacci of 6, how it will be executed? It will be something like this. Fibonacci of 5 plus Fibonacci of 4 it will be. You know what is Fibonacci of 5 is? Fibonacci of 5 just now calculated, that is 3, plus Fibonacci of 4, you know what exactly the value is here, 2. So value is going to be 2. 3 plus 2, that is nothing but 5 will be returned over here. As a result, you can see value 5 here. Same way, if I call Fibonacci with 8 parameter, then it will be calling the function as Fibonacci of 7 plus Fibonacci of 6. You know Fibonacci of 7 is going to give you 8. This value is 8, plus Fibonacci of 6 is now going to give you 5. That means that Fibonacci of 8 will return 13. But this one will not be directly substituting. This one will be evaluated again further as Fibonacci of 6 plus Fibonacci of 5. Again it will be evaluated further and goes on calling the functions. This is how the tracing of the function, recursive function, will be. Hope this have give you a clear picture how exactly Fibonacci series generates a number using recursion. That's all for now. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge, let us see today's challenge, functions in C. Let us quickly move on to the objective. In this challenge, you will learn simple usage of functions in C. Functions are a bunch of statements which are glued together or combined together. We have already came across functions concepts, so we need not worry about these details. This is just given a description about functions. A function is provided with 0 or more arguments, that is nothing but the parameters, and it executes the statements on it. Based on the return type, it either returns nothing, that is void, or it returns some value. Here is the syntax for a function: return type followed by function name followed by the parameter list, also called as arguments. Here is an example given. Example to read 4 variables, name of a function, or taking 4 parameters and returning sum of all these 4 values using plus equals to operator. Now, what is our task here is you have to write a function with a name called as max of 4, taking a, b, c and d are the 4 parameters and returning integer value. That is nothing but what is the maximum among these 4 values, we have to return it, which reads 4 arguments and return the greatest of them. That is a task. So the input will contain 4 integer values a, b, c, d, and the output is we have to print the greatest among these 4. One thing to be noted over here is we need not read the value and we need not print the value, that will be automatically handled. So if say sample input is a value is 3, b is 4, c is 6 and d is 5, among this one the greatest among this one is c, that is nothing but 6 value, that is outputted here. Let us try to understand first of all how exactly we can write down a code for finding the maximum of 2 numbers. Say for example, I want to find maximum among 2 given numbers, say a and b. I'll be returning a integer value for this one. So whichever is greater among these 2 is greater. That means that I'll check the condition. If a is greater than b, then I'll be returning a value a, otherwise I'll be returning a value b. This is nothing but a ternary operator I am using. Just I'll include one return statement, and this function is now going to find the greatest among 2 given numbers. But the task what we have to perform is we have to find the greatest among 4 integers. That means that this max function can be called internally something like this. Say for example, if we have a here as 3, b here as 4, c here as 6 and d here as 5. I'll be writing down the first function call, say max of. First I'll call with the last 2 parameters, say c and d. So I'll say c comma d. You know what is the maximum among this one? Maximum to be returned among this one is c. So d is gone. C is the maximum among this one. Now I'll take the next one, b. I'll place b like this and I'll call once again max function, because I have max function with 2 parameters already available. So here one value that is returned by this function call is c. That will become automatically the second parameter for this max function call. When I call max with b and c as the parameters, now it will compare b and c as 4 and 6. The value returned over here is c. That means b is discarded now. Now I have only one value left out. What is that one? A. So now I'll again compare with a something like this. I'll call max function one more time. That means that value returned by this part is c. Now is compared with a. That is 6 is now compared with 3. You know that the value going to be returned is c. That is handled by this function. This max function will take care about the 2 parameters. Now when we return this one, just I'll write down this single return statement with a semicolon to be placed within flower braces of a function name. I'll write down the function name as, say, return type int max of 4, any function name, taking how many parameters? 4 parameters. Done. Our task is over. Let us quickly write down the code. I'll first of all write down max function. You know that max is going to take 2 parameters, a comma b. what it is going to do is it's going to compare A value with B value. If A is greater than B, I am using ternary operator over here. We can even use if else condition also. Very simple ternary operator statement. It is nothing but, let us see how this ternary operator works. It is something like this. If A is greater than B, return A, else return B. So instead of writing down this code, I am just placing the same equivalent code using a ternary operator, question mark and colon. Now, here is a function call, max of 4 with 4 parameters A, B, C and D. So, here is the return type is integer. So, we will provide int as a return type. The function name is max underscore of 4. That is maximum of 4. Taking 4 parameters. Max of 4 is taking 4 parameters. I'll be calling the max function what we have written just now with first A using again max, with B with again max, because max will take always 2 parameters. So this time max of C comma D. So just now we have evaluated this working. First this max will be calculated, and according to our example values here, first this max will be evaluated, and according to the input values what we have 3. So first among 6 and 5 value is 6 evaluated, then B is given as an next parameter. So among 4 and 6 here it will be compared. First time A greater than B, A will become first time, C will be passing as a parameter, call by value, so value will be substituted here. D parameter, value will be substituted here for the first time. It is 6 here, it is 5 here. Now the condition is 6 greater than 5. Yes, it is true. True means A is returned. Where it is returned? It is returned to this function call. To this function call, current A value is 6. So 6 will be substituted like this. Now again max function is called with 4 comma 6 as a parameter. So this time parameters are 4 and here this parameter will become 6 now. When comparing the condition A greater than B, this time condition fails. Fails means what we are going to return is B. B is returned. B value is nothing but 6. 6 is now going to return to this function call. So for this particular function call we are now going to have 6 value. Leave this part. Now A is passed as a parameter. Next A value is nothing but 3. So this time this is going to be 3 substituted. Here it is going to be 6 substituted. Among this 3 greater than 6 condition is false. When condition is false, this part will be returned, that is B. B part is nothing but 6. So here for this function call also we are going to get 6 as the result, which we are returning it here as a return type. So control will come and substitute the value 6 into this variable, and you are going to print that maximum is 6 will be displayed here. This is how the working of maximum among the 4 numbers will be. Let us see. By running the code, it has passed the sample test case. So we are getting a message over here, congratulations on passing or clearing the test case. Let us submit the code for the remaining test cases. Here are the remaining test cases which are currently evaluating. Here is the message, congratulations, you have successfully solved your 5th code challenge, keep it up. Now that we have solved it, so we earned 10 points and we are now ready for the next challenge that we will see in the next video. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is to calculate the nth term. Let us quickly see the objective. This challenge will help you to learn the concept of recursion. Recursion is a process of calling a function by itself. So here is a function that calls itself is known as a recursive function. The C programming language supports recursion, but while using recursion, one needs to be careful to define an exit condition that is also called as terminating condition or base condition. We have named this one in our concepts when we have learned recursion, this one as a base condition or terminating condition. Otherwise it will go into infinite loop. If you remember, same thing we have learned over there. To prevent infinite loop in the recursion, if else statement can be used. We will be avoiding this else part as well. We will see the code, efficient code, how we can write down the code. Here is a sample recursive function is there. Function which is calling itself is a recursive call, and this function call is for the first time. Then internally it will be calling it again and again until the condition over here, that is a base condition or terminating condition, gets satisfied. Let us quickly jump into the task what we need to perform here. There is a series with a name S where the next term is the sum of the previous 3 terms. It is almost similar to Fibonacci series, which we have already solved in our programming challenge. So it is much similar to that particular concept. Given the first 3 terms A, B, C respectively, you have to output the nth term of the series using recursion. How it is? Say if n is equals to 1 is inputted, this is a recurrence relation. To find the time complexity of any recursive function, first a recursive function will be converted into its recurrence relation, and the recurrence relation can be solved using either substitution method or master's method or any other method to find its time complexity. So here is the recurrence relation given to us. If the value of n is 1, then return A. Otherwise, if the value of n is 2, return B. N is 3, return C. Otherwise, recursively it is now going to call this series S of n minus 1 first time, n minus 2 next time, n minus 3 next time, and all the values are getting added over here. The first line contains a single integer, that is n, input format. The next line contains 3 space separated integers A, B, C. So here the constraint is the input values should be in the range of 1 to 20 and A, B, C should be in the range of 1 to 100. The output format should be, we should print the nth term of the series using this particular recurrence relation S of n. Let us say if we have this sample input, n value as 5, A value as 1, B value as 2 and C value as 3. The output should be 11. How it is? Let us see the explanation given over here. Consider the following steps. S of 1 will evaluates to 1, that is nothing but A value. S of 2 will evaluates to 2, that is nothing but B value. S of 3 evaluates to 3 or returns 3, that is nothing but C value. Here is a recursive call. Recursive call. S of 4 is nothing but S of 3, that is nothing but n minus 1. S of 2, that is nothing but n minus 2. S of 1, that is nothing but n minus 3. If it is a case for S of 5, same thing, n minus 1, n minus 2 and n minus 3. From step 1 to 3 and 4 until this particular one, we can say S of 4 will evaluates to, because all these values are evaluated to 6. So we can say directly substitute this value over here. We will get S of 3 is nothing but 3 here plus 2 plus 1, that is nothing but 6. So S of 4 returns you 6 value here. Then using the values from step 2, 3, 4 and 5, S of 5 will be now substituted as S of 4 is nothing but here value is 6 plus value of S of 3, we know this value S of 3 is nothing but 3. S of 2 value is nothing but 2, that gives you a summation of 11. To understand it better, we will write down a recurrence relation or a recursive function first of all. So a recursive function will be something like this. Say I am writing down a function, say function, which is taking the number of parameters, say n, and taking A, B, C as the parameters. I will be checking one condition. What is that condition is, if this parameter what I am getting n value as 1, so I will write down if n equals to 1, then I will say return A, because what we have to return over here is 1. 1 is nothing but your A value. Same way, if n is equals to 2, then return B, that is nothing but 2 here. Same way, if n is equals to 3, return C. And lastly, we just need to return first time n minus 1 with the 3 parameters as it is, plus next time n minus 2 with 3 parameters as it is, and n minus 3 with a, b, c as the parameters. If I place this one in parenthesis, it will be something like this. How this function call will be? Here is the function call. Let us say function of n value passed here is, what is the n value passed here is the s of phi. So I'll consider phi as a parameter. For a, b, c values remains. So here 1, 2 and 3 as the parameters. For the first time, when n value is 5, here this condition is not true, this condition is not true, this condition is not true. That means that we are going to call 3 times that function. So function of n minus 1 for, that is 5 minus 1, remaining parameters are as it is, plus function call with n minus 2, 5 minus 2, 3, then 1, 2, 3. Then the last function call will be n minus 3, that is 5 minus 3 is 2 and 1, 2, 3 remains as it is. For this function call now again, this condition first is false, second condition is false, as well as the third condition is false. Again we are going to call this one 3 times. That is nothing but function of 4 minus 1, that is 3, with 1, 2, 3 as a parameters. Then the second function call will be function of 4 minus 2, that is 2 with a, b, c as it is, plus last function call is 4 minus 3, that is 1, then a, b, c is as it is. Then for this particular function call now, this condition is satisfied, that is n equals to 3. What we are going to return? Return c for this function call. What is our c value is? C value is 3. That means for this function call we got a value 3. For this function call, function of 2, we have the second condition satisfies. So value return is 2 here. Value return over here is 1 because the condition, first condition satisfies. So 3 plus 2 plus 1. So it's going to give you a value 6 here. This time for this function call, n equals to 3 satisfies. So value return over here is 3. So 3 here. For this function call, value return over here is b, that is nothing but 2. So 6 plus 3 plus 2, that is nothing but value return is 11. This is how this function is going to work, and this is the tracing part of the function calls. I hope the concept of this one is clear. So let us quickly write down the same code what we are seeing it over here to run and check the test cases. Here we need to embed the code. So I'll quickly write down the conditions over here. If n equals to 1, what we need to return? Return a. If n equals to 2, return b, return c. Otherwise return what? The function call. Function name is, now when we call the function for the first time, the parameter is now going to be n minus 1 with the remaining parameters as it is, plus here it is going to be n minus 2 with the remaining set of parameters as it is, and we will place this one within the parenthesis. That's all. So for the first function call, n minus 1 plus the second function call n minus 2 and the third function call n minus 3 with a, b, c all remains same. Let us quickly check how exactly the code is. Okay, before going for that one, we need not read any values here. It is already done in the main function. N value is read, n abc value is read, and the function is called. The value returned by this one is printed over here using printf statement. So as given in the note, we need not read and we need not print the values, just need to complete this task what we have done. Let us quickly see how exactly the output is. Here is the sample test case is cleared. We got a message, n value 5, ABC, we got the output 11 as expected. Let us now submit the code. It is having maximum number of test cases, almost 14 test cases are there, including the 0 test case what we have already cleared. We got a message, congrats, you have earned your second star. To proceed further, we will click continue and proceed. That's all for now. We will see the remaining online coding challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is variadic functions in C language. Let us see the problem definition. Variadic functions are functions which take a variable number of arguments. In C programming, a variadic function will contribute to the flexibility of the program that you are developing. The declaration of variadic function starts with the declaration of at least one named variable and uses an ellipsis as the last parameter. Here is this one is a optional parameter. This is going to be the mandatory parameter, which we have already used in a function called as printf function. The task of this challenge is, in this problem, we will implement 3 variadic functions with a name sum, min and max to calculate sums, minima and maxima of a variable number of arguments. We don't know exactly how many number of arguments are going to be there. The first argument passed to a variadic function is the count, that is the number of arguments, which is followed by the arguments themselves. And here is the input format. The first line of the input consists of integer number of test cases. Each test case tests the logic of your code by sending a test implementation of 3, 5 and 10 elements respectively. You can test your code against sample or custom input. The error log prints the parameters which are passed to the test implementation. It also prints the sum, minimum and maximum number of elements corresponding to your code. And the constraint of the problem is the number of test cases will be in the range of 1 to 50 and the number of elements should be in the range of 1 to this many. And the output format is, we will be printing only this statement. Correct answer is printed corresponding to each correct execution of a test implementation and a wrong answer is printed otherwise. Say for example, if we have a sample input as 1, then for all test cases you will be getting the output as correct answer. So let us quickly move on to the code here. Here are the 3 functions what we need to implement it. Sum takes count as the first mandatory argument and ellipsis specifies the optional arguments, and test implementation by sending the 3 elements is the code provided over here. Here is sum function called and here is the main function, the number of test cases declared, reading the number of test cases and their implementation. Here if it results into true, then print correct answer, otherwise printing wrong answer. Everything is handled automatically. We need not worry about this one. We just need to take care about the implementation of these 3 functions. Now to implement a variadic function, let us recollect how many variadic macros are there. So to implement variadic function, we have a list of variadic macros. Among them, the first one is variable argument list. Next one is variable argument start and variable argument arg, variable argument end, and the last one is variable argument copy. Among this, we will be using variable argument list, variable argument start, even variable argument arg as well as variable argument end. We don't require currently this option for our implementation because we don't need any bookmark or we don't want to save the current location to come back again and access that contents. So we don't require this macro right now. So we'll be using these macros as we have already covered in our concepts of variadic macros video. Let us quickly start and write down the code. Let us see here, something is also defined here. Minimum element is defined as 1 and maximum element is defined as a big value. What is defined here, what is given here as the constraint, minimum and maximum, is already defined. So let us write down the code for adding, summing up. First thing what we need to do is use VA list. Here you can see that is automatically coming VA list. You can give any name, user defined name. I am using it, say AP, argument pointer. Declare required number of variables. For example, I required say I comma n as 2 arguments, 2 parameters. Then the next macro to be called is VA start. You can see clearly over here, VA start is now taking 2 parameters, AP, what we have just now declared as the first parameter, followed by the second parameter will be the mandatory parameter what is passed to the sum function. What is that one? Is count. So let us use that parameter count here. Initialize a variable, n assigns say 0. You can use sum also here. Sum is the name of the function itself. That's why I am taking it as n. Now we need to iterate it. Now write down the logic between start and end macro. So here is the logic what we need to put down. So from the first element till we reach the count, what we need to do here, just sum up that value. N plus is equals to, we have to use this variable argument arg. This arg will also takes 2 parameter. One is the argument pointer, another one is what type of value it is going to take. We know that it is going to take integer value, so we are going to specify integer here. You can place this code into the flower braces, and once you are done with the logic, then you can put down this macro VA end. You can see clearly it's calling up with 1 parameter argument pointer. Close this one and then return the result because its return type is integer. So I'll return n. You can see clearly here the return type is integer. That's all regarding the logic of sum, because we need to perform addition, sum of all the numbers. We have done it. Let us now move on to minima. Same thing. First declare a variable list followed by argument pointer. Now how many number of variables are required? Say I'll be using I for iteration purpose, and let us say I'll be using current to access the current element. Minimum is a variable I am using. Min is the function name, that's why I'm using this one as minimum. VA start now takes 2 parameter, AP as a first parameter and int as a second parameter. Let us define a minimum value, because what is the range we have, what exactly the maximum value we can have it is 1, 0, 0, 0, then 1. I'll define some value. Whenever I get a value less than this one, I'll store it. Let us iterate it using a loop. I less than the same count. What we have to do here is, let us take current value is equals to VA underscore argument. This will take 2 parameters. AP is already defined, and second, what type of parameter this one is going to be. The second one is integer type of parameter. Data type we have to specify. Then let us check one condition here. If you get a current value less than the minimum what we have defined, obviously for the first time it will be less. Then from the next time, whenever you get a value less, then only you have to replace it in minimum. Minimum will take the current value. That's, we have to iterate it within the loop. Once you have completed the logic, then call end. End will be called with only 1 parameter, that is argument pointer. Once you are done with this one, the result is now available in a variable called as minimum. So return this value. That's all for min function. Declare a variable argument list, argument pointer. Declare the required set of variables. I required almost the same set of variables here. Instead of minimum, here I'll be required maximum. Call VA start. VA start will take two parameters. VA start will take two parameters, AP argument pointer and the mandatory parameter what is passed, that is count. Then there we have initialized minimum to some very big value. Here we will initialize maximum to 0. We will assume maximum to be 0 and then use a for loop. Same thing what we have iterated. There we have compared for less. Here we will be comparing it for greater. So for I equals to 0, I less than count. Let us write down the same logic here. So for maximum, again the same thing, current will take for the first time VA underscore argument. AP is the first parameter and we require what type of value argument is going to take, that is integer. Let us now take a reverse condition here. If the current value is greater than maximum, here it is. If it is so, then maximum will be now replaced by the current value. Here completes the loop, and once we are done with the logic, call end macro, argument parameter and then return. That's all the code required for this three functions. Let us quickly run the code and check. There is a compilation error. Yeah, here is the error showing that we have to take count, that is the parameter what is passed in start int over there. So that was the compilation error showing int instead of count, we have taken int. Let us run the code again. Let us submit the code. It's going through the remaining test cases. Yeah, the compiler message is success and congratulations. We have earned 50 points by solving this challenge, and you can see the status here. It's 105 more points to get your gold badge, and the rank under which now we are is under 10,000 now. So it's earlier only it was 8,000, now it is 7,000. That's all regarding the variadic function challenge. We will continue with the remaining challenges in the coming videos. Thank you.
Hi. In this section, we will learn about the following. First of all, let us see what are arrays and when do we use arrays. If we recollect the data types in C language, we have covered in a separate video. There we have seen there are three categories of data types: primitive data types or primary data types. Next one is user defined data types, and the last category of data types includes pointers, arrays, structures and unions. So arrays is one among the derived data types. Let us see what exactly arrays are. An array in C language is a collection of data elements which are stored at contiguous memory locations, that is side by side, adjacent to each other. The data elements are stored in an array. Here is the example array. The array length is 9. We have 9 elements over here, and these 9 elements are stored using indexes. We call these one as array indices. The first index of the array in C language starts from 0, not from 1. So the first data element here, 40, is located and accessed using the index 0. Similarly, second data element 55 is located at second position in an array and accessed using index 1, and so on. The last element 89 is accessed using the index 8. What is the advantage of having such sort of representation is the access is faster. The accessibility of elements takes less amount of time in such representation of data elements in the memory. Assume if there are 100 elements and each element is accessed using an index, we can take the index and go to that index directly and access the data element. In the coming sections of arrays, we will look at various operations, that is, how data elements are stored, how it is declared, how they are accessed, and what are the advantages of having such representations. Elements can be accessed randomly using indices of an array. Just now what we have seen, each element is having one index. So first element is having index 0, second element index 1, and so on. The last index was 8. So each data element stored in an array can be randomly accessed. I want to access the fifth element. I'll go to that particular index and I'll access the data element. So randomly we can access the data element. They are used to store similar type of elements as in the data type must be the same for all element. Here the main concept of having array is all the data elements in an array should be of the same type. So it stores similar type of data elements and we must create an array of that type and store all the elements of that particular data type only. They can be used to store collection of primitive data types such as int, float, double, char, etc. of any particular type. An array in C can also store derived data types such as structures, pointers, as well as unions. So it is not only restricted to store the primitive data types int, float, double, char, but it also allows you to store the other derived data types as well. When we come for advanced topics of arrays, we will see an array of structures, an array of pointers, an array of unions, etc. Now comes a question, when do we use arrays? Arrays are used when there is need to use many variables containing same type of values. Say for example, if I declare a variable of some data type like integer and store one value, at any point of time in my program, if I change the value, say for example int a equals to 10 is declared, and at some point of time in my program if I say a equals to a plus 1, so the original value of a was 10, now it is overwritten with a value called 11. Now when I say again a equals to a plus 1, then again 11 will be overwritten by 12. That means that at any point of time a variable can store a single value, whereas some situation arises where we need to store multiple values of the same data type. Then we must go for arrays. Example, marks of the students. All the marks will be of the same data type. So we will create an array of marks to access, that is to store and retrieve from an array. Similarly, if I have a collection of elements to sort, 100 elements are there of integer types. So it is not a good strategy to declare 100 variables to store 100 values. Obviously, we can go for
declaring 100 variables and each variable can contain a data element. But that is not a good approach. What would be the best approach will be? C provides a derived data type with a name called as arrays, where I can store all 100 elements using a single name of the same data type, and then apply sorting technique on those particular 100 set of elements. That is something said to be a better approach. It can be defined as a sequence of objects which are of the same data type. This is a condition, you can say. That means that I can't have one element of one data type and another element of another data type. That means that what are all the elements contained in an array should be of the same data type. Okay. It is used to store a collection of data. We are performing, obviously, we are storing a collection of data elements. And it is more useful to think of an array as a collection of variables of the same type. First data element is of integer type, second data element is of integer type, third data element is of integer type, and so on up to all 9 elements what we have seen in the starting of this section contains all integer values. So I can say only one variable name I'll declare, then I can use all these 9 elements to be stored using one single variable name. So the advantage of an array is multiple data elements can be stored using a single name, and moreover the accessibility of these data elements are faster using indexes. Okay, this is just an introduction part to an array. We have lot more to see in arrays. When we see the concepts of pointers, again arrays comes into picture. When we see the concepts of structures, then again arrays comes into picture. When we see the concepts of unions, then again arrays will be coming. So we can say arrays is a very important topic with respect to C language, as well as it is one of the most popular data structure used as a base to represent the data elements. It is one of the linear data structure which stores the data elements at contiguous memory locations and provides faster accessibility of data elements using indexes. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. First, we will start with how to declare an array, then how to access the elements of an array, how to initialize an array. Once the elements are initialized, then how do we change the values, then how to perform input-output operations using arrays, and at the end we will have a sample program to understand how exactly array works. In a separate video, we have covered the introduction part of an array, that is, what is an array and when do we use an array. So in this video, we will start with how to declare an array. An array can be declared with the following syntax: data type followed by array name with square brackets open and the size specified within the square braces and square braces closed with semicolon. The name of the array is a user defined identifier. To name the identifier, we have some rules to be followed, which we have covered in a separate video with identifiers as the title. So you can give any valid identifier name here while declaring an array. Example,
int a of 5. We read this statement as a is an array which can store 5 integer values, and this type of declaration is static declaration. Means at compilation time the memory will be allocated for the variable a which can store 5 integer values. This type of array is named as one-dimensional array. Since there is only one index over here to access, we call this one as one-dimensional array. There are two things to be noted over here. The size and the type of an array, once it is declared, cannot be changed. That means that a can store at most 5 integer values and the data type is int only. All 5 elements should be of integer types only. The above declaration is static, means the memory is allocated at compilation time. There are two phases of a program. One is compilation phase, another one is execution phase, also called as runtime. The memory which is allocated for this type of array declared above is static in nature. So we call this one as a static array. Once we come to pointers concepts, we will see how do we declare a dynamic array as well. Let us see how to access the elements of array. We can access the elements of an array by using indexes. Once the memory is allocated using static memory allocation, that is at compilation time. Example, in the last declaration we have used a of 5. That means 5 memory locations are allocated and each memory location can store an integer value and they can be accessed using indexes. A of 0 specifies the first data element in an array A, then a of 1 specifies the second data element in an array, then a of 2 the third data element, a of 3 the fourth data element, and a of 4 is the fifth data element. Suppose we declared an array with named A just as above. The first element is accessed with a of 0 and the second element a of 1 and so on. Arrays have 0 as the first index. If you see carefully over here, the index by default starts from 0, not from 1. So here first data element is available and accessed using a of 0, not a of 1. If the size of an array is n, then to access the last element we use n-1 index. That is, in our example here n value is 5, so we have allocated the memory to store 5 data elements, and to access the last data element we use n-1, that is 5 minus 1 is 4, a of 4 is used to access the last data element. Now here comes the address. Let the starting address of a of 0 be some memory address, say 2000 in this case. Then the address of the next memory location will be adjacent to it, that is 2004, the next immediate memory location, assuming that integer occupies 4 bytes. So first data element occupies 4 bytes, then second data element will be stored at 2000 plus 4, that is 2004 memory location, and the next data element again is an integer, so it also occupies 4 bytes, so it will be stored at 2008, and the next one at 2012, and the last one at 2016. This is because we are assuming that integer occupies 4 bytes. If integer occupies 2 bytes, then the memory addresses would be something like this. If we assume that the first memory address is 2000, then the second one will be 2002, third one will be 2004, next one will be 2006, next one will be the memory address 2008, and whatever memory that is assigned to an array, the starting address what we have over here is called as the base address. We call this address 2000 as the base address, and the name of the array itself is the base address. When we come for pointers concepts, we will see these concepts of memory addresses in detail. So time being, I am concentrating on indexes to access the data elements, but here just I have introduced you what exactly we mean by base addresses. Base address is the memory address allocated to store the first element of the array. Therefore, the name of the array itself is the base address. Let us see how to initialize an array. It is possible to initialize an array during declaration itself. While declaring an array, we can initialize the array then and there itself. Here it is. In the last example, we have seen only this part, that is integer a of 5 with semicolon. But now, here we are proceeding one step more and declaring and initializing 5 data elements. All these 5 data elements should be of integer type. Another possible initialization C allows is something like this. That is, without specifying the size of the array, we can initialize the array. Now, a very interesting point over here is, we have not given the size here. Then, how do compiler knows how much memory is to allocated? Compiler will see in the flower braces how many data elements we are giving it over here. It will count the data elements 10, 20, 30, 40 and 50. There are 5 data elements, so memory will be allocated for 5 data elements. So the name array can now store the address such that it can store 5 data elements of integer type. Now one more thing. If we don't initialize with the values, can we declare an array without size? No. Int a of empty square brackets is not allowed without initialization. That means when we initialize it, then only compiler will come to know how much memory is to be allocated. So giving int a of empty square brackets with semicolon is a incorrect syntax or error. So here we haven't specified the size. However, compiler knows its size is 5 as we are initializing it with 5 data elements. Here is. So I'll repeat once again. There are 2 possible initializations. We can give the size of the array while giving the data elements, initializing the data elements, or size is optional when data elements are given, but size is mandatory if there are no data elements are initialized. Hope the concept is clear. Once the data elements are initialized, are they going to hold the same values throughout the program? Let us say, for example, I want to change some values in my program. Then, before changing the values, if array contains these data elements 10, 20, 30, 40 and 50, I'll perform some changes over here. That means individually I am manipulating or changing the contents of the array. A of 2 is -6, A of 3 is 19, A of 4 is 11. So after changing the values, the impact of these changes, A of 2, A of 3 and A of 4 will be something like this. A of 2 will now get
updated from 30 to -6 in the memory location 2008 used with index A of 2. Similarly, 19 will be replaced by value 40 located at A of 3 memory location 2012, and 11 will be replaced by 50 at A of 4 located at memory location 2016. Let us see how do we perform input and output operations using arrays. Let's read the values, individual data elements in an array. Say scanf is a function used to read the value. Since it is an integer array, %d is used. Ampersand specifies we are reading, and ampersand is the address A of 1 and A of 4. Printing individual values from the array using printf statement. Whatever value A of 1 contains will be printed using printf statement, and whatever value that is available at A of 4 will be printed using printf statement. Here A of 4 will be replaced with this %d. Now usually we don't perform individual reading and writing displaying the data elements, so we need to perform the reading operation in group. So how do we read the group of elements? Here it may happen that there might be 5 elements, there might be 50 elements, there might be 100 elements also. So we can't write all 100 scanf statements. So here we can use a iterative statement, that is a looping structure, any one of the loop provided by C language. In this example, we are using a for loop for I equals to 0 because the index of an array starts from 0. It is not always compulsory to start the index with 0. We can start the index with either 1 or with 4 or with any other user defined index as well. But by default, C compiler uses default index as 0. So here this scanf belongs to this for loop which reads ampersand A of I. I value will be initially 0. So A of 0 element will be read. Then I value is incremented. So it is A of 1. Next time A of 2. Next time A of 3. Next time A of 4 will be the last data element to be read in an array A. Once I++ after this will make I value to be 5. 5 less than 5 condition is false. So control comes out of the for loop. Similarly, how do we print the data elements as a group of elements? Same for loop, what we have used for reading it can be used to print the data elements as well. Only difference what we have over here is there is no ampersand which specifies the address here, directly print the value. If we use ampersand, the addresses will be. So A of I, A of 0 will be printed first, then A of 1, then A of 2, then A of 3, and the last data element A of 4 will be printed. This is most commonly used loop, for loop, for reading and writing the data because it compacts all three statements within one single line: initialization, condition checking, as well as increment. So in our programs also, whatever we will be using it, we will be using a for loop for performing input and output operations. Hope this concept is clear. And let us now move on to an example which demonstrates how the data elements are read and how they are displayed. This program is to read 5 values from keyboard and store them in an array and then print the data elements whatever we have stored. At line number 6, we are declaring an array which I have already told you at compilation time the memory will be allocated to store 5 integer values. Next, giving a message to the user to enter 5 integers. Here line number 8 and 9, just now what we have done over here,
for loop for reading all 5 data elements in an array A. I value starts from 0, so A of 0, A of 1, A of 2, A of 3 and A of 4. Once we read all the data elements from keyboard, the data elements are now stored in an array A, which we are now displaying it over here using another for loop. Before doing that, we are giving a message to the user that the displaying integers are so and so. A of 0, whatever the data element 10, 20, 30, 40 and 50 will be displayed. These are some of the basic concepts of arrays. In the coming videos, we will see different types of arrays, multi-dimensional arrays, including 2-dimensional arrays, 3-dimensional arrays. So that's all for now in the basics of arrays. We will see the remaining topics in the coming videos. Thank you. Hi, welcome to the demonstrating session of one-dimensional array. Here, to show how exactly a one-dimensional array works, we are going to implement a sorting technique named as bubble sort. Concept-wise, easiest to understand. So we have chosen this example to show how exactly one-dimensional array works. We are declaring one array of size 10 and the required set of variables are also declared. Then once after reading all the elements from the user, the actual logic of bubble sort lies here from line number 14 to line number 25. What exactly the logic behind bubble sort is? Bubble sort starts from the first element and compare that element with the next immediate element in the array. And if that element, first element, is greater than the second element, then immediately we are going to swap these two set of elements located at A of j and A of j plus 1. Here are the 3 steps for swapping. Let us take an example. I am taking an example of sorting 5 elements 5, 4, 3, 2, 1 in ascending order. The input I am assuming these elements are given in descending order from highest to lowest or largest to smallest, and we are trying to sort them in ascending order from lowest to highest, that is smallest to largest. So first time when we have 5, 4, 3, 2, 1 in an array, index 0 contains 5, index 1 contains 4, then index 2 contains 3, index 3 contains 2, and lastly index 4 contains 1. The inner for loop, that is j equals to 0 to j less than n, j plus plus, what it does is for the set of elements, it will compare all consecutive memory location elements starting from the first element till the last. So for the first iteration, when j value is 0, the if condition A of j greater than A of j plus 1 is true because 5 is greater than 4. Results in true. When it results in true, immediate instructions what we have from line number 19 to line number 23 are 3 steps to swap these two elements located at A of j and A of j plus 1. For that, we are taking a temporary variable. Temp assigns first A of j, that is 5. Temp is now storing 5. A of j now takes A of j plus 1, that is 4. So 4 is now placed at index 0. Then the last step, A of j plus 1 takes temp, will assign value 5 to A of j plus 1, that is at index 1. So in an array A at index 1, we are now going to store 5, and now 4 has placed into index 0. Immediately j is incremented, and now A of j is now, that is A of 1, that is 5 again. 5 is again greater than 3. Again true. Again swap these two set of elements. So 3 will go up, 5 will come down. Still j is incremented for one more time, so that 5 is again compared with 2. So still 5 is greater than 2. Again it is swapped with 2. And for the last time, 5 is again compared with 1. Still it is greater. So 5 is again swapped with 1. Now here completes the first iteration. Then for loop of I again increments the value from 0 to 1. That means the same steps are now going to be repeated. So in the first iteration, 5 has placed in its correct position and smaller elements are bubbling up. Therefore, the name of this particular sorting technique is given as bubble sort. Let's see in the second iteration. In the second iteration, element 4 will occupy its correct position such that the lighter elements, that is 1, 2, 3, will bubble up, and 4 will go down and sits exactly above 5. And in the next iteration, that is in the third iteration, 3 will be placed in its correct position, and in the next iteration 2 will be placed in the correct position, and all the elements will be in sorted order. So here we have seen the example with 5 elements. It may happen that this process can be done using 100 elements. Then we need to iterate it for 100 times. So these two for loops are iterating. First for loop is iterating till n times, and the second for loop is also iterating till n times. N into n, n square will be the time complexity for bubble sort. Let's build and check. No errors, no warnings. Let's run and take the same set of 5 elements here. First position I am entering 5, then 4, then 3, then 2, then 1. Sorted numbers are here 1, 2, 3, 4, 5. Let's enter for some other input elements and check. I am entering some negative elements as well. Here are the sorted numbers minus 100 to 77. They are in ascending order. These are displayed here using the sorted numbers are. One printf is used with one space. A of I, first I value takes 0. So A of 0, that is the smallest element in the array, is minus 100 to the largest element, that is 77. These are the elements in ascending order placed in an array A. So this is just a simple demonstration for one-dimensional array, and the time taken by bubble sort is order of n square. That's all regarding one-dimensional array. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to this programming challenge. Here the problem statement is sort the elements of an array in ascending order using selection sort. Here in this problem definition we have two things over here to be concentrated. One is what exactly we mean by selection sort, and if at all selection sort is applied, the order in which the elements are to be sorted is ascending order. Here the list of elements are given to us. Those who are aware with selection sort, you can apply the selection sort and sort the elements in ascending order. Those who want to know some guidelines regarding selection sort, I'll provide the solution guidelines. Then you can solve or sort the data elements into ascending order. So here you can pause the video and continue with your approach if you have the knowledge of selection sort to sort the elements in ascending order. But if you are new to this problem, then you can continue with the solution guidelines which are coming now. Let's see the solution guidelines over here. Let's try to understand first of all what do we mean by selection sort. Okay, selection sort works with a technique of selecting either the smallest element or the largest element from the unsorted set of elements. If at all we want to sort the elements in ascending order, then to sort the elements in ascending order we must always select the smallest element. Otherwise, you want to sort the elements in descending order, then we always select the largest element from the unsorted set of elements. Remember these 2 points. First point is if our requirement is to sort the elements in ascending order, then we must go for always smallest element. Otherwise, if the requirement is descending order, then we always go for selection of largest element. Okay, let's proceed over here to understand how exactly selection sort works. Let I be the index pointing to this particular element, and we find the smallest element because our requirement now is to sort the elements in ascending order. Ascending order means smallest element to largest element. This is the order in which we want the element. So first which element? Smallest element. From these given set of element, you identify which one is the smallest element out of this set of elements. We know that minus 25 is the smallest element. Mark this particular one as J. Swap I with J first, such that we will have minus 25 to be placed here and 44 to be placed here. Remaining set of elements are as it is: 12, minus 8, 5, 16, 100, 10 and 3. This was the first iteration when our I value was 0. Now increment the value by 1 such that I earlier was pointing here. Now I will be moved to this particular position because minus 25 has perfectly placed in its correct position. From this particular one, if this one is I, select the smallest element from the rest of the set of elements. We know that minus 8 is the smallest element and mark this one as J. Swap ith element with jth element, keeping minus 25 as it is. Here comes minus 8 and here comes 12, 5, 16, 44, 100, 10 and 3 are as it is. Now I value is incremented to 2 such that I is now pointing it here. So this is going to be the ith element now. From this set of elements, pick up the smallest element. Smallest element is 3. Mark this one as J and swap ith element with jth element such that minus 25 and minus 8 are as it is. In place of 12 we will get 3. In place of 3 you will get 12. What we are doing here? We are interchanging or performing swap here. How swap is done? We will see this step also. Now the remaining set of elements are as it is: 5, 16, 44, 100 and 10. Now I value is incremented to 3, and then I value is now pointing it here, such that this is going to be the ith value, and among this set of elements, smallest among this set of element is itself. 5 itself is the smallest element. Now in this scenario where I value itself is the smallest, so we mark j here and swap 5 with 5, such that 5 remains into the same position. So I value, if it is incremented to 4, now I value is now pointed by this one. From the remaining set of elements, we know that the smallest element is now pointed by j is 10. Swap these two elements, we will get minus 25 as it is, minus 8, 3, 5 as it is. Here you will get 10, here you will get 16, 12 as it is, 44 as it is, 100 as it is. Now when I is incremented to 5, I is now pointing it to this one, and j, that is the smallest element, is here. Same way, now it is going, these elements are same, not changed, as it is. I am not writing these elements. Minus 25, minus 8, 3, 5, 10 are as it is. Then here you will get 12, 100 as it is, 16 as it is. Here you will get 44. Then from this set of element, again you find the smallest element, 12 is correctly placed. Then from this set of element, smallest element is 16, so here I is going to be point here, j is going to be point here. Swap these two elements such that you will get 12 is already perfectly placed, 16 is here, 100 is here, 44 is here. Now that I is pointed by this one and j will be now pointing it, last swap will be 44 and 100, such that you will get this sorted elements as 44 and then 100. This is perfectly sorted elements. This is how the working of selection sort is. Hope with this particular logic we can write down the program. I'll give you the hint over here. When we are traversing, this requires one loop. Let us take one loop for traversal of this one, and internal, that means inside this loop we need to find the smallest element every time. That means that within this loop you required one more loop. That means that this one can be implemented using a nested loop only. That's why the time complexity for selection sort is always going to be n into n, which gives you n square. Now what is this time complexity? Is quadratic time complexity. This one is the quadratic time complexity taken by selection sort. Hope with this particular logic we can write down the program. For the solution of this programming challenge, you can watch the next video. Thank you. Hi, and welcome to the solution of the programming challenge to sort the elements of an array in ascending order using selection sort technique. Here the main requirement is we want to sort the elements in ascending order. Ascending order always starts from the smallest element to proceed it till we get the largest element at the end. As we have seen the working of selection sort, it always selects the smallest element from the given set of unsorted set of elements of the array. So what are the requirements over here in our program is, we required an array. Let's name this array as A, in which we want some n number of elements. So this is an array, this is one variable. We required one more variable, say index I, to iterate it from index 0 to index 1 to index 2 and so on up to n minus 1. I'll start with the declaration of the variables. Int say a of 10. First thing is we will ask the user to enter the number of elements. Read the number of elements in a variable. Once we know how many number of elements are there, now read those many number of elements in an array. Once user enters the elements, we will be reading the elements using a loop. Once we are done with reading of the elements, now I am going to call a function say selection with two parameters, say array and the number of elements, which is not going to return any value. So I'll just say void selection, taking two parameters over here. I'll say integer. Array name can be the same, or you can have a different array name as well. What are the requirements we have it in this selection function is we need to iterate it from the first element till the last element. So we will have a loop for that one. Let's declare all the variables upside. I, j, some more variables, we will declare it over there. Now what we required over here is we need to store the value of I in some variable. So I'll take it in j. J assigns I, then I'll iterate using one more loop. Say for k equals to from the next element immediately after I, that means I plus 1. What we need to do over here is if we find an element a of k less than a of j, then immediately we know that the smallest element is located at jth position. At the end of this for loop, we will be pointing j where exactly the smallest element is. In other words, j is now pointing it to the smallest element at the end of this for loop, inner for loop. Now after coming out of this particular for loop, we need to swap the elements. Swapping takes place using a temporary variable. So I'll be declaring a temporary variable and using a of I, then a of I takes a of j and a of j takes temp. After coming off this particular for loop, let's try to print the elements. For printing the elements also we required a loop. Let's say return. Let's see how exactly the code is. Build and run the program. Here we required the variables to be declared, so we haven't completed this task of declaration. Let's rebuild again. Enter the number of elements. Let's say I want to sort 5 elements. Enter the elements. First element, second element, third element, fourth element and fifth element. As you can see here, all the elements are in sorted order of their ascending one. This is the smallest one what we have, and this is the largest one. Here the numbers are something like this: 21, 33, 7, 1, 6. Indexes 0, 1, 2, 3, 4. I is pointing it over here. J will be first pointing it here because 1 is the smallest. Ith element is swapped. 1 is here, 21 is here, 33, 7 and 6. Next I is here. J is the smallest element here. Sorry, J is the smallest element here. Then ith element will be swapped with jth element. So 1, 6, 7, 21, 33. After the end of the iterations, you will get this set of elements in sorted order. Let's change or do some modifications to get the elements in descending order. What would be the possible changes I have to do to make the elements in descending order? Just I need to make this change as greater. You can see same set of elements. If I run now for 5 elements, 33, 22, 1, 7, 6. You can now see these same elements are now in descending order. Largest element is placed at the first and smallest element is placed at the end. The order in which we have placed this one is descending order. A very small change in the program has done the sorting in a reverse order. So if at all I am finding an element a of k greater than a of j, I am placing that index in j, then that j will be swapped over here. Let me explain the swapping process over here. Let's say we have 0, 1, 2, 3, 4, an array A. First time let us say 22 is there, then 4 is there, then 29 is there, 30 and 7. This is the index I. We know that smallest element, that is from k equals to I plus 1. I value is this one, so k value starts from here. If a of k, obviously here it is greater. Greater means the largest element. In descending order we are trying to sort this one. A of k is greater than a of j. What is j is? This is j, because we have stored j value here. I value is now stored in j, but it is not true. So k value will be incremented. Again 29 is greater. Yes, it is greater. So j will be now pointing it here. Again k will be incremented. Again this one is greater. So j is now pointing it here, but 7 is not greater. So j is now pointing it here at the end of the first iteration of this inner loop. Then we are going to swap here. One temporary variable is declared and we have these variables. Temp assigns a of I. What is currently a of I is 22. 22 will be now copied here in this memory location. Then a of j is now placed in a of I. What is a of j? A of j is 30. 30 is now placed here. Temp. What temp contains now? 22. 22 is now shifted to this memory location. That is 22 is placed here. This is how the elements are interchanged. 30 is moved to this place and 22 is moved to this particular place using these three steps. So we have seen both ascending order and descending order. So greater than is used to sort the data elements in descending order, whereas less than symbol is used, or less than element is used for sorting the data elements in ascending order for the selection sort. And the name selection sort is used because we always select either the smallest element or the largest element to sort the elements in ascending or descending order respectively. Hope the result matches with your solution. We will see the remaining programming challenges in the coming videos. That's all for now. Thank you. Hi and welcome to another programming challenge. Here is the problem statement for this programming challenge. Search a given key element in an array using linear search technique. Here we need to apply this technique to perform a search operation for a given key element in an array. Okay, let's say we have an array over here of size 5. We want to perform a search for a given key element. Then say I want to perform a search for 40. Search for 40 will be started from the first data element. 40 doesn't match over here. Then 40 is compared with the second data element. There is no match here. 40 is compared with the third data element. There is no match here. And 40 is compared with the next data element. There is a match over here. Yes, we terminate the search successfully here. Say for example, if the key element is say 40, what we have done the search. Again, if the key element is say 10, and third possibility is if the key element is say 45, which is not there in the array. For 40, we found an element over here in the 4th position of the array, and for 10, we found the data element in the 1st position itself. In these scenarios, whenever we found the data element, we need not proceed further to search the data element because we found the search successfully. Then here itself, we need to terminate the search successfully here itself. Consider for a situation, say key elements 45. 45 is not there in the array. Again, that search starts from the first data element 10, then 20, then 30, then 40, then 50. As we have compared all the data elements of the array, there is no match over here. Then here search will be terminated unsuccessfully. So there are two possibilities of searches over here. One is said to be successful search and another one is said to be unsuccessful search. These are the two possibilities of successful search, and this is a scenario for unsuccessful search. This has to be implemented using a C program. So the things what we required it, we will be discussing in the solution guidelines. But those who want to solve this problem and take this challenge, you can pause the video and pen down the logic and write down the program for this type of search. All the best for you. Those who want to look for the solution guidelines, let us continue now for the solution guidelines. Here is the technique what we are performing, it is linear search. What are the requirements we have to do it over here is, first thing is, we need to identify how many number of variables are required here. Key element what we are trying to search is 1. Another one is the array. This array A is a one-dimension array. To iterate this array, we required an index. That index can be anything, let's say I, whose initial value is 0, and when it is incremented to 1, it will be pointed over here. When it is incremented to 2, then it is pointed over here. Like that it is going to be incremented. So let us see the logic of linear searches. Give whatever key element is given to you, inputted by the user. Say for example 40 is the example what we have seen. 40 will be compared first with the first data element of the array. Since there is no match, we will increment the value of I by 1. Then we move on to the next data element and compare this key element 40 with 20. Since there is no match here, increment the value of I again to move on to the next data element, that is 30, and here also there is no match. Then now also increment the value of I. Now we got a match over here. Whenever there is a match, terminate the search here itself without proceeding further. Whenever there is a successful search, we can terminate the search without further proceeding. So this is simple solution guidelines. We will see the solution in the next video. Thank you. Hello and welcome to the solution for the programming challenge to perform a search using a linear search technique. Let's brief about the linear search technique before proceeding further. This technique, linear search, searches a given key element in an array. Say for example, in an array we have some data elements with indexes starting from 0, say 12, 15, 9, 29, 43 and 7. Say we are going to perform a search for a given key element 7. 7 is available in the array at last position, but we don't know where exactly it is located. So we will start the search from this particular position onwards, that is starting from the first position. So we required the variables are, an array is required, a variable key of type integer is required, index is of type integer because it keeps these values. Remaining procedure we have already seen in the solution guidelines. So let's quickly start the program for linear search. I'll declare an array first, integer a of some size 10. You required a variable I, required a variable key. Now give a message to the user. First thing is we will be reading how many number of data elements user wants. Based upon these many number of data elements, we will be performing a search. So we will be declaring this variable n as well here. Now we will ask the user to enter these many number of elements. Once we give a message to the user will be now entering the data elements. But these data elements are multiple. That means there are more than one data element. For this one, we required a loop. So for I equals to 0, now read it using this index a of I. Once we got all the data elements in an array, now we need to perform a search. What is that search is going to start from? Search is going to start from again an index I equals to 0. We can use any loop. I am using over here for loop. You can use while loop as well, even do while loop also. Now what we need to do in this loop is whenever we go to the first position, we will compare whether the key element matches with a of the first element. For this we have to read the key element as well. I'll be reading the key element, giving a message. Now if there is a match, we need not continue over here, and we can give a message to the user and break the loop. Element found at so and so position. We need not continue, break the loop. Say for example, if the for loop terminates without any match, then we can give a message over here. There is a problem with this code. What is that one? If the data element matches with any one of the element in the array, you will get both the messages, element found as well as element not found also, because we are using a break statement, not terminating the program. Let's see and change the program once again after running this program for one time. I'll run the program. Here found at I position, not I position, you can say I plus 1 position. Enter the number of elements in an array. Say I want to enter it 6 elements. I'll be entering the elements one by one. Say 12, 3, 7, 24, 9 and say 100. Enter a key element to search. Now I'm going to search for a key element, say 100. We got a message over here that element found at 6th position, as well as you are getting a message that element not found. Why these two messages? Because of break statement. We can avoid this printing of two statements, or when we get a message for successful search, we should not get the message for unsuccessful one, isn't it? Then we have two techniques for doing that. We will see one by one. One thing what we can do over here is we can add exit of 0. We can say exit of 0. Let's build and run. 12, 35, 61, 44, 23. I want to search for 61. Now we got a message over here as element found at 4th position. You can see after giving this message, we are not having any more messages over here. Just 61 is the key element. Yes, it is available at which particular position. You can see this is the first position, this is the second position, this is the third position, and this is the fourth position. And we are printing this particular position as value of, you can say, I plus 1, because I value is starting from 0. When there is a match, these are actually indexes. At index, this element is available. At index 1, this element is available. At index 2, this element is available. At index 3, this element is available. So we are printing 3 plus 1. That's why we are getting a message over here, 4th position. Let's run for unsuccessful search now. Say 5 elements, 11, 10, 50, 2, 63. Now I'm going to search for say 55. Now you can see you got only one message over here. What is that? That element not found. We are not getting that message of element found at so and so position. This is one of the technique using which you can perform linear search successfully. One more technique we can use instead of using exit of 0. What we can do is, I'll take a flag variable here, say variable, any integer variable. I am naming this one as flag, whose initial value I am assuming it to be 0, and whenever I am finding an element, I am changing the flag value to 1. Now after coming out of this particular loop, I'll check what is the status of the flag is. If flag is equals to 1, then what is the message? Yes, element found. One more thing I have to add it is, I have to discontinue the loop. So whenever the data element is matched, I am giving a message over here that this one, otherwise, else, give a message that element not found. This is another way of implementing linear search. Let's run this one and check. Say I want to give 8 elements now: 12, 30, 2, 65, 9, 78, 100, 45. I want to perform a search on 30. 30 is located at second position only. Yes, successfully we found the data element which is currently located over here. 30 is matched at second position perfectly. So we have seen different ways of implementing linear search using exit, which terminates the program whenever giving a message to the user, or we can make a use of this flag variable as well, whose initial value is 0 and we are changing this value to 1 whenever there is a match. And after coming out of this for loop, you can see, we will take one example over here, say 0, 1, 2, 3, 4, 5, 6. The data elements are say 30, 40, 15, 9, 12, 18 and 70. If the key element, whatever we are having over here, say for example 15 it is, and initial flag value is 0. So it's now comparing the key element 15 over here with I value as 0. So key element is not matching first of all with first data element. So I value is incremented. Next data element 40, no match. Again 15, yes, there is a match over here. That means that for I value equals to 2, there is a match. We are changing the status of the flag to 1. Coming out of the loop, this break will take the control out of this particular loop and checking the status of the flag. What is the status of the flag is 1. Yes, element found, and element is found at percentile D. This percentile D will be I plus 1 value that is to be substituted. Current I value is what? 2. So it is going to be 2 plus 1. Third position is the output what we are going to get. Suppose that there is no match. If I am trying to search for a key element, say 45, which is not there in the array, the status of the flag never changes. It will be 0 always. When this for loop completes, come out of the loop and check the status of the flag. It will show the status as 0 only. So when the status of the flag is 0, else part will be executed and element not found is the message what we are going to get. Okay, I hope linear search is very much clear for you with two different techniques we have seen. That's all for now. We will see the remaining topics and remaining challenges in the coming videos. Thank you. Hi, and welcome to another programming challenge. In this programming challenge, we are given a task of searching a key element in an array using a technique called as binary search technique. Now, what do we mean by binary search? Let me just briefly explain you what exactly this binary search technique is. Binary search is a searching technique which searches a given key element in an array provided if the set of elements in an array are in ascending order. Now, what do we mean by ascending order? Ascending order are the set of elements which are given from smaller element to the larger set of elements. Say 1, 2, 3, 4, 5, 6, so on up to, say for example 100. This may not be in this particular sequence. This set of elements can be in this sequence as well. Say for example 2, 12, 40, 50, say 65. If these elements are given in ascending order, say for example the name of the array is A and the number of elements what we have over here is 5. Now we can perform a binary search. Let me just brief you about what exactly we mean by binary search technique is. Binary search is a searching technique which calculates mid value as taking the first index as low and high as the last index. So here in our example, our low will be 0 and high index will be last fourth one, that is n minus 1. N is 5, so high value will be n minus 1 it will be. So mid will be calculated as, mid is nothing but the middle position element is calculated as low plus high by 2, absolute value. Absolute value is the integer value without any fractions. So in this particular case, say for example, if I am searching for a key element, say 40, then low is currently at index 0, high is currently at index 4. So mid will be calculated as low plus high by 2, that is nothing but 0 plus 4 divided by 2 is nothing but 4 by 2, that is 2. So our current mid is 2. Let us compare this key element 40 with the middle position element. Yes, there is a match. So terminate the search here itself. This is first scenario. Consider we are going to search for a key element, say 2. Then in this particular case, mid element 2 does not matches with 40. Then we know that the elements are there in ascending order. As the elements are there in ascending order, we know that key element, that is 2, which is less than the middle position element, we need not search the key element in the remaining part of the array. So we will continue the search in this particular part of the array. How? We know that 2 is less than 40. So therefore this high value is removed from here and high value is placed here. Again mid is calculated. This time mid is now going to be 0 plus 1 divided by 2. Now 0 plus 1 divided by 2 is nothing but 1 by 2, which is 0.5. But this one should be taken as absolute value. Absolute value means by default if we declare this variable mid as integer, then integer can store only absolute values. What is absolute value of 0.5 is? 0.5 absolute value is 0 only. So mid will be calculated and mid is now pointing it here. Now again compare. Is key element matches with mid? Yes, now there is a match. Whenever there is a match, that is key element found, we need not continue the search. That means that it may happen that instead of 5 elements, there can be 50 elements or there can be 100 elements. We need not search the remaining set of elements. For this particular reason, we maintain one variable. Say for example flag. We initialize this variable to 0. Whenever there is a match that we found a key element at this position or at this position, we change the status of the flag to be 1 and we break the loop. Now how do we break the loop? We know that breaking of loop is done with the help of a keyword called as break. Now let us consider another scenario. A key element which is greater. Say for example if it is 50. If it is 50, we need not search the key element in this part of the array. That means that if 50 is greater than 40, then change the low position. Earlier what we have done, we have changed the high position. Now we will change the low position, keeping high position as it is. So low will be now pointing it here, and now you are going to calculate this time. Mid is equals to low plus high divided by 2. That is nothing but 7 by 2 is 3.5. Absolute value you are going to get this one as 3. That means that element now found at this particular position. Consider a worst case scenario. Say for example, if I am searching for a key element which is not there in an array, then how long shall we continue this process? This particular process should be carried out until low value is less than or equals to high value. That means this will become your terminating condition. Based upon this particular condition, you make an iteration. So repeat this particular process of calculating mid and compare whether the key element matches over here or not. If not, then continue the search into either the left part or continue the search into the right part of the array. So these are the possible cases in which the binary search works. With these solution guidelines, now I want you to pause the video here and pen down and write down the logic and type the code and try to execute it. Now, if you are done with the code writing and execution, I hope you got the solution. Those who have not done, just you can watch here and you can match your solutions. So what are the requirements to the program over here is, I'll declare the required variables here. Say for example, I required the variables as low variable I required a high variable, I required a mid variable, I required a flag variable. Flag is to be initialized to 0. Yes. Other variables are also to be initialized. I required one more variable, say n number of elements. So I'll declare n. So these are the required number of variables. Let us say I required a integer variable I to iterate it. Then I'll declare it this one as I over here. First message, I'll give it to the user. Read the number of elements using %d in a variable n. These are the number of data elements in an array. We required an array as well. So declare an array of some size. I'll declare an array of size 10. Static memory allocation, I am doing it over here. You want, you can do the dynamic memory allocation as well. Give a message to the user to enter the number of elements. Now user will be entering n number of elements. We are reading it using a for loop because there are multiple number of elements. So we are using a for loop using index I. So starting index 0, a of 0, first element, next I is incremented, then a of 1, then a of 2, and so on. Now once you got the elements in an array, give the message to the user that enter the elements in ascending order. Now once you got the elements in ascending order, you need to initialize the variables. Low is initialized to 0 and high is initialized to n-1. Now these are the two initializations, and one more initialization we have already done for flag. Now we need to iterate it. How long shall we iterate? You can use any loop. I am using a while loop over here. Until low value less than or equals to high, I have to iterate it. The first thing what we need to do in this loop is calculate the value of mid. Mid is calculated as low plus high divided by 2. Since mid is an integer value, it will store the absolute value. Like we have seen already, 3.5 absolute value is 3, 0.5 absolute value is 0. Now we haven't read the key element, so let us give a message. Read the key element in a variable key. So we haven't declared that key element. Let us declare that variable here. Okay, if that key element what we are trying to search matches with your mid position, then what we need to do? Let us give a message. Here we are giving a message that element key found at %d position. What is the position? Mid position we got it. Actually mid is the index. So we will take this one as mid plus 1, because index is always 1 less than the position. And once we got the element, we will change the status of the flag, then we will discontinue the loop. Else, let us say if there is no match, then it may happen that the key element might be less than the middle position element. So if the key element is less than A of mid position, then in this scenario, what we need to do? We need to change the variable high value to mid minus 1. Otherwise, let us say if it is neither equals nor less, that means that automatically it is greater. Greater means I have to change the value of low. Low will be changed as mid plus 1. This will be continued in the while loop. After coming out of the while loop, let us check one condition. What is that condition? What is the status of the flag? Is it still remains 0? If it is 0, that means that element is not found. Because when we have found the element, we are changing the status of the flag to be 1. So it was initialized to 0. If it is still 0, that means that element is not found. So we'll give a message that percentile D not found, that is a key element is not found. Now once we are done with this one, let us build and check for any errors. Yes, there is an error over here. There is one extra semicolon. There is one extra double apostrophe. Finally, there are no errors and no warnings here. Let us run the program. Enter the number of elements. For the first time, I'll enter 8 elements. And remember, these elements must be there in ascending order. So I'll enter it as say 1, 5, 8, 10, 15, 22, 30, 45. These are the 8 elements I have entered. I want to search an element, say 30. So 30 is now located at 7th position. So 30 is currently located at 7th position. But according to the array, indexes will be, this is located at index 0, this is located at index 1, this is located at index 2, similarly 3, similarly 4, similarly 5, and this is actually 6. So we have to print at 7th position. For that reason only we have made it to print it as mid plus 1 position. So this is current mid position, plus 1 will give you 7th position. This is nothing but 8th position element. Let us run for another input values. Let's say 6 elements, 20, 50, 60, 81, 100 and 210. I want to search an element, say 81. Yes, 81 is currently located at 4th position. Here is, you are getting message, percentile D is replacing this key value here, and this percentile D is replacing mid plus 1. So this is key element and this is mid plus 1. Perfect. Let us run one more time and check for unsuccessful search case. Say for example, I have 8 elements. Among this, I want to give an element, say 56. You can clearly see over here that the key element 56 is not matching with any of these elements in the array. So you are getting a message that 56 not found. Perfect. This is how your binary search works. Let me brief the program once again. Binary search is a searching technique which searches an element on ascending set of elements or ascending order of elements. The required set of variables we have declared it over here. Initialize this one not to continue the iteration once we found the element. So this variable is used. We know that first element is assigned low index, last element is assigned high index, mid value is calculated every time, n is the number of elements, I is used for iteration, and key is the key element to be searched. And static array allocating the memory over here, reading the number of elements, how many number of elements we want it, and read each element using a for loop over here using a of I. Read the key element which we are trying to search and initialize low index and high index. Then How long shall we continue this process? This process should be carried out until low value remains less than or equals to high value. Then what we are doing in this loop is we are calculating mid value. Mid is nothing but low plus high by 2, that is the absolute value. For that reason, mid is declared as integer. Once the key element matches with the middle position, we are giving a message to the user that element found at so and so position, and we are breaking the loop. But before breaking the loop, make sure that you change the status of the flag to 1, which was initialized to 0. Our flag is initialized to 0. Now we are changing it to 1. If there is no match, that means that either the key element is less or might be key element might be greater. If it is less, then change the value of high to mid minus 1. Otherwise, change the value of low to mid plus 1 and continue the search until this condition satisfies. Now the last scenario is for unsuccessful search. What is the scenario for unsuccessful search? In unsuccessful search, the low value becomes greater than high. Then the while loop will get terminated and you will check the condition here, status of the flag. Status of the flag is initialized to 0, which was never entering into this block and changing the status to 1. So it remains to be 0 only. Once it is 0, that means that you give a message to the user that element not found. So once the condition becomes this one false, while condition become false, this condition is checked, and if the condition is true, flag equals to 0, you print and give the message to the user that element not found. That's all regarding binary search. We will continue the remaining topics in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is array reversal, that is reversing the contents of the array. Here is the problem definition. Given an array of some size n, we have to reverse it. For example, if an array contains the elements 1 to 5, then after reversing it, we should get it as 5, 4, 3, 2, 1 if the input is 1, 2, 3, 4, 5. Input format, the first line contains an integer n denoting the size of the array. The next line contains n space separated integers denoting the elements of the array. Here is the constraint. N value should range from 1 to 1000 and the array elements will be again from 1 to 1000, where ARR of I is the ith element in the array. The output is handled by the code given in the editor, which would print the array. So we need not print the array. Sample input, this is n value, these are the contents of the array. Then it should exactly reverse 12 first, 1 next, 2 next, 7, 13 followed by 16. Explanation given over here is after reversing it, we should get this particular array. Here are some of the sample inputs and sample outputs are there. Let us take this particular array, say for example. So if we take this array, it should exactly reverse the contents. Now for achieving this task, what we can do is we will take this sample. Let us say the name of the array is A and we have, say for example, 8 number of elements, and the elements are, there are many techniques we can reverse the contents of the array. One of them, we are using it now, the pointers. Let us say the base address of the array, say 1000 is the base address. We will initialize this particular base address in a pointer, say left pointer, and we will initialize the address of the last one into a right pointer. How to do this one, we will see that. Then take a temporary variable, store the contents of this one, say right pointer 11, I am storing it in a temporary variable. Once I have copied down this one, then I'll copy down this 15 into this part. So I'll write down. So I am drawing it in a separate array to show how exactly the output is going to be. We have copied down this 11 into a temporary variable. Now this 15, we will place it using this right pointer. So right pointer will take 15 and left pointer will take this temporary value, such that 11 is now swapped with 15. Increment left pointer and decrement right pointer. we have seen in pointers arithmetic how to increment and decrement the pointers. We will just say left pointer plus plus such that it will move from one memory location to another one, and right pointer minus minus such that RP, right pointer, will move into this memory location. Now the same process again. Temp is now going to take this value 5, and here this 5 we will copy it LP value here. Currently both the values are 5, so temp now again copied over here. So using this LP pointer, using this RP pointer. When I just increment one more time LP and decrement one more time RP, both are pointing it here. Currently now LP is pointing it here and RP is now pointing it here when I decrement RP. So 11 is now copied again into this, 16 will be now copied into this place, and again 11 is copied back from here. This 11 will be taken and place it here. Same thing again, incremented one more time LP and RP, right pointer, again decrement it. This time your temp will take 17 and 15 will be copied down over here, that is into this position, and then 17 is now copied into here. You can check this particular contents are exactly reversed. So this is the logic what we are going to take. So what are the requirements over here? We need a pointer, left pointer, we need a right pointer. Left pointer to initialize it to the base address, that is the address of the array. Right pointer, where it should start from? It should start from number minus 1 index. So for doing that one, we will take another for loop to iterate it from this position to this position until we reach the last position. Place the right pointer into that, and this is how the working of reversing an array. Let us quickly write down the logic into the code and test how exactly it runs. Now here write the logic to reverse the array. Here we will write down the logic of reversing an array. So what we have seen, we require two pointer variables. So that we will first of all declare two pointer variables, left pointer and right pointer. Where should left pointer point it to? Left pointer will take the address, that is the base address of the array, and we required a temporary variable as well. These are the requirements of the variables. Now we will place, left pointer is perfectly placed. Now left pointer is now pointing it to the base address, that is the starting address. Where should right pointer starts from? Right pointer will start from the last position. So for doing that, we required a loop. We will iterate it and we will check if I value is equals to say number minus 1, then right pointer will take the address of, how do we give the address of that one? Array name is ARR plus that index memory location it will take. This concept we have already covered in pointer arithmetics. Array of 7 it is pointing, so address of A of 7. So if I place star over here, this is nothing but the value located at ith memory location. So here we need the address, so we'll specify the address here. So with this for loop contents, RP is now pointing it to the last index. We need to iterate it. The movement of pointers, left pointer from left position and right pointer from right position. So let us take this one as say temp assigns temporary variable. First of all stores the value of the right pointer, and right pointer will take the value of left pointer, and left pointer will take the value of temp. This swapping we have seen. Then right pointer should be decremented and left pointer should be incremented. But question is, how long shall we continue this process? This process we will repeat it until left pointer is less than right pointer. That's the end of the while loop. We have to iterate this one until left pointer is less than the right pointer. That's all regarding the code. Let us quickly run the code and check. Yes, we got a message, it has passed the sample test cases. Let us submit the code testing for the remaining test cases. Yes, congrats. You have earned the third star, that is 100 points we have earned. To continue, we will press continue. Here we can see we have earned 20 points with this challenge. That's all regarding the challenge of reversing the contents of the array. We will continue with the remaining challenges in the coming videos. Thank you.
Hi. In this section, we will learn about the following. What are multidimensional arrays? And how many types of multidimensional arrays are there in C language? Let us start with the first one. What are multidimensional arrays? A multidimensional array, in simple words, known as an array of arrays. That means if an array contains more than one dimension, it can be 2, it can be 3, it can be 4 dimensions, or it can be any n dimensions as well. Size of multidimensional arrays. The total number of elements that can be stored in a multidimensional array can be calculated by multiplying the size of all the dimensions. Let's see here with an example. If I have an array int x 4 5 with square braces, this will store a total of number of rows here are 4, number of columns are here 5. Therefore, there are total of 20 elements that can be stored in this type of multidimensional array. Similarly, if I have x of 2, 3, 4, it is a 3-dimensional array. You can read this one in two ways. You can say 2 planes with 3 rows and 4 columns if we are reading in a row major order, or if we are reading in a column major order, 4 planes with 3 rows and 2 columns. So it is the 3 dimensions specified over here are x dimension, y dimension and z dimension. So here z dimension is the number of planes. This type of multidimensional array will store a total of 2 into 3 into 4, that is nothing but total of 24 data elements it can store. Let's see the types of multidimensional array. By default, if we create an array, it is a one-dimensional array. That means if a single index is there, it is a one-dimensional array. If there are more than one index, then we call them as multi-dimensional array. And the first form of multi-dimensional array is a two-dimension array. A two-dimension array here contains 2 rows and 4 columns, and the total number of data elements are 8, and they are stored in the form of a matrix. So 2 rows and 4 columns. Similarly, 3-dimensional array 2, 3, 5 specifies here 2 planes, 3 rows and 5 columns. If we read the data in a row major order, and 5 planes, 3 rows and 2 columns, if we read the data in a column major order. We will see what exactly we mean by row major and column major order in a separate video when we discuss about 3-dimensional array. These are the mapping techniques. So for time being, just remember that row major and column major order are the mapping techniques. Similarly, for 4 dimensions, there are 4 dimensions over here, 3, 4, 3, 2. So the total number of data elements are 3 multiplied by 4 multiplied by 3 multiplied by 2. 72 data elements we can store in this type of 4-dimensional array. Similarly,
for n dimensional array, dimension 1, dimension 2, dimension 3 and so on up to the last dimension, that is d of n. So it's up to the requirement of a program how many number of dimensions you can use it. So usually a programmer requires maximum up to 3 dimensions. Okay, we will see a separate video for 2-dimensional array and a separate video for 3-dimensional array. That's all regarding multi-dimensional arrays in C language. We will see the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about the following. What are 2-dimensional arrays? Initializing a 2-dimensional array. Accessing the elements of 2-dimensional array. And how do we perform input-output operations on a 2-dimensional array? Let us begin with what are 2-dimensional arrays. In the last video, we have seen a multi-dimensional array, and a 2-dimensional array is the simplest form of a multi-dimensional array. Normally, when we say an array with 1 dimension, it is a single dimensional array with 1 index, and a 2-dimensional array will have 2 indices to access the data elements. For easier understanding, we can see a 2-dimensional array as an array of 1-dimensional array. We have already seen the last video. What is a 1-dimensional array? So a 2-dimensional array is nothing but an array of 1-dimension array. That means that an array which can hold in each memory location one 1-dimension array. A 2-dimensional array can be seen as a table or a matrix with some number of rows and some number of columns. We can label them as, say, m rows and n columns, where number of rows ranges from 0 to m-1 and column number ranges from 0 to n-1. A 2-dimensional array named as X with 3 rows and 3 columns is something represented as follows. Here, row 0 specifies the first row and column 0 specifies the first column. Intersection of these two will be the first data element located at x of 0, 0. The first index 0 is from row and second index 0 is from column. Similarly, second data element x of 0, 1 is 0 row 1 column, the second data element in a 2-dimensional array. And the third data element x of 0, 2. 0 is from row and 2 is from column. Now this representation, what we are seeing it over here, is in row major order. Similarly, row 1 is the second row and x10 specifies second row, first column. Similarly, x11 specifies row 1, column 1 and so on. How do we initialize a 2-dimensional array? There are 2 ways in which a 2-dimensional array can be initialized. Here, while declaring an array itself, if you want to initialize, let us have an example here. x43 specifies there are 4 rows and 3 columns. That means a total of 12 data elements can be stored in this array. we can initialize all 12 elements while declaring an array itself here like this: 0, 1, 2, 3, 4, 5, so on up to 11. All 12 data elements are initialized while declaring the array. The same thing can be initialized in the following way. That is, each flower braces over here specifies that one row consists of, there are 4 data elements. That means that each row consists of 4 columns here. So there are 3 such rows. That means 3 rows and 4 columns. Any one of the initialization can be done, but the second one is more readable for a programmer or for a user to follow how many data elements are there in first row and how many data elements are there in second row and how many data elements are respectively. The advantage of having such initialization is we can exclude, that is, the number of rows, like we have done in one dimension array, x of empty square brackets we have given. Then compiler counts the number of data elements and allocates the memory based upon that. Similarly, x of empty square brackets followed by the number of columns is must. So here if I say x of empty square brackets and 4, compiler will allocate the memory by counting how many total number of data elements are there. Then it will divide it with 4. So 12 data elements divided by 4. Each row, that is nothing but 3 rows are there. So compiler will allocate the memory for 12 data elements and divides the data elements into 3 rows. But remember, second square brackets size is mandatory, that is must. Let us see how do we access the data elements of a 2-dimensional array. Elements in a 2-dimensional array are accessed using row and column indices. Example, x of 2, 1. In this particular representation, just now what we have declared, 3 rows and 3 columns. X of 2, 1 here represents the data element located at this particular position. So this is how we access the data element in a 2-dimensional array. Example, x of 0, 0 refers to the first element located at 0th row and 0th column. Similarly, x of 3, 4 refers to the element at 3rd row and 4th column, and so on. In general, x of ij refers to ith row and jth column in a 2-dimensional array X. Let's see how do we perform input and output operations on a 2-dimensional array. Here, reading, that is nothing but input operation. Earlier, when we have seen a 1-dimensional array, we have used one single for loop. Because we want to read n number of elements, we have used a loop. Now here, the data elements are stored in the form of a matrix. Therefore, we require 2 for loops. One for loop is to access row data elements. Another for loop j, which is required to access column data elements. So I index is used for accessing row elements and j index is used here to access column elements. So combination of that one, when I say scanf for the first time, a of I replaced a value 0, j replaced a value 0. A of 0, 0, that is the first element is read and j value is incremented such that 1 is less than 2. So a of 0, 1 is read, and so on. The data elements are going to be read in a 2-dimensional array. Similar to performing read operation, input operation, we can perform output operation, that is displaying of data elements can be done in the same fashion, except printf replaces now scanf. So here there is no ampersand symbol, just a of I comma j. Same two for loops, nested for loops. I is used for row and j is used for column. So these two indexes are used for accessing the data elements using row and column. Using this input and output operations, we will see the next video in which we will demonstrate how to access a two-dimensional array. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, welcome to the demonstrating session of two-dimensional array. Here we are demonstrating a two-dimensional array using a program which reads the elements in the form of a matrix of some order, say m by n, and find the sum of all the elements from a two-dimensional array. For this, the required variables are one two-dimensional array with a name A of some size. Maximum I am declaring it to be 5 by 5. User can enter any value from 2 to 5 maximum at most. If we want to give more than 5, you can give the size here more than that also. I index to iterate for row and j index for iterating through column. R here specifies the number of rows and C here specifies the number of columns. Sum is a variable whose initial value is 0. Now, why we are initializing this to 0 is because by default the storage class of int will be auto, and by default the value will be given as a garbage value. So we are initializing it to 0 over here for some variable. Let us see. The next step is we are asking the user to enter the number of rows and number of columns. Based upon the number of rows and number of columns, we are iterating using two for loops. One for loop at line number 12, iterate for the number of rows, and j for loop iterated for number of columns. Now here within the loop, we are asking the user to enter the elements for each position. So it starts from 0, 0, then 0, 1, then 0, 2, and so on. When a user enters a value here, we are reading it using scanf a of I comma j, and we are adding that value to the current value of sum, which is initialized to 0. And at the end of the two for loops, we are trying to display the sum of all the elements of the array is %d, that is sum. A simple program to just see how exactly the iterations works in a two-dimensional array. Let us build and run the program. Enter the number of rows and number of columns required. Let us say I'll give 3 and 3 as the number of rows and number of columns. So total of 9 elements we are going to enter it. Enter an element for position 0. So I'll enter it in a sequence, say 1. Then immediately you are getting a message, enter an element for 0, 1 position. So j value is incremented this time, I value remains same. So I am entering it again 2. This time you see again j value is one more time incremented, and I am reading the next element. This time when j value gets incremented to 3, 3 less than 3 is false because we have already entered 3 elements in the first row. Okay, first row elements are completed. That is 0, 0 is the first position in the first row, 0, 1 is the second position in the first row, and 0, 2 is the third position in the first row. Now starts the second row. Second row, first column, I am entering the value. Then second row, second column, and second row, third column. Now starts the third row. Third row values are first one, second one, and the third one. All 9 elements we have entered it, and the sum of all the elements of the array is, the sum of all 1 to 9 is added and placed in a variable called as sum. If you see the working over here, we are starting I value, I index as 0 here, and j value as index 0. So here 0, 0 is the first position element. So we are getting this message over here as you can see. First 0, 0, ij, first time enter the element for 0, 0. Then j value gets incremented. So here I value remains 0 only, j value gets 1. So we are entering the element over here that is read in a variable a of ij, that is 0, 1, and it is added to the previous value. Previous value was, earlier it was 0, sum was 0, 0 plus 1 is now 1. Now 1 plus 2 is 3. Next time 3 plus 3, 6. 6 plus 4, 10. 10 plus 5, like that the elements gets added, and at the end we can see the output over here. The sum of all the elements of the array is 45 is the message what we are getting it from here. The sum of all the elements of the array is sum, and the sum is now stored in a variable sum over here. Hope the concept of two-dimension array with iteration, 2 for loops, one iterating for a number of rows and another one iterating for number of columns is clear. We will see the remaining topics in the coming videos. Thank you.
Hi, and welcome to another practice program. Here in this particular program, we will see a concept based on two-dimensional arrays, that is performing addition of two matrices. We have already covered the concepts of two-dimensional arrays and how the elements of two-dimension arrays are accessed. Those who have not seen those videos, I suggest you to first watch that videos and then you can continue with the program. Here in this particular program, we are declaring maximum row value and maximum column value to be 4 using a preprocessor directive hash define. Hash define is one of the preprocessor directive. In a separate video, we have covered this particular topic as well, where there is a macro name and macro substitution over here. Wherever the name row appears in the program, its equivalent value 4 will be substituted. Similarly, macro name column, wherever it appears, its equivalent value 4 will be substituted. Like here, we are declaring row, column, row, column, row, column for all three matrices A, B and C. All these A, B and C are two-dimensional arrays of maximum size 4 by 4, and these are other variables: row 1, column 1, row 2, column 2, and these are the indexes used to access the matrix. Let us say we have a matrix A of some order, say 2 by 2, and a matrix B of order 2 by 2. Matrix addition is very much, let me just give a brief description over here. Say I have first data element over here, second data element here, third data element here, and fourth data element. Similarly, I'll be having some data elements for matrix B as well. Then a matrix C of size 2 by 2 will have this position in an array of two-dimensional array. We call this one as A of 0, 0. That means 0th row, 0th column. Similarly, this position is A of 0, 1. This one will be A of 1, 0, and this one will be A of 1, 1. Same way for B also, B of 0, 0, and this one is C of 0, 0. So if we have these basics, then it's this one is B of 0, 1. This is going to be B of 1, 0, and this one is B of 1, 1. Similarly, for C, 0, 0, 0, 1, 1, 0, and 1, 1. So first thing what we are doing here is we are reading the order of the first matrix A, that is R1 and C1. Next we will read the order of second matrix. Then giving a message to the user to enter the elements of the first matrix, like here. These are the elements of the first matrix. When user enter these values can be any values. At runtime you can decide what these values can be. So here we have to access row as well as column. So we are having one for loop for accessing row, another for loop for accessing column. So this one is for accessing row and this for loop is for accessing column. Row access, this is for column access. And when we are giving a message over here, enter the elements for %d and %d positions. User will be entering the value. We are reading each and every element at A of ij. First time 0, 0, second time 0, 1. J value is incremented, I value is as it is. Similarly, when it comes for the next one, I value is now 1, J value is 0. I value is 1, J value is 1. Once we are done using reading of A, same procedure is repeated for reading the elements for B as well. That we will see here. This message is used for reading the contents of matrix B. Here also we need row access, here also we need column access and reading the elements of matrix B. Once we are done with the contents of A and B, then we are just displaying the same information whatever we have read in the form of a matrix, tabular form. We are inputting the values something like this: 4, 3, 2, 5 for A, let us say. Same way 1, 2, 3, 4 for B. But the same information we are displaying it over here. How? 4, 3, 2, 5. This form we are displaying it over here using this /n. /n means after printing the first row, the next data should be printed in the next line. For this one we are having /n. Same way for matrix B also we are using 2 for loops for printing this information. 1, 2, then the next data is printed in the next line 3, 4. This is the content of matrix B. Once we are done by displaying the contents of A and B, now the time is to add these matrices and store it in a matrix C. Now this for loop is our addition of two matrices. Contents of A and contents of B are added. That means that A contents are 0, 0, 0, 1, 1, 0 and 1, 1. Same way for B also 0, 0, 0, 1, 1, 0 and 1, 1. Whatever be the contents over here, that will be added and placed in a matrix C over here. C of I comma j, that means that at C of 0, 0, whatever contents of A of 0, 0 is there will be added with this one and it will be placed over here. Same way, j is incremented means this content is added with this content and it is placed over here. Like that, all the data elements of matrix C is now stored using these two particular for loops. So we got the addition of two matrices in this two-dimension array C. Same contents we are displaying it over here by giving a message: the sum of two matrices is. If you observe one thing, whenever we are accessing the contents of the matrix, we are having two for loops or two loops, nested loops you can say. One for accessing row, another one for accessing columns. Every time, whether it is for reading purpose or displaying purpose or for addition also. And at the end, we are displaying the matrix C also here. We are displaying the matrix C using again 2 for loops only. I hope the addition of 2 matrices program is clear. Let us run and check the output. Let's build and run. Now the first message is enter the order of matrix A. I'll enter it as 2 by 2. Same way we are reading second order, I'll give it as 2 by 2. Now here you can see one thing. We are getting the position, enter element for 0 0 position. I'll enter it some value, say 5, 4, 6 and say 2. All 4 elements of matrix A is read, and now the message is to enter the elements for matrix B. Let's say 1, 2, 3 and 4. Once I press enter over here, you can see the first message what you are getting is matrix A is 5, 6, 4, 2 in the form of a matrix. Then the matrix B contents whatever we have read is displayed in the form of a matrix, and the sum of 2 matrices are, you can see the first data element 5 is added with 1 and it is placed over here as 6. Same way 4 is added with 2 and placed as this 6. Same way this 6 is added with 3 and placed it over here, and the last one 2 is added with this 4 to get this data element as 6. This one is also displayed in the form of a matrix, and this matrix is C matrix, and this matrix is B matrix, and this matrix is A matrix. I hope the concept of this matrices is clear. We will see the remaining topics in the coming videos. Thank you. Hi, welcome to another programming practice. Here in this particular session of practicing, we will be seeing the matrix multiplication using 2-dimension arrays. Earlier we have already seen addition of 2 matrices. Here we will see and demonstrate how 2-dimensional matrix multiplication will be. Let's assume that a matrix A is of some dimension, say 2 by 3, and B is of some dimension 2 by 4. Is this matrix multiplication possible? First question. No. As the basics of mathematics says that to multiply 2 matrices, the column of the first matrix must match with the row of the second matrix. If we name this as row 1 and column 1, this one as row 2 and this one as column 2, then C1 must match with R2. Then only we can proceed with multiplication of 2 matrices. This is the basic criteria for performing multiplication of 2 matrices. So in the earlier video, we have already came across addition of 2 matrices, how the elements are stored in matrix A and how the elements are stored in matrix B, and how addition is performed using a matrix C, where we have in detail seen how 0 0, 0 1, 1 0 and 1 1 contents are added from each and every memory location of matrix A and matrix B and placed in a matrix C. Now the first thing what we have to concentrate in multiplication of matrices is the column 1 matches with row 2? If so, then only we can proceed with multiplication. That is the basic criteria to be satisfied. So here, after reading the order of the first matrix and the order of the second matrix, the first thing what you have to check is whether the column of the first matrix matches with the row of the second matrix. If it is so, then only we can proceed. Otherwise, we says that it is incorrect data. That we will see here. You can watch here else part. Else means what? It is not of the same order. That is, column 1 is not matching with the second row. So we says it is incorrect order. We give a message and terminate the program. We will not continue. Let us say if both column 1 and row 2 are equal, same. The only thing is reading the contents of first matrix A, same procedure what we have done in addition of two matrices, and reading the contents of matrix B and displaying the contents using one for loop for matrix A. So matrix A contents are printed over here and matrix B contents are printed here using this for loop. Here is the actual logic lies. So this particular part of the program gives you matrix multiplication. Now the only difference between matrix addition and multiplication is there we just need to add the contents of 0 0 of matrix A with the contents of 0 0 of matrix B and store in C. So that we will say C of I comma j is equals to A of I comma j plus B of I comma j. That I am not writing the indexes over here, but here what we need to do is, let's assume the matrices are 1 2 3 4 2 3 6 9. Matrix C will be 1 will be multiplied by 2, then it will be something like this: 1 multiplied by 2 plus 2 multiplied by 6. What we are doing it over here, we are multiplying 0 0 of A matrix and 0 0 of B matrix. That we are doing it over here. A 0 0 is multiplied with B 0 0 and something is added over here. What is that one? Here we are adding the result of these two and storing where? So initially C of I comma j is 0 before this particular loop. That means every time we perform addition, we make this C of I comma j as 0. Then initially 0 plus this value 1 into 2. So 0 plus 2 will be here, 2 will be there. Then whatever the current content C of I comma j is there, it will be added with the next value 2 into 6, that is 12. So 2 plus 12 it will be, that value is nothing but 14. So 14 will be now stored in this particular memory location as a whole. So that C of I comma j over here now stores the value 14. For this one we required one more for loop. Other things are same here. One for loop for accessing the row, another for loop for accessing the column. And this additional for loop is used because the values are multiplied and simultaneously added also. That's the only difference in the matrix multiplication. Otherwise, everything is common. Now, once we are done with multiplication of these two matrices, the only thing left out is displaying the matrix C. So displaying of matrix C is done using again another two for loops. Contents of C are displayed over here using two for loops. This message will be given if the order of the first one does not match with the order of the second matrix. Let's test this one by build and run. I'll give first wrong order, say for example 2 by 3, and then I'll give here 2 by 4. So you can see I have given a value over here as this is going to be R1 and this is going to be C1 and this is going to be R2 and this is going to be C2. When it is not matching these values, that is column 1 is not matching with row 2, so it's giving you a message over here that incorrect order and it's not proceeding and terminating the program. Let us proceed now to enter the correct information. Say I'll give first 2 by 2 matrix, then 2 by 2 for second matrix and the elements, say 2, 3, 4, 5. For easy multiplication, I'll give identity matrix over here, that is 1 0 0 1. 1 0 0 1 matrix multiplied by any matrix will give you the same original matrix. So here you can see the matrix A contents are 2, 3, 4, 5 and matrix B contents are is identity matrix 1 0 0 1. whichever matrix multiplied by identity matrix will be giving you the same matrix. That means the contents of A will be there here. Same matrix A, that is 2, 3, 4, 5. Let us give another input and check. I'll give 3 by 2 order and B matrix is 2 by 4 order. Is it correct order? Yes, it is correct because C1 now matches with R2. Now I'll enter some elements over here, say 1, 2, 3 and say 5, 4 and 6. All 6 elements are over for the first matrix because it is of order 3 by 2 means 6 elements. Now I'll enter the elements of matrix B is of order 2 by 4. 2 by 4 means total of 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. You can see the order of matrix A is 3 rows and 2 columns, and the order of this matrix is 2 rows and 4 columns. This 2 now matches with this 2, and the resultant matrix will be is of order 3 by 4. So this is going to be 3 by 4. 3 rows and 4 columns. 1, 2, 3 and 4 columns. You can test with this multiplication. It is perfectly working. So this program is just meant for demonstrating how exactly the multiplication of two matrices takes place. Hope the concept is clear. The rest of the topics we will continue in the coming videos. Thank you.
Hi. In this section, we will learn about first, what are three-dimensional array, how to declare a three-dimensional array in C language, and how to initialize a three-dimensional array, and at the end we will see a program demonstrating a three-dimensional array. Let us first start with the first. What are three-dimensional array? A three-dimensional array is an array of arrays of arrays. Looks very strange, but the fact is it is an array of arrays of arrays. Something like this. A three-dimensional conceptual view, you can see the front part of set of elements, 9 set of elements what we have from 11, 12, 13, 14, 15, 16, 17, 18 and 19 is something referred to be as a 0th two-dimensional array. Similar to this, we call this one as one plane. Then we have similar 2 more planes which consist of again one more two-dimensional array which consists of 9 elements. Again the last one, that is second two-dimensional array. So this is just a conceptual view how we view a three-dimensional array. But in reality, the data elements are stored in this particular manner. The data elements of the first two-dimensional array from 11 to 19 are stored in a single dimension array with some memory addresses starting from 1000 to 1016. They are stored in a one-dimensional array. Again, in a consecutive memory location, that is 1018 onwards, 21, 22, 23 and so on up to 29. Again, the second two-dimensional array starts elements from 31, 32, 33 in the contiguous memory location. This is how actually the elements are stored in the memory. But how do we convert the conceptual view into the memory map? That is, the three-dimension contents to be converted into a one-dimensional array. This is carried out using a process called as mapping process. Every compiler follows any one mapping process among these two. First one is called as row major mapping and second one is called as column major mapping. In row major mapping, the elements are mapped row wise. That is what we are following it here. First row from the first two-dimension array, that is from first pane 11, 12, 13 consists of first row will be stored first. Then 14, 15, 16 constitute of second row. These elements are stored next. Similarly, the last row consists of 17, 18 and 19 will be stored next. Once we complete the first plane, then we will move on to the second plane and again row wise we will store the elements 21, 22, 23 consist of again the first row from second plane. Similarly, second row from that plane and third row from that plane will be stored into one-dimensional array. This type of mapping is called as row major mapping. Most of the compilers follow this type of mapping mechanism, which is also named as lexicographic order. Row major mapping is also called as lexicographic order. Now comes to second, column major mapping. How column major mapping is done? If at all we follow column major mapping, then the first column elements, that is 11, 14 and 17 will be stored. Then 12, 15, 18 will be stored next. Then 13, 16, 19 will be stored next into the memory. When the first plane gets completed, then we move on to the second plane and follow the same process. Mapping here are also named as order also, that is row major order or column major order. Now, how to declare and initialize a three-dimension array? We have a syntax to follow for three-dimension array declaration. Data type followed by array name. Array name can be any identifier followed by three dimensions D1, D2 and D3 placed within square brackets. Example, int a of 333. Just now seen example here. This one also consists of order of 333. Means when we read this declaration from left to right, this means that the first three indicates planes, 3 planes. The next 3 specifies number of rows and the last 3 specifies number of columns. Whereas if we follow column major mapping, then it will be read from right to left and the first rightmost 3 is the number of planes here, then next 3 number of rows, then next 3 number of columns. Here, since all the 3 dimensions are same, so it doesn't make any difference in reading. Let us see now how do we initialize a 3-dimension array while declaring an array. Here is 333. 3 planes, 3 such planes here, 1, 2 and 3 planes here. Within each plane we have 3 rows and 3 columns. So a total of 27 elements are going to be stored here. Now let us see the last part of this section, that is a program to demonstrate a 3-dimensional array in C language. A very simple program
we are using it over here to demonstrate the working of a 3-dimension array. Line number 6 specifies the declaration of a 3-dimension array with 2 planes, 3 rows and 2 columns, giving a message to the user to enter the values. Since there are 3 dimensions here, we require 3 for loops, each one having one index to access. Then within the innermost for loop, we are giving a message to the user to enter the specific number. Then we are reading the numbers and the process is repeated for 2 planes, 3 rows and 2 columns. Here in the bottom, we are displaying the same result using printf statement. Let us see the working of this by building the project, running the program. Now you can see dimension 0, 0, 0. Say I'll enter value 1. Next. Now k value has been incremented, that is the innermost for loop k value is incremented. I and j remains 0 only. So dimension 0, 0, 1. I'll enter a value 2. Then you see dimension 0, 1, 0. Then dimension 0, 1, 1. Then dimension 0, 2, 0. Then dimension 0, 2, 1. Changes 1, 0, 0. 1, 0, 1. 1, 1, 0. 1, 1, 1. 1, 2, 0. And the last one is 1, 2, 1. So all 12 values we have entered over here. Now we are displaying the values entered by the user using this particular message over here, 3-dimension. If you can see the first for loop here, here is the values. You are getting a message here, enter dimension percentile d replaces I value, then second percentile d replaces j value, then the next percentile d replaces k value. We are reading the values into first time 0, 0, 0, that is 1 we have entered. Like that, k value is incremented, so it is now 1 here, second value is incremented. When it is incremented to 2, 2 less than 2 is false. So j value is incremented to 1, so it is now again 1. So k value again starts from 0. So 0, 1, 0 value is 3 and so on. All the values are read here. Then we are trying to print the values here. So 1-dimension array requires 1 for loop, 2-dimension array requires 2 for loops. Here 3-dimension array requires 3 indexes, so we have 3 for loops here. Even for printing also we have 3 for loops. That's all regarding 3-dimension array. The remaining topics we will see in the coming videos. Thank you.
Hi and welcome to another online coding challenge on HackerRank. Today we will look at a challenge named as Dynamic Array in C. Let us see the problem definition. Here is a person's Snowhauler is the librarian at the central library of the city of Husky Land. He must handle request which comes in the following form. Here is the format in which he will be getting the request. 1 x y. If it is so, 1 is the sequence of instructions, you can say, x and y. Insert a book with y pages. Here is the second part, is the number of pages at the end of xth shelf. This is the number of shelf. Same way, if the request comes in the form of 2 here, he needs to print. If it is 1, then insert. Then print the number of pages in the yth book, that is the same thing. Print the number of pages in the yth book on the xth shelf. And if it comes in the form of third one, that is x, print the number of books on the xth shelf. Now Snowhauler has got an assistant named Oshi, provided by the Department of Education. Although inexperienced, OSHI can handle all of the queries of type 2 and 3. These are the types of queries what OSHI can handle. Help Snowhauler deal with all the queries of type 1. So Snowhauler, he himself has to deal with the first type of query that comes. So there are three types of queries here. First type of query, when X and Y, then insert a book with Y pages at the end of Xth shelf. And second query in the form of X and Y, print the number of pages in the Yth book on the Xth shelf. And the last one is X, print the number of books on the Xth shelf. So here is the first type of query what Snowhauler has to handle. Here is the required variables. First one is a dynamic array, one-dimensional array with a name called as total number of books. It is a one-dimensional array. This stores the total number of books in each shelf. Then we have a two-dimensional array. Here is a pointer to a pointer. Here it's only one pointer, so it's a one-dimensional array, one-dimensional dynamic array, and this one is a two-dimensional dynamic array. This stores the total number of pages in each book of each shelf, and the row represents the shelf and the column represents the books. So if it is in the form of a two-dimensional array, then row represents here number of shelves. These are the shelves representing. In each shelf, here are the number of books which are stored. So here column represents books and row represents the number of shelves. Here is the input format. The input format is the first line contains an integer, total number of shelves, the number of shelves in the library. The second line contains an integer, total number of queries, the number of requests that comes. Then each of the total number of queries lines contains a request in one of the three specified formats. Here is the total number of shelves should be in the range of 1 to 10 to the power 5, and total number of queries should also range in the same 1 to 10 to the power 5. For each query of the second type, it is guaranteed that a book is represented on the Xth shelf at the Yth index, and X should range from 0 to total number of shelves what is provided as the maximum. Both the shelves and the books are numbered starting from 0. That means there can exist or there might not exist a book as well as shelf. That's why it's starting from 0. Maximum number of books per shelf is allowed is 1100. So maximum what we can have is 1100 or less than that. Here is the output format. We have to write down the logic for the request of type 1. Type 1 request, what we have seen, has to be handled by Snowhauler himself, and the logic for request 2 and 3 are provided. So we need not worry about these two types of logics. If the sample input is this one, say 5, 5, then followed by the request that is coming. Let us see what do we mean by this one. First 5 means the number of shelves. Next 5 means the number of requests or the queries. Then here 1, request type 1, place a 15-page book at the end of 0th shelf. The meaning for this one is, here is given, place a 15-page book at the end of 0th shelf. Now what do you mean by this request? Request type 1, place a 20-page book at the end of 0th shelf. And here place a 78-page book at the end of second shelf. And request type 2, request type 3, here it is. 3 is just to need to print it. And type 2, number of pages in the 0th book on the second shelf is, how many are there in the second shelf? We know it is 78. That's why it is given over here as 78. Let us see, just have a look into the code here, what is given to us. Here is a one-dimensional array already declared, that is the total number of books, and total number of pages, two-dimensional array, that is already declared. Here are the required set of variables which are declared. Memory is allocated dynamically for total number of pages, memory is allocated dynamically for total number of books, reading the number of shelves, already everything is done. Here is the space where we need to provide the logic for the type of query for the first type of query. Second type of query is already done, and the third type of query that is there in else part. So let us write down the code for the first type of query. What we need first of all is the number of shelves and number of pages. So I will be declaring the variables here, say shelves and the number of pages. Read number of shelves and number of pages we have read. Now what we need to do in the first type of query is, whenever x and y are the parameters that are coming into picture here, if you can see the first type, here it is, insert at the end of xth shell. So remember this, insert a book with y pages. So here is the number of pages that are coming. So I have a variable, say total number of, you can see here, total number of queries are there, total number of shelves are there, total number of pages are there, even total number of books are also there. So we required total number of books. There I have to place in this particular shelf, I have to increment the value by 1. Then I required a book as a one-dimensional array. So I'll be declaring one book as a one-dimensional array which stores, say, total number of pages. Book contains total number of pages. In each page where I have to place that, so I have to specify that using shelf. Now I have to increment the value of the book. Now how many number of pages are there, that we have to place it into the book. So for that one we need a loop. So I'll be using a while loop, book not equals to 0. What I want is, I just want to move the pointer, number of pages what we have read, maximum the last page, say 400 is the page number. So I'm moving using a pointer, iterating it using a loop, and at the end I am placing the number of pages. That's it, what we wanted for type 1 query. So let us run the code and check. Congratulations, it has gone through the sample test case, and here is the output, and the expected output it has matched. Let us submit the code. It is going through all the test cases, 15 test case including test case 0. Yes, congrats, you have just solved all the arrays and strings challenges in C, and we have earned 40 points with this one. That's all regarding dynamic arrays in C language challenge. We will continue with the remaining challenges in the coming videos. Thank you.
Hi, in this video we are going to start a very important topic of C language. Yes, it is pointers. This feature of C language makes it very unique among all the programming languages and a very powerful tool for the programmers to handle many data structures. In this section, we will learn about the introduction part of pointers. So we will begin with, what are pointers? What is the address of a variable in C language? How to declare a pointer? And at the end, very useful for the beginners, how to access the address and value at address using pointers. Let us begin with understanding what are pointers. Pointers or pointer variables are those variables that are used to store addresses rather than values. Usually, when we say a variable can store either an integer value or a float value or a character value or any other data type. But here, when we say a pointer variable, this type of variable will not store values but addresses. So when a variable is declared in a program, then a memory will be allocated either at compilation time or at runtime. That is, let it be static memory allocation or let it be dynamic memory allocation. Some memory addresses will be associated with that variable. To access such memory address, we need a special variable named as pointers. Let us see what is an address of a variable in C language. If we have a variable x in our program, then %x will give its address in the memory. We have already used this address many times in our programs earlier than this topic, say in scanf function. Example, when we write a scanf function to read a variable, ampersand is specified over here. This ampersand means here the address. So here the value entered by the user is stored in the address of X variable. Let us see the basics, and we will start with first, how do we declare a pointer? The syntax to be followed while declaring a pointer is data type followed by star, then the variable name. Example, int asterisk ptr. Int is the data type, star indicates it's a pointer variable, ptr is a user defined variable name. You can use any other variable name instead of ptr based upon your requirement. Here ptr is a pointer variable which can store the address of an integer variable. So this declaration over here, int star ptr with semicolon, indicates that ptr is a pointer variable which can store the address of an integer variable. And at the end, let us see how to access the address and the value at address. I have a declaration over here, say int a equals to 10, which means that a is a integer variable which is initialized with a value 10, and in the memory it will be something like this, where a is the variable name, 10 is the value assigned, and with some memory address. For example, we have taken the memory address as 2000. And let us say now I am declaring a pointer variable star ptr. This will be something like this. Ptr is a pointer variable which can store the address of an integer variable. But when it is declared like this, in the memory, variable name ptr will be assigned some memory address. Here, for example, we are taking the memory address as 4590 and it is initialized with a value null. Usually, this initialization is compiler dependent. Some compilers initialized it with garbage values, and most of the compilers initialize it with a null value. Now let us say if I have a statement something like this, ptr is equals to %a, means I am now assigning the address of a to a pointer variable ptr. With this assignment statement, the memory structure will be something like this. Ptr is a pointer variable which was initially initialized with a value null with some memory address 4590. Now it is taking the address of a integer variable a. And what is the address of a is here for our example 2000 it is. So 2000 is assigned into the memory address of ptr. Yes. it will now point it to the address of 10. So there are three things over here associated with a variable A. A is the name of the variable, 10 is the value, and 2000 is the address. So we can now say 10 is a value at address 2000. Say for example, in reality, let us say A is assigned some memory address here and PTR has assigned some memory address over here. When we have PTR is equals to ampersand A, now PTR is now holding the address of A as a value in PTR memory. So it is now pointing it to this address. Let us see how do we access these values. For example, let us start with the first printf %d A. A is the value of integer type. So when we say A over here, we using %d format specifier, we will get the output as 10. If we have printf with PTR value to be printed, PTR contains not normal data, it contains the address. That's why the format specifier used over here is %p. Even we can use a format specifier %u also. This will give the address of variable A. Let us say if we are trying to print instead of PTR ampersand PTR, that means that we are now trying to access the address of PTR itself. That will result into the address of PTR. Let us say instead of using ampersand, if we write down star, star here specify value at that particular address. So what is the value located at this address? Value available at this particular address is 10. So you will get a output as 10. And when we say ampersand A, ampersand always specify address. So which address we are talking about now? The address of A. So you will get the address of A over here. When we say ampersand PTR, we will get the address of PTR. When we say ampersand A, we will get the address of A. When we say directly A, value 10 is printed and we can access that value of A even using a pointer here star PTR. This will give you value 10 as well. So this is the basics about how we can declare a pointer variable and how we can access the address and the value available at that particular address. In the coming videos, we will see the remaining topics in detail. Thank you. Hi, welcome to the demonstrating session of pointers. In the last section, we have seen the introduction part of pointers. The same thing we will see it in the form of a program. Let us declare a variable and initialize a value. Simultaneously, I am declaring a pointer variable with a name PTR. It's a user defined name. You can declare any name. Let's try to print the values. Say %d value A. Same printf statements I am using it over here, what we have seen while learning the concepts of pointers. So first printf, the value of A I am trying to print. The next printf, I'll print the value of its address. So address can be printed using the format specifier %p ampersand A. For every printf, we are using a new line operator here. Let's just use this part and we will add the code later on. Let's build. We haven't used it over here, this one. So it's giving me warning. We have not used this pointer variable. Let's not worry about it. Run. You can see here two things we are trying to print. A and its address. Let's now assign the address to the pointer. I'll copy the same printf here. Now let us say try to access using pointer variable whatever changes we have done. Let's build and run. You can see here value 10 has been printed for A. Ampersand A is the address and this 10 is using pointer, that is pointer variable star. Let us add some more printf statements over here. Just want to print ptr. ptr contains the address of A. So it has to be printed using %p. Same address, what we are trying to print it over here, the same address should be printed over here as well. Let's build. Run the program. You can see over here, first we are trying to print A value, that is 10, then address of A, then star ptr gives you the value stored at A, indirect access, that is using ptr, value available at this particular address, and again ptr, the address stored over here, same address it is printing. Now when we try to print the address of ptr, then this address will be the address of a variable ptr. Now you can see this address is different. Value 10 is printed, address of A is there, ptr, asterisk ptr 10, and ptr is the address of A, same address here, but this address is somewhat different. You can see last address what we are trying to print over here using ampersand ptr. So this one is to demonstrate the usage of address and value at address. So I'll repeat once again over here. When we are trying to print A, that is the contents of A will be printed. When we are trying to print ampersand using format specifier %p, address of integer A is printed. Then the address is now assigned to pointer variable. Using pointer variable, we are trying to access the value available for variable A. So that is printed again over here. ptr, that is the address of A, that is printed because ptr now contains the address of A. So address is printed using format specifier %p. And lastly, we are trying to print the address of a pointer variable, that is nothing but ampersand ptr, that is a different address. These two addresses are clearly different. That's all regarding the demonstration of pointer variable. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. First, we will understand what exactly the relationship exists between pointers and arrays, and then we will learn about how to access the array elements using pointers, and at the end we will demonstrate a program using arrays and pointers in C language. Let us start with the first. What exactly is the relationship exist between arrays and pointers? We have already gone through these two topics. Array is a collection of similar data elements which are located at contiguous memory locations, whereas a pointer is nothing but a special variable which holds the address of another variable. Here, pointers and arrays are synonyms in terms of how they use to access the memory addresses. That means they can interchangeably use their names when it comes to access the memory addresses. But there exists some difference between pointers and arrays. What exactly it is? A pointer variable can take different addresses as values, whereas in case of arrays it is fixed. That means that array can take only one address. That is something referred to be as the base address. In C language, the name of the array always points to the first element of the array. That is something referred to be as the base address. Let us say I have an array A of some size of integer data type. Then in the memory it will be something like this: A of 0 with some memory location, A of 1 with another memory location. Assuming that integer occupies 4 bytes, the last 2 digits is now having a difference of 4 bytes. That is, the first data element to be stored at memory location ended with the memory address last 2 digits 20, whereas the second data element stored at A of 1 with last 2 digits located at 24. The third data element can be located with the memory address ending with last 2 digit 28. The point to be noted over here is array index in C language starts from 0. Let us say we have a pointer variable star p of integer type. So p is a pointer variable which can store the address of an integer variable. Let us assign the address of this array A to the pointer variable p. Even we can assign the address in this way as well. With this assignment, a pointer p will be created which points to this memory address, and this memory address is referred to be as the base address. So currently p is also pointing to the base address as well as A is also pointing it to the base address. In another words, you can say A itself is the base address. Now P can change the address, whereas A will not change the address throughout the program execution. Let us say I want to assign some value into the memory locations which are allocated. Star P equals to 10. This assignment will assign a value 10 to the first memory location available at A of 0. So with this one, A of 0 will occupy 10. So pointer P, that is star P, now points to 10, and P is now pointing it to the base address, that is the first memory location accessed by A of 0. Say if we say P++ is nothing but a pointer arithmetic that we will cover separately. When we say P++, that means that P equals to P plus 1 will increment the next memory location. That means P is now going to point it to the next memory location, contiguous memory location. So P is now pointing it to the second memory location. So star P equals to 20 when we say, P is now pointing it to a value 20,
Since P has been incremented to point it to the second memory location, star P will now store the value at second memory address. Similarly, when we say P++ for the next time, P is now pointing it to the third memory location, and when we assign star P equals to 30, now star P is now pointing it to the data element 30. It is very clear from this particular example that whenever we are pointing it P is now pointing it to the memory location, whereas star P is now pointing it to the value at that particular memory location. So therefore you can say P is the address, star P is the value at address. Therefore, two operators over here we are using it. One is ampersand specify address, star specify value at address. Even here, star is also called as dereference operator. Let us take another example over here. Instead of taking integer array, I am taking it over here a character array. Same way, the base address of the array is assigned to a pointer variable P, which now stores the address of a character array. Here is, there are 12 characters located at A of 5, and last one is a special character named as null character. Now let us try to understand how exactly the memory location is allocated over here. A of 0 stores the first character H, which is now pointed by star P. Star P means the value located at A of 0. When we say P plus 1, we are pointing it to the next memory location, and when we say star P plus 1, the value located at that particular memory location. Similarly, P plus 2 is the next memory address, star P plus 2 is the value at that address, and so on. And the last one is P plus 11, pointing it to the last memory address, and star indicates the value null, and the value is a null character. When I say A of 1, you can interchangeably use this one as star A plus 1 using pointer. A of 1 over here is character E. You can even access the same character using star A plus 1, as well as we can even access it using star P plus 1 also. All three are same. Similarly, A of 5 is in space, which can even be accessed using star A plus 5 and star P plus 5 as well. In general, we can say A of I can be accessed using star A plus I or star P plus I or star I plus P. All are same notations. We will see how exactly this can be executed in the coming program. I am taking the same example what we have discussed just now. An array is declared of size 3. A pointer variable P is declared. Here at line number 10, I am assigning the address of the first data element, that is the base address, into a pointer variable P. Now P is assigned a value 10. Here in the following printf statements, we are trying to print the addresses. Here the first printf is printing the address of A, second printf is trying to print the address of P, and value located at the first memory address is accessed using a pointer variable. So star P is similar to writing as star P plus 0. Here we are incrementing a pointer variable to point it to the next memory address and assigning the next data element. Same thing we are repeating it over here. I am trying to print the address of A and trying to print the address of P. Now the point to be noted over here is the address of A will not change, whereas the address of P will get changed. Similarly, we are trying to print the value in two different ways. That is, A of 1 can be accessed using star A plus 1. Then again we are incrementing a pointer to point it to the next memory address and assigning the value 30. Then again trying to print the address of A and the address of P. Again, here also the address of A will not get changed. It will remain the same. Here we are trying to print the next data element located at A of 2 with index as well as pointer. Let us try to run the program. First build. First let us start with first an array is declared, a pointer is created. Here first printf, address of A is some memory address over here. Same memory address is assigned over here to a pointer P that we are printing it over here in the second printf statement. Now the value is assigned star P equals to 10, that is accessed first using pointer variable, as well as here the same thing is star P plus 0. Same value 10 is printed 2 times. Now when P got incremented here, so P memory address should be changed and the value 20 is assigned. That 20 we are accessing using star A plus 1 now, and A of 1, that is nothing but 20 is printed located at A of 1, and the memory address currently, the memory address of A remains same, whereas the memory address of P now gets incremented by 4 over here. You can see F0 here, F4. So integer is occupying 4 bytes here in this environment, and for the last time when P got incremented, P is assigned a value 30. Here it is, value 30 is printed, but before that one the memory address of A remains same. Here you can see the memory address remains same, whereas the memory address of P now got changed again from 4, now it has moved to 8. 4 byte is added. So this is just a simple demonstration program to understand how exactly pointers and arrays are linked and associated together. Okay, I hope the concept of pointers and arrays is clear. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to the online coding challenge on HackerRank. We are into our next challenge, and the next challenge is students marks sum. Let's quickly see the problem definition over here. You are given an array of integers with a name called as marks, denoting the marks scored by the student in a class. Here the alternate marks, that is marks of 0, marks of 2 and so on, denoted the marks of all boys. Similarly, marks of 1, marks of 3, marks of 5 and so on denotes the marks of all girls. The array name marks word as a pointer which stores the base address of that array. In other words, you can say marks contains the address where marks of 0 is stored in the memory, that is a base address. For example, we have an array marks with 3 marks, 3, 2 and 5. Marks stores this particular address. We call this one as the base address. Here this one is the base address that is located over here. So first marks of 0, marks of 1, marks of 2. Among this one, this marks specifies for boys, that is marks of 0. Similarly, this one for index 1 girl, then similarly for index 2 again boy. Complete the function here, marks summation. You are given an array marks. It is a pointer variable which can store the integer values. Gender, let's see what is the use of this gender is. Then
number of students, which returns the total sum. There are two types of genders: marks of boys if gender is equals to B, marks of girls if gender is equals to G. The logged code stub reads the elements marks along with gender. Then it calls the function marks summation with three parameters. First one as the array, second one as the gender, one is a character, number of students, that is the integer value n, to get this sum of alternate elements as explained above. So if input gender is say for B, we have to sum only the even number of positions, that is mark of 0, mark of 2, mark of 4, mark of 6 and so on. This is for boys. If it is girl, then mark of 1, mark of 3, mark of 5, mark of 7 and so on. Here is the input format. The first line contains the number of students, that is n number of students, denoting the number of students in the class. Each of the number of students subsequent lines contains marks. The next line contains gender. Here are the constraints. Number of students should not go out of this range. Minimum 1, maximum 10 to the power 3. Marks, minimum 1, maximum 10 to the power 3, where I value is between 0 to number of students, that is n value provided as the third parameter. Gender, either B will be given or G will be given, any one. The output should contain the sum of all the alternate marks as explained above. Say for example, if this is the input given, this is nothing but n, total number of elements. These are the contents of the array. This is available at index 0, this is available at index 1, this is available at index 2. Since the last parameter given is B, B means boy, boy means we have to sum up only these two values, index 0 plus index 2, that is going to give you 3 plus 5, that is nothing but 8. So here is the small explanation. Marks array contains, this is at index 0, this is at index 1, this is at index 2 and gender is B. So marks of 0 is 3. Another sample input, n value, this contains in an array with index 0, index 1, index 2, index 3 and index 4. If it is G, that means that this sum plus this sum it should be. So it's now going to give you marks of 1 plus marks of 3. This is correct. Here is a typing mistake. Instead of 4, we got a value here and it should be 6 since it is gender girl. And the last sample is n value is 1. Array contains only one element, that is index 0. Since it is girl, so there is no mark of index 1. So it output should be 0. If it is boy as the input value, then the result is 5. It should be. So marks of this one, gender is B, so there does not exist marks of 1, the sum is going to be 0. By taking this particular sample input, let us see how exactly we can proceed to write down the code. What we will do here is, we will just check the gender, because gender is provided as a parameter, either G or B. We will initialize a variable, say for example index I equals to 0. If we say gender is girl, then we will start I value from 1, because the array contains some set of elements. Say for example, if this is the array, then for girl, if it is, I value should start from 1. So we have initialized I value to 0. So we will start from here I value. If it is boy, then we will start with 0 itself. So 0 plus alternate values. So I should be incremented here. I plus is equals to 2. Every alternate value, this is for boy. If it is for girl, then 2 plus 4. This is going to be the summation for girl marks. I hope the concept is clear. Let us write down the code. Here is the area where we need to write down the code. Let us declare the required set of variables. We need the summation of all the values. So we declare a variable, say S, and we required I value to be initialized to 0 for iterating purpose. Gender, which is passed as a parameter, we will check. If gender is equals to say G, then we will increment the value of I. Otherwise, we will not increment the value of I. We will iterate the loop. Since we have already initialized the value of I, need not have anything to initialize. How long shall we continue? Here the second parameter, number of students, you can see number of students as the second parameter, and I value should be incremented. I plus is equals to 2. What we have to do is, whatever I value is pointing, that value from array marks should be copied down. So I'll say S plus is equals to marks of I. It will iterate within the loop and calculate the sum of all the alternate values of I, and at the end we need to return what? The value of sum, that is S. Let us quickly trace this particular one before executing it. Let us assume that, so this array is given, number of students, that is nothing but n value is currently 5 students. Gender is passed as a parameter. Let us assume that it is passed G as a parameter. So we are checking it. If gender is equals to G, what is the value of I initialized? I value is initialized to 0. Since gender is equals to G is true, we will increment the value of I to 1. Then for I equals to 1, that is from here it will start until number of students, that is this one. I plus equals to 2. S value plus is equals to current S value. We haven't initialized anything, so we will initialize this value to 0 as well. So marks of I is nothing but 2. So it's going to be 0 plus 2 is 2 for the first time. Next time I value is incremented to 2, that is nothing but 3. So now it is pointing it over here. So first time 2 is added, next time 4 will be 2 plus 4, that is nothing but 6. So when I value is now incremented for the next time, it will be 5. So 5 less than 5 is false. Comes out of the loop and say return S. What value we are going to return is 6. Consider this one is a case for, this is a case for G, that is girl. If it is boy, then I value still remains 0 only. Then we will start from here, I value, that is first one. So marks of 0, that is S is equals to 0 plus 1, 1 it is. Next time I is incremented to 2. So when it is 2, 3 is taken into consideration. 1 plus 3, that is nothing but 4. I value is 4, that is nothing but 5. So 9 it will be. When I value becomes 6, this condition fails. 6 value less than 5 is false. So when condition comes out, return S, that is nothing but 9 in case of B value passed as parameter. Currently, if it is assumed to be G, then it will return 6. Hope this one works for all possible cases, and hope this tracing is helpful for understanding the concept. Let us try to run the code and check. We need to initialize this one to 0. Let us now run the code and check. Here are the 3 sample test cases. 3 elements, 3 to 5. If it is boy, output is 8, and we got the same output as it is expected. So we got a message that it has cleared all the sample test cases. Let us submit the code. There are almost 13 test cases apart from test case 0, so 14 test cases. So compiler message success, congratulations, we have solved this challenge and you have earned 20 points, and we have covered up to 40% of this particular one. You are now 30 points away from the 3 stars, that is the 3rd star. Hope this concept is clear. We will continue with the next online coding challenge in the coming video. Thank you.
Hi. In this section, we will learn about the following. What are pointer arithmetic? How many pointer arithmetic operations are supported by C language? Working of pointer arithmetic operations, and at the end we will see a program to demonstrate the working of pointer arithmetic. Let us begin with understanding what are pointer arithmetics. An arithmetic operation performed on pointers. is nothing but a pointer arithmetic. Let a pointer variable is declared as follows: int asterisk arr is the name of the array, be an array with base address as 1000. Say this is the memory structure. ARR is a array name which is holding the base address. Assuming integer occupies 4 bytes, the next consecutive memory location is 1004 and the next consecutive memory location is 1008 and so on. ARR of 0, that is the first element, is located at base address 1000 and second element ARR of 1 is located at memory address 1004 and so on. Now here ARR is the name of the array, ARR plus 1, that is array plus 1, is the arithmetic operation what we are doing, that is memory address 1000 plus the next memory location is after 4 bytes, 1004 it is. It is not 1001, it is going to be 1004 is the next consecutive memory location for the next data element in the array. Similarly, array plus 2 means the base address plus 2 consecutive memory locations, that is 4 plus 4, because integer occupies 4 bytes here, plus 4, that is 1008 and so on. So ARR is the name of the array, also it holds the base address, that is 1000. So you can say the name of the array itself is the base address. Next, pointer arithmetic operations. A arithmetic operation performed on pointers. We have a limited set of arithmetic operations that can be performed on pointers. It may be any one among the following arithmetic operations only. What we are listing it over here. First one is increment operator. Next one is decrement operator. Next one is plus or plus equals to, that is an integer may be added to a pointer. Similarly, minus or minus equals to, that is an integer may be subtracted from a pointer. Only this set of operations are valid operations on pointers. So these are the 4 pointer arithmetic operations. Let us see the working of pointer arithmetic operations. In this example, we are seeing the working of plus plus operator. Let us say an array with 3 elements. A of 0 contains the first data element with some memory address here, and A of 1 contains the second data element with another memory address, and the last data element 30 is located at A of 2 with some other memory address. Let us see the memory address now here very carefully, because now we are interested in only memory addresses. The memory address of the second data element is 24, last 2 digits, and the memory address of the first data element is 20. So the difference over here what we are getting is 4. So in this example we are assuming integer occupies 4 bytes. Therefore first data element, if it is located at 20, then the next consecutive memory location is 24 and the next one is 28. Now PTR is a pointer variable assumed to store the base address
ending with 20. When I say PTR plus plus, that means that PTR is equals to PTR plus 1, that is going to the next consecutive memory location and pointing it to the second data element with memory address ending with 24. Similarly, one more time PTR plus plus makes the pointer to point it to the third data element with the next consecutive memory location at memory location ending with 28. The remaining operations we will see as a program which demonstrate the working of pointer arithmetics. Here is the example which is demonstrating the pointer arithmetic in C language. At line number 5, we are declaring two arrays and we are declaring two pointers, and an index I is used in the for loop to iterate. The first for loop is asking the user to enter the elements in the first array. Once we enter the three data elements here from 0 to 2, A of 0, A of 1 and A of 2, base address is now assigned to a pointer variable P. So the base address of A is now stored in a pointer variable P. Similarly, we are reading the data elements in an array B by using a for loop, and the base address of the first data element is stored in a pointer variable Q. These printf statements are trying to print the addresses. Here the address of P is printed, that is a pointer variable, and the address of A, that is a base address, is printed, and Q, that is the base address of B. So here these two addresses must be same and these two addresses must be same. Let us now see here, we are trying to print the value at A of 0, that is using asterisk P. So star P or asterisk P now stores the first data element of the array A. When we say P++, that means that we are now pointing it to the second memory location and trying to print the value. Similarly, for the second array B, we are printing the first data element and making Q++ to point it to the next data element and printing that particular value. Let us reinitialize P to the base address of array A. Now I am doing P plus equals to 2, that is I am incrementing P value with 2. Now it is pointing it to the third data element in the array. So now I am trying to print the value at P plus 2 is printed with star P. Similarly, if I decrement it, it gets back again to the first data element in the array A. So now when we are trying to print it, it's going to print the value over here. Now again, I am reinitializing a pointer P to the first data element of array A and Q to the first data element of B. And plus operation is performed on the first data element of array A and the first data element of array B, because star P holds the first data element of array A and star Q holds the data element of array B. Similarly, subtraction is done. Similarly, multiplication is done. Let us build and run the program. Let us see here, we are getting a message from the user for the first time to enter the data elements. First data element I am entering it as 5. For the second time in the for loop, I am getting the same message. I am entering another number over here. Then for the third time, when I value is 2, A of 2, that is I am entering another data element over here as 6. This for loop gets completed first. Now P is holding the address of the first data element, that is 5. Now we are getting this message, enter the element for second set. When I value is 0, that is I am entering the first data element over here. For I value equals to 1, I am entering the second data element. For I value equals to 2, I am entering the next data element. If you see carefully over here, now we are getting messages, say the address of A is using P, we are trying to print the address, and the address of A, both are same currently. Similarly, the address of B we are trying to print using Q as well as B, both are same. Let us now see A of 0 value is star P, that is the first value. First data element is 5 over here. A of 1 is the second data element. Similarly, B of 0 is the first data element in the second array. B of 1 is the second data element in the second array. Now concentrate over here, P plus 2, that is base address is pointing it to the address of P, that is this base address. When I say P plus 2, it is now pointing it to the third element. Third element of which array? First array A. So now we are getting third element of this one, first array, that is 6. Now when we say P minus equals to 2, it is getting back the pointer to point it to the base address. So when I print it over here, A of 0, we are getting 5. Lastly, when we perform star P plus star Q, that means 5 plus the first data element of A and the first data element of B is added and 7 is the result, and the minus that is subtracted, 5 minus 2 is 3 over here, and 5 multiplied by 2 is 10 over here. Okay, this is about the pointer arithmetic in C language. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. What is pointer to a pointer? How to declare a pointer to a pointer? And at the end, a program to demonstrate the concept of pointer to a pointer in C language. Let us start with what is a pointer to a pointer. In the last video, we have seen the introduction part of a pointer. A pointer is nothing but a special variable which can hold the address of another variable. Here, when a pointer holds the address of another pointer, then such type of pointer is known as a pointer to a pointer. It is also called as double pointer. Let's have an example over here. We have an integer variable I, which is initialized to a value 5 and assumes to have a memory address, that is I is located at a memory address 1000. If we declare a pointer 1, that is ptr1, which is now holding the address of a integer variable I, then the contents of ptr1 is 1000 and ptr1 is having its own memory address. Let us assume that it is 2000. Now ptr2 is a pointer to a pointer, which is now holding the address of ptr1, that is 2000, it is holding the address, and ptr2 is having its own memory address. We are assuming it to be some 3000. So here I is a normal integer variable, ptr1 is a pointer variable, which is holding the memory address of a integer variable I, and ptr2 is a double pointer which is holding the address of the existing pointer ptr1. A double pointer has two basic meanings. First one is of a pointer to a pointer, where changing the value of a double pointer will result in the original pointer being changed. That means that if we change the value of the second pointer, obviously it results into the change in the original pointer. Another is that of a two-dimensional array, such as a matrix or a list of character pointer. When we declare a single pointer, it acts as a one-dimensional array, whereas if we declare a double pointer, it acts as a two-dimensional array, or you can say a list of character pointers. The example of such character pointers we will see when we come for a topic command line arguments, where main function takes two parameters or arguments, argc and argv. Argc will give you the count of the number of arguments, and argv is a two-dimensional array which contains the number of parameters, which contains the names of the arguments. Now let us see how to declare a double pointer. Its syntax is data type followed by two asterisks, then variable name followed by semicolon. If you remember, when we have declared a single pointer, then one asterisk is used, and now since it is a double pointer, we are declaring it with two asterisks. Example, say an integer variable is there which is initialized to a value 5. A pointer variable ptr1 is declared. Now a double pointer with two stars, that is two asterisks, are declared. Let us say now when I say ptr1 now assigns address of I, that is ptr1 is holding the address of a integer variable I, and ptr2 is now holding the address of ptr1. That is, when we declare int asterisk ptr1, then memory is allocated for ptr1 as well. That memory address is assigned into ptr2. So now ptr2 is holding the address of a pointer variable, and ptr1 is holding the address of an integer variable. Therefore, we call ptr2 as a double pointer. The same example what we have seen, I is an integer variable which is holding a value here with some memory address, and ptr1 is a single pointer holding the address of I, that is 1000 here. ptr2 is now holding the address 2000, which is the address of ptr1. And the last part of this section is a program to demonstrate pointer to a pointer. Here is a simple program. Same one integer variable, we are declaring it over here and initialized with a value 10 at line number 7, and at line number 8 a pointer variable is declared and a double pointer is declared at line number 9. Now p is taking the address of a normal variable, and pp, that is a pointer to a pointer which is declared with double asterisk, is now holding the address of a pointer variable. From line number 13 to line number 15, we are trying to print the value 10 using different methods. First one, at line number 13, we are directly displaying the value of A. Value of A is percentile D replaced by A, that is 10. And line number 14, value of A is indirect access of element 10 using a pointer variable star P. Since P is holding the address of A, we are accessing the value at address using star operator. And the last one is same value 10 is printed using double pointer as well. Since PP is holding the address of P and P is holding the address of A, we can access it using double asterisk and print the value. And from line number 17 to 19, we are trying to print the address of the same integer variable in three ways. Here percentile P is used as a format specifier to print the address. First time ampersand A means address of A. P is holding the address of A, again the same address will be printed, and PP is holding the address of P. So indirectly when I say star PP, that means value available at P. What is the value available at P? Address of A. Let us see the running of this program. No errors, no warnings. Value of A is A, that is 10. Value of A is percentile D using star P, the same value 10. And the value of A is percentile D using double pointer, the same thing. And also the memory addresses, that is the memory address of an integer variable A. The usage of double pointer will be there in the data structures like linked list, and when we access the data structures like trees and graphs using linked representation, then the concept of pointers and pointer to a pointer will comes into picture. As well as whenever we want to allocate the memory dynamically for one dimension array, we can use a single pointer, and whenever we want to allocate the memory dynamically for two-dimensional array, then we can use a pointer to a pointer. That's all regarding pointer to a pointer concepts in C language. We will see the remaining topics in the coming videos. Thank you.
Hi. Now we will see a program to demonstrate the parameter passing mechanism called as call by reference, also known as call by arguments. C language supports two types of parameter passing mechanisms. One is call by value, another one is call by reference. In call by value parameter passing mechanism, the actual parameter values will be substituted into the formal parameters, and whatever change we do it in the function using formal parameters, that will not reflect back into the called function. That is, formal parameter changes does not affect the actual parameters. Therefore, here the concept of call by reference, what it does is it uses pointers. Whatever changes we do it for formal parameters, that will reflect into the called function actual parameters. We are using a program to swap two numbers using pointers. At line number 4, there is a function prototype with a function name called as swap, taking two parameters, both of integer pointers, and in the main function
before calling the function swap, we are reading the values from the user and displaying the same before calling the function and after calling the function as well, to see how exactly the effect of formal parameter will be there in actual parameters. Here at line number 11, there is a function call to a function swap with two parameters, the address of the first number and the address of the second number are passed as the parameter. Whenever we pass the addresses, we required pointer variables at the other end to accept those addresses or to hold the addresses, because normal variables cannot store addresses. So we require pointer variables here. So whenever there is a function call at line number 11, control goes to line number 16 to execute the function swap. Now in this particular function, we are using one temporary variable. In that temporary variable, we are storing the first value star x. Star indicates value at address, whereas ampersand specifies address. So we are swapping the numbers over here. Okay, temp stores first value takes second value, and second value takes the value of temp. Thus they swap the values over here. We are printing the values of number 1 that is there in star x and number 2 that is there in star y in swap function after swapping. And when the control goes back again to the calling function, that is after executing the function swap, the control goes to line number 12. At line number 12, again we are giving a message in main function after swapping number 1 and number 2 values. Very simple example to understand how exactly pointer works. Let us see the execution by running the program, asking for the user. Here is the main function. Enter two elements for swapping call by reference mechanism. We are reading two numbers over here, 20 and say 30. So now number 1 stores the address of 20, number 2 stores the address of 30. So before swapping, we are trying to print the values here, then swap function is called. Let us see how the execution will be. Here is the message before swapping number 1, here 20 and 30. Now the control goes to swap function. Let us see what happens in swap function. When control goes to swap function, address of number 1, that is address of 20, is taken in a pointer variable x, and address of number 2, that is there in variable y. Whenever we say just x and y, these are the addresses, but when we say star x and star y, these are the values. So we are swapping it over here. First time temporary variable is created here. When temporary variable is created, 20 is copied into temp, 30 is copied into x, and 20 is now copied into y. So in swap function, we are trying to print it over here. Numbers got swapped here. You can see 20 got replaced with 30, 30 got replaced with 20. Now after executing this one, when the control goes to main function, we are trying to print the same message over here, main after swapping number 1 and number 2. You can see in main function after swapping we get the same result. But what happens if it is call by value? Let us see the changes over here. What would be the changes? We have to do it to understand the importance of call by reference is, I'll just make this one as star, I'll remove from all places. So it will become call by value parameter passing mechanism. Here also in the prototype, I am removing all stars. Now what happens here? Value is substituted. Let us build and run the program. Same input I am giving it here, 20 and 30. Now you see, in swap function, in main function before swapping is 20 30, in swap it is swapped 30 20, but in main after swapping it gets back again to 20 and 30. This effect will not be there here. You can see values printed over here are 20 and 30, whereas if we use pointer variables, so let us make it again pointers. Whenever pointers are passed, addresses are used. So these are the changes I have to do. So you also practice this using different examples. Let us see these changes here. Save this one, build, run the program. I'll use a different input values, say 400 and 320. You can see 400 and 320 got swapped here, and in main function also it gets reflected. This is the advantage of using call by reference. Very useful mechanism provided by C language. That's all for this section. We will see the remaining topics in the coming videos. Thank you.
Hi, and welcome to the practice program session for new parameter passing mechanism in C language. Here we will learn the second parameter passing mechanism, that is called as call by reference. Whenever we say call by reference or call by address, there comes a concept called as pointers, because addresses can be stored by a special variable, something referred to be as pointers. How exactly the working of call by reference parameter, how exactly the working of this parameter passing mechanism is? It will be something like this. These are the actual parameters A and B with some memory addresses assumed to be 1000 and 2000 here. These are the variables available in calling function. In called function, these parameters are known as formal parameters. Here in call by reference or call by address, the address of the actual parameter will be passed. So whenever we pass the address, who will hold the address? Here pointers will hold the address. So x and y are of pointer type. They are now going to hold the memory addresses of A and B respectively, where x and y will have some memory addresses of its own. We are not interested in this one. So here x is now holding the memory address 1000 and y is now holding the memory address 2000. Let us recollect quickly what we have done in call by value mechanism. We have a function called as swap, where we have used one temporary variable to swap these values A, and A assigns B and B assigns temp. Is it not? Yes. Here also we will have a function swap. That function swap we are writing it here. That is the called function swap. This one is, and within this one we are naming this one as say x and y. Okay. So let us label this one as say x, this one as x, and this one as y, and this one as y. Now when we pass the memory address, who is going to hold the memory address? X. Who is going to hold the memory address is a pointer. So x is a pointer variable and y is also a pointer variable. So how do we declare that one? We declare it something like this: x integer star y as the parameter for which function? Swap function. So when we want to swap these two elements, we have one temporary variable. So let us declare that temporary variable. I am now having one temporary variable. Is of what type? Again integer type. What type of? A and B are the same data type. When we are going to swap these values, temp assigns x. What x contains now? 1000. But 1000 is the memory address. We don't want the memory address to be swapped. We want the value available at this particular memory address. So we will write down here x is there. X means 1000. So I'll prefix star before this. When I say star x, that means I am accessing the element available at that memory address x. that will be now copied into temp. So now what is the value copied into temp is value available at memory address X, that is 20. Then I'll say Y means 2000 memory address. I don't want 2000 memory address to be swapped. I want the value available at memory address 2000. So I'll again prefix star. Star Y should be copied into star X. That means 30 should be placed here with this statement. Then the last temp will be now copied into B, that is Y memory address. So it should be again star. So 20 will be now copied into this memory location. So swapping will not takes place here in the called function. Swapping will takes place here in the actual parameter memory address only by taking the reference. That's why this one is also called as call by reference parameter passing mechanism. So before calling the function swap, if you try to print the data elements, you will get 20 and 30. In the swap function, you want to print the data element, you will get 30 and 20. After calling the function, again when you come back to the calling function and tries to print the values, you get again 20 and 30. This is going to be the output what we should get it when we are using parameter passing mechanism. Hope the concept is clear. Let us write down the code for this one and execute and test. Required number of variables, A equals to 20 and B equals to say 30. We are trying to print the numbers before calling the function swap. Let us call the function swap here with addresses of A and B. How do you pass the address? Address is passed using ampersand. Ampersand A comma ampersand B. Addresses of these two will be passed. We'll give a message in main before function is called and after function is called. Now let us try to write down the swap function. Swap function return type is void, takes two parameters. First parameter is also a pointer and second parameter is also a pointer because we are passing the addresses. So declare two pointer variables as the formal parameters. Declare the required variables. Here we required a temporary variable. Now the swapping steps are temp assigns. When I say X, it will be the memory address. So I'll prefix the value. So star prefixed will be the value stored at that memory address. Then I'll say star X assigns star Y. These values are swapped and the last step is star Y should hold the value of temp. Let us try to print and give a message here. So this is going to be the output in swap function. So what we are doing here, trying to print and check the values before calling the swap. Then calling swap will take the control here, passing the address, swapping the contents, trying to print the elements here, and then after coming back into main function, we are trying to print and check the values whether they have reflected the changes here or not. Let us build. Okay, here is a missing comma for these two lines. Let us build and run. Star X and star Y should be the output here in the function, and the output is in main function before calling swap numbers are 20 and 30. In swap function the numbers are, yes, they are swapped here, and in main after the swap is called they are now going to have an impact and the changes are reflected back into the calling function because of the address and reference. So here is a program to clearly demonstrate how exactly call by reference works with the help of pointers. Hope the concept is clear. We will continue with the remaining topics in the coming videos. Thank you.
Hi. In this section, we will learn about the following. What are void pointers? What is null pointer? Then what is a near, far and huge pointers?
Let us start with void pointer. The void pointer in C language is a pointer which is not associated with any data type. Like if we want to declare a pointer of integer type, then we can declare it as int asterisk variable name. That can store the address of an integer variable only. If you want to store the address of a float, then you declare a float pointer. Similarly, to store the address of a string or array, we have separate declaration. But situation arises where we have to store the address of any variable in a pointer. In such case, void pointers are very useful. It points to some data location in the storage, means points to the address of variables. It is also called general purpose pointer. As I said that it is not meant for a specific type of variable to store the address. We can assign the address of any data type to this type of pointer. In C language, when we see the dynamic memory allocation functions, malloc, calloc, which is used for dynamically allocating the memory, they returns void pointers. Then in that case, we have to typecast it to a specific type of pointer. So these are generic pointers. Void pointers are useful in those situations where we are not sure about the address of the data type. So we can declare a void pointer and it acts as a generic pointer which can store the address of any data type. Next is null pointer. The word null is a constant in C language and its value is 0. In case with the pointers, if any pointer does not contain a valid memory address or any pointer is uninitialized, so that means that when pointer is not given any address, it is not pointing it to any address, we says it is a null pointer. So currently a pointer is not holding any memory address, that pointer is a null pointer. We can also assign 0 or uppercase null to make a pointer as null value explicitly. Let us come to the next type of pointers. There are three categories of pointers are there, which are some old concepts used in 16-bit Intel architectures, where in MS-DOS operating system, programmers used to allocate the memory and access it using near, far and huge pointers. They are not currently that much useful, but anyhow we will see the concepts over here. Near pointer is a pointer which is used to point to the bit address of up to 16 bits in a given section of the computer memory, that is 16-bit enabled. The main drawback of near pointer is it can only access the data of a small size, say about 64 KB in a given period of time. In the memory, it will be something like this. Say a near pointer is now pointing it to the data segment. So near pointer cannot access beyond the data segment, like we have the contents like graphics video, we have like graphics video memory, text video memory, etc. Near pointer cannot access those memory, and the size of near pointer is 2 bytes. C allows you to make any pointer to be a near pointer with the help of a keyword near. These are all the segments, memory segments over here. Near pointer can access only up to this data segment. It cannot access beyond that data segment memory. Then we have two more categories of pointers. There is a small difference between far and huge. Let's see over here. Far pointer is a 32-bit pointer. Can access information which is outside the computer memory in a given segment. Now to use this pointer, one must allocate a sector register to store data address in the segment, and also another sector register must be stored within the most recent sector. We have the memory divided over here in the form of segments. Far pointer now can point
to a 32-bit address even outside the computer's memory. Now, this one is fixed in nature. Far pointer, you can say it is a static type of pointer, whereas huge pointer on the other hand has the same size as the far pointer, and it can also access the bits that are located outside the sector. Here comes the difference. Far pointer, which is fixed, and hence that part of the sector in which they are located cannot be modified, whereas huge pointers can be modified. That is the advantage of huge pointer over far pointers. Representation wise, they are the same. That's all regarding the concepts of the miscellaneous pointers in C language. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will learn about the following. First, we will try to understand a concept, something referred to be as dynamic memory allocation. So, what do we mean by dynamic memory allocation in C language? Then, there are some functions to allocate the memory dynamically. We will see how many dynamic memory allocation functions are there in C language, and with brief details about each one, along with examples to understand how exactly the memory is allocated. Let us first begin with understanding what do we mean by dynamic memory allocation. Consider the following array. I have a character array of size 12. A pointer is declared and assign the base address. Each memory location is holding one character over here, and there are 12 memory locations. Now this type of memory, what we are declaring it over here using char a of 12, is memory allocated at compilation time. That is, this type of memory allocated is at compile time. Now the feature C provides is dynamic memory allocation, refers to performing memory management through a group of functions in the C standard library manually, that is allocating the memory at runtime. Some of the C standard library functions which are used to allocate the memory and deallocate the memory dynamically are malloc, calloc, realloc and free. Their performances varies in both execution time and required memory. That means each function will have their own execution time and each will have a different memory allocation scheme. To use these library functions in our program, they are actually defined in a header file called as stdlib.h. So we need to include this header file in our program whenever we are using this C standard library functions malloc, realloc, calloc and free. Let us first try to understand what exactly we mean by malloc. Malloc or memory allocation, full form of malloc is memory allocation function, is used to dynamically allocate a single large block of memory with the specified size. You can specify the size of memory block in terms of bytes. It returns a pointer of type void which can be cast, that is typecast, into a pointer of any form. We have seen in a separate video with a topic miscellaneous types of pointers or other pointers, where we have discussed what exactly a void pointer is. Void pointer is a generic type of pointer which can hold the address of any data type. So currently malloc function returns a pointer of type void which can be casted into a pointer of any type. Syntax for declaring a malloc function will be something like this. Pointer assigns, here comes with parenthesis typecasting, malloc bytes, number of bytes, you can specify it over here if you know exact number of bytes, or if we don't know exact size, then we can call size of operator to calculate the size and allocate the memory dynamically. Example, pointer assigns typecasting here malloc 100 into size of integer. In one environment, integer may occupy 4 bytes or integer may occupy 2 bytes. There, if we are not certain about the size of integer, then we can call size of operator, which calculates the size of the data type specified multiplied by 100 over here. These many number of bytes of memory will be allocated, and the first memory address, which is called as the base address, will be assigned to PTR. But here, if PTR is of integer type, we have to typecast it because malloc function returns void pointer. So this is must. Typecasting is must whenever we use malloc function. Since the size of integer is 4 bytes, we assume over here, this statement will allocate 4 into 100 will be 400 bytes of memory, and the pointer PTR holds the address of the first byte in the allocated memory. Consider an integer pointer is assigned the memory address of the first byte allocated by malloc function, which is taking parameter as 5 into size of integer. Let us assume that the size of integer is 4 bytes. 4 multiplied by 5 will be 20 bytes. Here typecasting is required because malloc function returns void pointer. We are now typecasting it and then storing the address into PTR, which is a integer pointer. Now this function allocates a block of memory, and PTR is now holding the first block among the 20 bytes of memory. A block of 20 bytes is dynamically allocated, among which PTR is now holding the base address, that is the address of the first byte. Make a note over here, whenever malloc function is used to allocate the memory dynamically, then the memory from heap will be allocated. Let us assume that if there is not sufficient memory available, then null will be returned. So PTR will be holding a null value. We have already came across this type of pointer in the earlier video with a title miscellaneous types of pointers. The next category of dynamic memory allocation function is calloc. C stands for over here contiguous allocation. Calloc or contiguous allocation function is used to dynamically allocate the specified number of blocks of memory of the specified type. It initializes each block with a default value of 0. Unlike malloc, it initializes each block with a default value 0. There is a small difference in the syntax when compared to malloc. Malloc just take the size in bytes, whereas here we are specifying n, element size. Example, say calloc is now taking two parameters, 25 and size of float. If float takes 4 bytes, 4 multiplied by 25. The calloc function allocates contiguous space in memory for 25 elements, each with the size of the float. So the total memory allocated will be 25 multiplied by 4 bytes, that is going to be 100 bytes. And the address of the first byte will be stored in a pointer variable PTR. If PTR is assumed to be of float type, then we required a typecasting here. Let us see with an example. Calloc with 5, size of integer. If we assume the size of integer to be 4 bytes, and typecasting is must because calloc also returns void type of pointer, then here Each one occupies 4 bytes. Total of 20 bytes of memory is allocated, where each block is now occupying 4 bytes, and the address of the first byte will be stored in a pointer variable PTR. 5 blocks of 4 bytes each is dynamically allocated at runtime, that is at execution time. Same thing here, if there is no sufficient space available from the heap memory, then a null value will be assigned to the pointer PTR. And the next one in the sequence of dynamic memory allocation is realloc. Realloc or reallocation function in C is used to dynamically change the memory allocation of a previously allocated memory. That means that if already some memory is allocated by either malloc or calloc, then if that memory is not sufficient enough, then we can reallocate the memory with a new size using realloc. If the memory previously allocated with the help of malloc or calloc is insufficient, then realloc can be used to dynamically reallocate the memory. Here is the syntax. Realloc takes two parameters, a pointer with new size. Example, pointer with 10 into size of integer. Let us say if malloc function is already used to allocate this memory and this memory is not sufficient, 20 bytes of memory is not sufficient right now, we want to change the memory structure, then we can use realloc function something like this. I am using the pointer variable as a parameter, first parameter, and the second parameter is the new size, 10 multiplied by size of integer. If we assume integer takes 4 bytes, then a block of memory of 40 bytes is allocated and the address of the first byte is now stored in a pointer variable. So the size of pointer is now changed dynamically from 20 bytes to 40 bytes. You can even change to any size. Again, if there is not sufficient space available, then pointer holds null value. The three dynamic memory functions, malloc, calloc and realloc, all are something referred to be as memory allocation functions, whereas free is a memory deallocation function, that is whatever memory that is allocated by malloc, calloc and realloc should be released by using free function. So free is a function in C language which is used to dynamically deallocate the memory, that is release the memory. The memory allocated using the functions malloc and calloc is not deallocated on their own. It is programmer's responsibility to use free function to deallocate it. Whereas in a programming languages like Java, there will be a concept of garbage collector where garbage collector is automatically invoked and the memory will be released. In C++, delete is a function which is used to deallocate the memory. Here in C language, free is a function which is used to deallocate the memory. Therefore, free function is used whenever dynamic memory allocation takes place. It helps to reduce wastage of memory by freeing it. So it is programmer's responsibility to use free function whenever either any one of the function is used in the program, that is among malloc, calloc or realloc. Syntax for declaring free function: free takes only one parameter, that is a pointer variable. Example, free with a pointer variable which is currently storing the address of the first byte. When we release that memory, the complete block of memory will be released or deallocated. That's all regarding dynamic memory allocation in C language. We will see the remaining topics in the coming videos. Thank you.
Hi and welcome to programming practice. Let us demonstrate here in this program one of the dynamic memory allocation function, most commonly used dynamic memory allocation function, that is malloc. Dynamic memory allocation functions are those functions which are used to allocate the memory at runtime. See, memory can be allocated at two different phases. One at compilation time, another one is at runtime, that is at execution time. Whenever we want to create an array at compilation time, simply what we can do is we can create an array just by saying int a of 10. Then the array will be allocated the memory at compilation time. If at all we want to allocate the memory at runtime, then we must use some dynamic memory allocation functions. One of that dynamic memory allocation function is malloc. Whenever we call malloc to allocate the memory dynamically, it will return the base address of that particular block of memories. So say for example, if I am creating an array of integer type, so I'll just say int star a pointer is now ready to store the address of that particular memory locations. Now I'll say a equals to, I'll call this particular function now malloc. Now when I call the function malloc, as we have seen in the separate video where each memory location function syntaxes we have seen, malloc function takes the number of bytes, how many number of bytes of memory you have to allocate it. So that size you have to specify it over here. If you don't know what exactly the size is, you can call size of operator. The most important point regarding malloc is malloc returns address of void type. We have to typecast it because a is of type integer. So before storing the address, we have to typecast this one into integer pointer, integer address. So this one is mandatory whenever we are using malloc function for dynamic memory allocation. So this is brief regarding compile time memory location and runtime memory allocation. Apart from malloc, we have calloc, realloc and free are the functions which are used under dynamic memory allocation, which we have already covered in a separate video. Let us demonstrate over here how malloc function is used. One more important thing is, if there is no sufficient memory available whenever malloc function is called, then this one is now going to store null value. So whenever a pointer stores a null value, that means that no memory currently available. So we can terminate the program by checking this null condition. Let us begin the program now. I'll declare a integer pointer and say how many blocks of memory you want. I'll take that value as n, and to iterate the contents in an array, I'll use an index I. Let us define this n value as, say for example 10, or you can read this value from keyboard also from the user. Let's say ptr is equals to, I have to typecast first this one, that is int star, call malloc function with this n followed by the size of, here is the size of operator, say integer. I don't know how much size integer occupies on this machine. If you want to display that one, we will display that size of integer also. Let us say if this pointer return by the user is null, then we need not proceed. Give a message to the user and terminate the program by just calling exit of 0. To do so, to include this one, we have to include stdlib #include stdlib.h. Let us assume that memory is successfully allocated, else part will be executed. Let's give a message to the user that memory successfully allocated. After giving the message to the user that memory is allocated successfully, we want to print the contents of the array then you can use any loop to demonstrate this one. Let's try to use a for loop over here for I equals to 0 using pointer variable. Let's try to store some values in this one. Say something like in the first memory location I want to store 1, and then in the second memory location I want to store 2, and so on. And we can give a message to the user. Since the contents of the array are in a loop, I'll copy this for loop. And you want to know how much memory pointer occupies. Let's try to print and get the size of operator. Since it is an integer pointer, it occupies 4 bytes in this environment. So I'll be printing it something like this. The size of the pointer is %d. Now I'll call over here size of operator. In this one, I want to know the size of the pointer. Let's build and check. You can check here. There are no errors, no warnings. So we can proceed further. Let's run this one. The output is now memory allocated successfully using malloc function is the first printf. The elements of the array are 1, 2, 3, 4, so on up to 10. At index 0, we are storing first I plus 1, that is 0 plus 1 is 1, then 0 plus 2 is this one, then 0 plus this one. Like that, the elements are stored and we are displaying the contents. And at the end, we are getting one more message. What is that message is? The size of the pointer is 4 bytes. These are the number of bytes. This is how malloc function works. Let us try to display the size of integer as well. Let's see the size of integer. You can see now the size of a pointer as well as the size of the integer, both are 4 bytes. Obviously the message we have not changed the message over here. Let's change the message and display it again. The size of integer is, here is, the size of the pointer is 4 and the size of the integer is also 4 bytes, and the contents of the elements are from 1 to 10 and the memory is allocated successfully. That's all for the demonstration session of malloc function. We will see the remaining topics in the coming videos. Thank you. Hi, and welcome to another online coding challenge on HackerRank. Today we will see one-dimension arrays in C. We have already came across challenges using one-dimension array, but here this one-dimension array we have to use the memory dynamically using malloc function and release the memory using free function. As we are familiar with an array data type, an array is a container object that holds a fixed number of values of a same data type or single type. To create an array in C, we can do it in two ways, that is in static way. This is a static way of allocating the memory. Here array is a variable which holds up to 10 integers. The above array is a static array, which we have already seen while learning the concepts of arrays. So here the memory is allocated at compilation time. So a dynamic array on the other hand can be created in C using malloc function, and the memory is allocated for this type of array from the heap memory at dynamic runtime. To create an integer array of size n, we will be declaring a pointer variable first of all, then allocating the memory using malloc function, then typecast it to use what type of data elements we are going to use. Malloc function uses the size, n number of elements, and the size of the integer will allocate the memory in bytes, where array points to the base address of the array. Now here in this challenge you have to create an array of size n dynamically, input the elements of the array, sum them, that is add all the elements, and then print the sum of the elements in a new line. This is the task. Here is the input format. The first line contains the number of elements, that is n. The next line contains n space separated integers, and the constraint is the n should range from 1 to 1000, and all the elements what we have for the array should also range from 1 to 1000. And the output format, print in a single line the sum of the integers of the array. Say for example, if n value is this one and an array contains this set of elements from index 0, 1, 2, 3, 4 and 5. If the name of the array is ARR, and if we are starting from index I, then when we say ARR plus I is the memory location base address when I is equals to 0. So every memory location will have some address, and the base address will be stored in the name of the array. Then we will make use of one variable, say sum, initialize it to 0. Whenever we encounter the first element, we sum up and add the value and store it in this variable sum. Go to the next memory location by incrementing the value of I and take the next data element and add the elements and store it in sum. Iterate through the next element, extract all the elements like that and sum up all the elements till the last element, and you will get the sum here to be say 51 for this input data elements. Very simple task here. So let us now proceed. Let us declare the required set of variables here. I need a variable n. I need a dynamic array, so I'll be declaring a dynamic array using pointers. I need a index to iterate it. Then I need a variable sum, which is to be initialized to 0 to sum up all the data elements. Here the first thing is we will read the data element using scanf function. Now the next immediate thing is we will dynamically allocate the memory, and the base address is to be stored in the name array. So I'll say ARR is equal, and we have to typecast it using int star. Then use malloc function here. Malloc function will be taking the size, unsigned long integer. So we will say n multiplied by, we don't know the size of the integer here on this environment in which we are going to execute it. So we will use size of operator along with int to allocate the memory dynamically. This will store the base address in the variable ARR. Now read all the elements. To read the elements we required a loop. Here we will be using a for loop. Say for example, for I equals to 0, I less than n, and iterate it using I++. Scanf %d array name plus the index is enough whenever we are using pointer variable to read the data elements. Once we have read all the data elements, now the next thing is we have to sum up the data elements. To sum up again we have to iterate it. So we will be using one more loop. For I equals to 0, I less than n, sum is a variable in which we have to place the data element. So sum plus is equals to, when I say just ARR plus I, that means that the memory location of ith element. Then I want to access that data element, I'll be using star prefixed. We have already came across this one while learning the concepts of pointers. Now once we got the result in sum, next thing what we have to do is print it the variable sum. Now one important thing what we need to take care is, whenever we are allocating the memory using dynamic memory allocation, malloc, calloc or realloc, we have to release the memory. Free is the function used for deallocating the memory whenever memory allocation is done dynamically. So I think the rest of the things are done. The only thing what we need to do is check whether this one works correct or not. Run the code. There are some compilation errors are there at line number 20, so you can okay, we have placed comma inside, so just run the code. Yeah, it has cleared the test cases, and let us now submit the code. Compiler message, success, congratulations, you solved this challenge, and with this challenge we have earned 10 points and 80% of this progress is over. Now that we are just 20 points behind our next star. That's all regarding one dimension array in C language. We will continue with the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is pointers in C language. Let us quickly see the objective of this problem. In this challenge, you will learn to implement the basic functionalities of pointers in C. We have already covered this topic in detail, but let us just have a brief explanation about pointers. A pointer in C is a way to share a memory address. That is, a pointer is nothing but a variable which can store the memory address of another variable. In order to access the memory address of a variable, say a variable is val is a variable. In order to access the memory address of a variable val, we need to prepend it with ampersand always specifies address. Example, ampersand val returns the memory address of this variable. The memory address is assigned to a pointer and can be shared among various functions. Example, an integer pointer is there which is now taking the address of this variable val. We'll assign the memory address val to pointer p to access the contents of memory to which the pointer points. For example, star p will return the value reflected by val, and any modification to it will be reflected to the source value. That is nothing but we have two types of parameter passing mechanisms in C language. Call by value is one and call by address is one. So this particular concept is nothing but call by address. That is, modification to it will be reflected to the source. Let us now jump to our task. You have to complete the function named as update, which is returning void taking two pointer parameters, which reads two integers as arguments and set a with the sum of them, that is nothing but addition of this one to, and b with absolute difference of them. So the difference of these two but with absolute value will be stored in b, and the sum is placed in, say, a. Input will contain two integers a and b separated by a new line. So what is the output format? You have to print the updated value of a and b on two different lines. We need not input the values. Input and output will be automatically handled. You only have to complete the function, that is this particular function update. Say if a value is 4 and b value is 5, sum of this one is again stored in a and difference of this one with absolute value, here it is 4 plus 5, is again stored back in a, that is becoming a complement here, a dash. Difference of these two gives you actually -1, but we have to take absolute value. Absolute value in C language can be achieved using ABS function that is available in math.h. So let us quickly write down the code to accomplish this task. Let us see what are the things given here before writing down the code. Two integer values are there here, a and b, and two pointer variables are there, star pa which is storing the address of a variable, star pb which is storing the address of b variable. Reading two values, that is automatically done. Now update is called. Update is called with addresses. Here you can see pa is storing the address of the first variable, and pb is storing the address of second variable. Whenever address is passed as a parameter, then the actual parameters are addresses, then formal parameters should be pointers. So these are the formal parameters. We should have pointers over here. That means address of pa will be now copied into this a variable, and star means its value, and the address of pb is copied into b, and star means the value at that particular address. Using these two parameters, now we have to add the values and take the absolute difference of this. For that, we will declare one temporary variable which is taking, say for example, the first value. Now star a, that is nothing but the first value, will become the sum. Sum is nothing but star a plus star b, value at address a and value at address b. We got it replaced in a. What we should have it in b is, we should have the absolute value of a value got updated, so we can't take now a because a is now containing sum of these two values. We can take temporary value, which we have already stored, subtracted by b. What happens if I take here star a? For example, if I take star a over here, you will get the sum value of a and b, because immediately before this statement, what we are writing is we are summing up these two values and storing it in a. If I have 4 and 5, then 9 will be stored in a currently. So that 9 will be substituted here, minus 5. So 9 minus 5 is going to be 4. Actually, you should have its original value a. A original value is available here in this variable temp. So that's why here we will be using temp rather than a. Let us see the working of this code first before running. We have some sample input, say 4 and b as say 5. PA is a pointer variable storing the address of a. So when I say a here, a is the name of the memory location, 4 is the value. Consider the memory address of a as say 1000. B value is 5. Assume the memory address is 1200. So PB is a pointer variable storing the address here 1200, here 1000. By taking this address here, it will be pointing it to 1000. By taking this address, it will be pointing it to 1200. Now, when a function is called update, PA and PB, we are passing the addresses. 1000 is passed as a parameter, 1200 is passed as a parameter. So this part of memory contents are there in main function. But what is there in update? In update, we have two variables here, A and B. What we have copied down into this one is 1000. What we have copied down over here is 1200. When we say int temp, one temporary variable is created of type integer. This is integer type with some memory address. We are not interested in this memory address here. Is equals to star a. When I say just a without star, 1000 would have been copied here. But when I am saying star a, value available at this particular address, so you go to this address, extract the value and copy down the value over here. So you got temp as 4, first step after this execution. Then when I am saying star a is equals to star a plus star b. So star a means going to this memory address and its value is now replaced by star a plus star b. So now you are going to get a contents as 9 here. And when I am saying star b is equals to absolute value of temp. So instead of temp, if I would have used a here, star a, I would have get 9. But what I want is the original value of a. Original value of a is now currently available where? It is available in temp. So I'll be using temp minus star b. 4 minus, take the address of b, go to this one and 5. Where it is stored the value here? In b only. That means that 4 minus 5, that is going to be 1. But we are using absolute value function that will make this one as positive plus 1. So currently when we try to print this value, since it is a reference type of parameter, whatever change you do it here will reflect it back. So when we try to print these values, what we are going to get the output? 9 here and 1 here. Hope this working is clear. Let us run this code and check how exactly the test cases will be. Yes, our sample test case is cleared now. We got a message for this input value. We got 9 and 1 as the output as it expected. Let us quickly submit the code and check for the remaining test cases. Yes, you just solved all the introduction challenges in C. So congratulations, we have done with all the introduction challenges of HackerRank. That's all for now. We will continue with the remaining challenges in the coming videos. Thank you.
Hi. In this section,
we will learn about the following: what is a string, how to declare a string in C language, then we will see how to initialize a string. Once we initialize a string and declare a string, how the memory representation of that string in the memory, and at the end we will see how we can perform the reading and writing operations on a string. Let us start with understanding what is a string. A string can be defined as an array of characters. We have already seen C provides basic data type as a character. Character data type can store a single character. If we have collection of such characters in an array, then we can call that as a string. Strings are collection of characters but terminated with a special character that is called as a null character. A null character is represented in the memory using /0, and each character in an array is represented with single quotation mark, so as the null character as well is specified using a single quotation mark. Let us say a string contains the following contents: ABC has 4 characters. We have specified ABC with 3 characters only, and the 4th character, that is /0, will be automatically appended at the end of the last character. Therefore, we will say the individual characters are A enclosed in single apostrophe, B, C, as well as /0. Each character is individually enclosed in single quotation mark, whereas if we see a string, it is clearly enclosed in double quotation mark. String is not a data type in C language, but we have a header file called as string.h that we will see in the coming videos, that we will see in the next video. Let us see how to declare a string. Declaring a string is as simple as declaring a one-dimensional array, because when we declare a one-dimensional array of characters, simply it becomes a string. Syntax for declaring a string: character followed by array name, then within square brackets the size of the array. Example, character str of 10. Then the memory location will be allocated for 10 characters contiguously, where at each memory location a character can be stored. There is another alternate declaration of a string. We can even declare a string with the following syntax. Here you can see a pointer is declared. Array name is now a pointer which can store the address of a character. Both the declarations here, the first one and the second one, creates an array which can store characters at contiguous memory locations. But the difference is the first one is declared at compile time and the second one is declared at runtime, that is at execution time. Example, character *str, a character pointer is declared without any value assigned to it. Let us see how to initialize a string. There are multiple ways of initializing a string. Based upon our convenience, based upon our feasibility, we can initialize a string. Among them, the first one is character str with empty square braces, assigns a value hello with double quotation mark. Compiler will easily recognize the size of this particular array by placing a null character at the end of the string HELLO/0. It counts to be 6 characters within this particular array. So compiler allocates 6 contiguous memory locations to store this string. We can even declare it by specifying the size. So size is optional provided if it is getting initialized at the same time. If we are not initializing the string, then we cannot leave this square braces empty. The next one, here the same thing can be initialized using single quotation mark, where each character is separated using comma and each character is enclosed within single apostrophes HELLO followed by /0, which is automatically appended in the above two cases, whereas if we are using flower braces and specifying individual characters, then we have to provide /0 as a terminating character, that is called as a null character. Even we can initialize the same by providing the size as well. Let us see how the memory representation of character array is there. Assume that we have a character array str which is initialized to a string hello. In the memory, it will be looking something like this. Str at the first memory location, the first character is stored, and the second character is contiguously stored at the second memory location and followed by the next character and so on. The last character is the terminating character which is automatically appended at the end of the string. The starting index is by default 0 and the length of this particular string is 5. /0 is not counted as a character to be included in the string. Now the last part of this section is how do we provide reading and writing operations on a string. Let us start with first, how do we read a string using different functions. First one is using scanf. The format specifier used over here is %s and followed by the variable name, that is a character array. If we notice carefully over here, there is no ampersand specified while reading a string, whereas for reading an integer or a float or a double, we required ampersand to be specified before the variable name. Now the next one is gets. What is the drawback of scanf is, let us say while providing input through the keyboard, if I give a text as hello space world, then as soon as scanf identifies a space, the following characters won't be stored. It will terminate the process of reading then and there itself. So str now contains HELLO as a collection of characters, whereas it should have been hello space world. That can be done using the second function called as gets. That is nothing but get a string. We can read a complete string provided with multiple spaces in between the characters. The next one, fgetS, is associated with files. This operation is to read the data using a file pointer and declaring a string and specifying the size, how much size in bytes to be read. And the next one is writing string using printf and puts. Same thing, what we have seen using scanf can be done using printf, %s, str. The problem with again printf will be whenever a space is encountered, then the following continuation part of that string will not get printed. To overcome this problem, we have again a solution over here is we can use another function called as puts, that is put string. So a string can have multiple spaces as well. That's all regarding the introduction part of a string. We will see the remaining topics in the coming videos. Thank you. Hi. In the last video of introduction to strings, we have seen what exactly a string is, how to declare a string, how to initialize a strings, and we have seen the basics of strings. Now in this section, we will learn about some of the commonly used string functions and the detailed understanding of each string function with syntax and examples of each. Let us begin with string functions. These are the commonly used string functions. strcat used for concatenation of two strings. strcmp used for comparing two strings. strcpy used for copying a string. strlen used to find the length of a given string. And the advanced versions of 1, 2 and 3 can be seen over here in the form of 5, 6 and 7. strncat concatenating a restricted number of characters from a string. Then again n over here specifies the number of characters in all these three functions. strncmp comparing strings for n number of characters and copying a string for n number of characters. Let us begin with the detailed understanding of these string functions. Let us first begin with strcat. The strcat function will append a copy of the source string to the end of the target string. Appending is to add by keeping the current contents as it is. Syntax of strcat: target string, comma, source string. There are two strings are passed as a parameter to strcat function. The contents of the second parameter will be appended to the first parameter, that is target string. For example, we have two strings over here, one named as target string, another one named as source string with some sizes. First string contains hello, second string contains space followed by world. When we call strcat function with these two as the parameters, source string contains the same contents after this function call, whereas the target string now contains hello followed by the contents of the source string, that is hello space world. When we try to print this string, target string, we are using a function puts, because printf statement will not print the contents of the string once it encounters a space. Therefore, we are using a puts function over here to print the target string, which contains now hello space world. The second function strcmp, cmp is for comparing two strings. This function takes two strings as arguments, that is parameters, and compare these two strings lexicographically, that is character by character. Syntax used to declare this function strcmp. strcmp takes two parameters as strings, string 1 and string 2, and returns 0 if both the strings are equal. Otherwise, a non-zero value will be returned if the two strings are not equal. Let us see the example here. Consider two strings over here. str1 contains hello, str2 also contains hello, but with a small difference in the first alphabet. That is, first string contains uppercase h and second string contains lowercase h. When we call strcmp with these two parameters, str1 and str2, this function returns an integer value. That's why we are now holding the result into a variable I. If I value is 0, that means that if both the strings are equal, right now in our case currently they are not equal because the ASCII value of these two characters, capital H and small h, are different. So first string is not equals to second string when we are comparing it. So else part will be executed by saying strings are unequal. Now, a function to copy a string into another. This function is used to copy one string into another. Syntax. This also takes two strings as parameters. Returns void. Let us have an example over here. First string is just declared without any initialization, expecting the output to be there in the first string. Then second string, str2, is initialized with a value hello. When we call strcpy with string 1 and string 2 as parameters, the contents of str2 now will be copied into str1. After this, when we try to print the values of str1 and str2, both will contain the same strings. Currently we are printing only the first string. strlen is the next string function used to find the total number of characters available in a string. That is, this function returns the length. strlen stands for string length. That is the total number of characters in a string. Remember, /0 will not be counted with this particular function. It takes only one parameter, string as a parameter, and returns integer value. Example, when we call strlen, it returns a value which we are capturing in a variable L. Then at the end we are printing the length of this string. Now from here onwards there is a small difference in the functions what we have already seen, that is for concatenation, comparison and copy. We have n as a new version of functions available. This function appends not more than n characters from the string pointed by the source string to the end of the string pointed by the target string and a null character at the end of the string. Let's look at the syntax. Earlier version of strcat takes two parameters. Now strncat takes three parameters, where the third parameter now is n. Example, let us say target string contains hello, source string contains space to space all. When we call strncat with three parameters, target, comma, source, comma, 3, that means from source string it will append the three characters into the target string. So from the beginning one space, then T, then O will be appended,
at the end of hello into the target string. When we are printing the output using put s, then we will get the output as hello space 2. Similar to string comparison, we have strncmp. This function lexicographically compares not more than count characters from the two null terminated strings and returns an integer based on the outcome. If you remember, strcmp returns either 0 or non-zero value, whereas here there are some possibilities that the first string might be greater than the second string, or both the strings can be same, or first string can be less than the second string. This value returned by this particular function will be an integer value. So the syntax takes three parameters, strncmp, to compare character by character specified by value n. Example, let us consider two strings with the first character in each string to be different than the remaining set of characters. Here, two strings are compared character by character, and if the ASCII value of the first string is greater than the ASCII value of the second string, then a positive value will be returned. Otherwise, if both the ASCII values are same, 0 is returned. Else, if the ASCII value of the second string is greater than the ASCII value of the first one, then a negative value will be returned. So here we are comparing it. Here we are capturing that integer value in a variable I and comparing if I equals to 0. Obviously here they are not same. Else part, if I value is greater than 0, currently this condition also false because the ASCII value of the second one is greater than the ASCII value of the first one. So the last printf statement will give the output as second string is greater. And the last one, the strncpy function is similar to strcpy function, that is to copy a string, except that at most n bytes of source strings are copied. Same thing, strcpy takes two parameters, here strncpy takes three parameters. Let us try to understand this strncpy with the help of an example. First string is just declared without any initialization, whereas the second string is initialized with a string hi all. When we call a function strncpy with three parameters, str1 that is empty currently, str2 contains hi all, and then 2. So n value is 2. So starting two characters will be copied into str1. So the first two characters from str2 will be copied into str1. Once we print the output, the copied string is, you will get only the two characters from the second string. I hope the concept of string functions are clear. We will see the remaining topics in the coming videos. Thank you. Hi, let us have a demonstration program to demonstrate the working of string operations, that is using built-in string functions. We have some of the commonly used operations are comparing two strings, concatenating two strings, that is appending one string after another one, then finding the length of a string and copying one string contents into another. All these operations can be carried out using built-in functions strcmp, strcat, strlen,
and strcpy. So there is separate function for each one. We have strcmp is the first function. Comparing two strings, returns an integer value. If both the strings are same, it returns 0. Otherwise, a non-zero value will be returned. Let us assume that it is -1. Next one is concatenating two strings, strcat. When we concatenate two strings, that is append one string after another one, it results into the final concatenated string. Length. Finding the length is using strlen, returns an integer value, that is the number of characters within it, and strcpy is used for copying one string into another one. Compare, concatenate and copy takes two parameters, whereas strlen takes one parameter as a string. Here in this declaration, we are declaring two strings of size 20 each, taking a variable len which stores the length of the string, giving a message to the user to enter two strings, reading both the strings using getS function, whose implementation is available in a header file string.h, which we are including here. Calling first function strcmp is a built-in function taking two string parameters, returns 0 if both the strings are same. We have seen in the introduction part of strings how strcmp works. Lexicographically, it compares the characters, that is, character by character it compares. If it returns a non-zero value, then we will get a message that these two strings are not equal. To concatenate, we have strcat, and the first string gets concatenated with the second string, that is, the contents of the second string will be appended to the first string, so the result is available in the first string. When strlen is called with one parameter, it will count the number of characters and return the result into a integer variable called as len, which we are displaying it over here. The length of the string is so and so. And the last function strcpy copies the contents of the first string into the second one. Then we are displaying the second string over here. Let us build and check for any errors. Run the program with different inputs. First we will give the input as hello and hello. There is a difference in the first character. First one is uppercase, second one is lowercase. Strings hello and hello are not equal, and the concatenated string is the combined result of both the strings, and the length is the number of characters that is available, and the copied string is second string is getting copied into the first one, and we are printing that result. Let us give the same strings as input and check. Hello and hello both are in lowercase, so these are equal, and the concatenated string is, and the length is 10, and hello is the output in the copied string. Well, all are working fine. This is just a demonstration to show you how exactly the built-in functions works. We will have the next video where we will work out with our own user-defined functions, where we will iterate each character by character to compare the string and append character by character in strcat. Even to find the length, we will iterate it using a loop and find the length, as well as for strcpy. That we will see in the next video. That's all for now. We will see the remaining topics in the coming videos. Thank you. Hi, in this section we will see a program to demonstrate the working of strings without using string functions. The operations included are: first one, comparing two strings; second one, concatenating two strings, that is combining two strings and finding the length of a given string, and at the end we will see how to copy one string contents into another. Let's begin this program. The required header files we will start with stdio.h for standard input output operations and string.h when we are using gets and puts function here in our program. Let us begin with first operation, that is compare. When we are comparing two strings, that means that we are comparing lexicographically. What is the meaning for this lexicographic comparison? Is character by character. We know that each character is stored at one memory location. So a string is nothing but an array of characters where at each memory location of an array a character is stored. We are now going to compare character by character. Let us first declare the prototype for compare. I am assuming that when compare performs the operation, it returns 0 if the two strings are same or equal. Otherwise, it returns -1 or any other non-zero value. So I am taking the return type as integer. Say the name of a function, I am giving it as compare, assuming that it takes two string parameters, character array and character array. This is the prototype for the compare function. Let's start the main function here. Now in main function we declare the required data types, say string1 of some length and string2 is of some length, say 20 and 20. I am declaring both over here. Now we will give a message to the user to enter two strings. When user enters two strings, we will read it through getS function. We have seen what is the significance of getS function while seeing the introduction part of strings. So both the strings I am reading it using getS function. The implementation of this getS function is available in the header file string.h. String.h includes the functionality of getS function. Now once reading this one, now I am calling compare. Since compare is returning a value, I am using it in if condition, or you can capture the value in a variable and compare it in if condition. I am using directly over here by saying compare of. Compare takes how many parameters? Here it's showing 2 parameters it takes, both of string types. So I'll pass first parameter as string1, second parameter as string2. Whatever value returned by this function, if it matches with 0, give a message, else let us close main function here, and now let us write down compare function. Here is the compare user defined function, we are writing it. Return type is integer for compare. We can use character array or pointers over here. I am using character, the first one. This one is the formal parameter. Whatever the value of actual parameter is there, that address will be copied into the formal parameter here. Let us iterate the strings using while loop. I am not specifying any condition here in while loop, just saying how long shall we continue, we will decide it. Now we will check if the string1 of some index matches with say null character, or string2 of I, we will declare this I value, matches with null character, anyone, if anyone reaches null character, that means that we need not continue, give a break. So for that we will declare a integer variable and initialize it to 0, and if it is not reaching, so we will go to the next index and iterate it. How long this while loop should continue? Until both the contents of the first string and the second string should be same. Then we will continue this particular loop. Now, once we come out of this loop, let it be match or let it does not match. After coming out of the while loop, we will see if, let us say, both of them have reached the null character, that is the first string also reaches the null character as well as the second string also reaches the null character. That means that we have reached both the terminating point and both the strings are same. If both the strings are same, return 0, otherwise return any other non-zero value, let us say -1. Let us build, check for any errors here. No errors, no warnings. Let us run and check. I'll give first of all both the strings same. Here, strings hello and hello are equal is the message what is displayed to the user. Let us enter one more time and check for unequal strings. You can see a message over here, strings hello and hello, where there is a difference in the first character. First one is uppercase and second one is lowercase, so they are not equal. Okay, once we are done with this comparison one, let us now move on to the next operation. The next operation is to concatenate. Let us say concatenation, concatenate, concat is a user defined name, we are using it. Parameters, say the same two strings as parameters, character array and character array, and let us call concat function. Concat with two parameters, string 1 and string 2. Let us write a function for concatenation, that is concat function returns void concat with two parameters. First one is character array. Formal parameter and actual parameters you can give different names. I am giving the same names over here, str1 and str2, character arrays. Now the second string str2 will be appended or concatenated at the end of the first string. So to append the second string at the end of the first string, we must know first of all what is the length of the first string. So now let us say I'll find the length of the first string with a function called as strlen. I'll be declaring this variable over here, required variable I will declare first. Then I'll use a for loop to iterate it and append character by character. That is, we will start from the first one, j equals to 0, the first character. And what would be the terminating condition? Terminating condition is to terminate when we encountered the null character for the second string. And I value should be incremented as well as j value should also be incremented parallelly. Now within this particular for loop, you copy down each character by character, but here the indexes will be different. How they are different? You can just have a look here. I am using I index for str1 and j index for str2 because I know that the length of the first string is I. After that particular length only I am going to append it. Let us say for example the length of the first string is 5, then at index 5 only I am going to append the first character of the second string because indexes starts from 0. Make a note of this one. Now once we copy it character by character or append character by character the second string into the first string, we know that every string terminates with a null character. So make sure that you give null character by yourself. You make sure that you give /0, that is null character, at the end of the first string. Now after giving this one, you can print the message over here that concatenated string is %s is %s. Let us use a new line operator to print the contents into new line. Here the first string contains now the result, that is concatenation 1. Let us build. Here there is a spelling mistake, str1, no errors. Let us enter two strings over here, hello and world. Strings hello and world are not equal, and the concatenated string is hello world. Both the functions are now parallelly getting executed. We will see the output with a different input parameters, hi space John. So hi and John are not equal, but you can see here after concatenating I got the output as hi space John. Okay, this one is working perfectly. Let us now move on to the next function in our list, that is length. When we find the length, obviously length will return a integer value. So the name of the function, you can give it any name over here. I am using the name of the function as string_ln, takes one character array. Now I am declaring star. Both declarations are same. You can declare it using square brackets, character array it is. Now I am using another usage, that is a pointer, character pointer. Let us say in main function I am calling length. Whenever we call a length function, length is now going to return. So I am declaring one variable over here, len, and assuming that the string function, what we are writing it over here, which takes first string or second string, anything, any one string as a parameter, and now we are going to give a message to the user using printf statement that length is len. We have to declare this variable over here, int len. Let us now write down the function over here, length function. How a string length function works? We will count the number of characters within this particular function and return that count. Very simple one. But how long? How long shall we count the characters? We know that every string terminates with a null character. So we will start writing down the function like this. String_ln is the name of the function, which takes a character pointer, let us say p as a character pointer. Starting the function over here, I'll declare a count variable which is assumed to be initialized to 0, and I'll iterate it using a loop. You can use any of the loop. I am making use of while loop over here as a convenient one. You can make use of for loop as well or do while loop as well. So how long shall I iterate it? I have to iterate it until I get a null character. Now within this while loop, what should I do? I'll increment the value of count by 1 and I'll make a pointer also to move to the next consecutive memory location. We have already seen in pointers arithmetic that whenever we have to move a pointer from one memory location to another memory location, it has to use p++. That means that a pointer p is now moved to the next memory location. Once this while loop gets terminated, we know that we got a count over here. So return the count variable. That variable will be now captured into this len and it will be displayed. Let us build and run the program. Strings hello and Sharif are not equal. Concatenated string is hello Sharif. The length is the total length, what you can see over here, 13. the total number of characters. Now what we got it in string 1. String 1 is actually contains hello, string 2 actually contains Sharif. But after concatenating, the result is now placed into string 1. That's why the length is the number of characters available in the first string. Let us run this one for a different input and check. Hi is one string, James. Hi James are not same, and the length of this one is 7. Perfect. All the three functions are working perfectly. Let us now move on to the last operation in our list. You know that after copying the string, we will display the string there itself. Let us declare it using a pointer. Two functions I am using arrays, two functions I am using pointers. Void copy. Now how it is get called in main function? Here is copy function called copy of two parameters, that is the two strings, first string and second string. Let us write the function at the end, that is copy function. Now one thing is, how do we copy? Copying, when we copy the contents of one string into another one, if a string contains already some contents, it will be overwritten. Okay, so let us copy character by character. Return type for the function is void. Name of the function is copy. Takes the first parameter as character str1 and the second character is star str2. Earlier we have seen character arrays. Now we are seeing using pointers. Now for any of the string to terminate, let us copy the first string into second string. So to copy the contents of the first string, we have to iterate from the first memory location until we reach null character. For that one, we required any loop. Let us take again the while loop. I'll take an index I, which I assume that until I reach null character, I'll iterate in that particular loop. But I have to declare that variable. So here the second string, that is string 2 contents, now will be getting same as the contents of string 1. Simply make I value to be incremented, but provided it has to be initialized with some value. What is that? Say 0. Now once we copy down character by character, all the characters of the first string will be copied into second string, and we know that every string terminates with a null character. So it is a programmer's responsibility to provide a null character at the end of the string. Once we got this one, let us print and check the output over here. Now once we are done with this particular function, let us build no errors and run the program. Hello and small case hello. You can see the first output, strings hello and hello are not equal, and the concatenated string is hello with hello, and the length of this string is 10 and the length of this string is 10, and at the end you can see hello hello, that is the first string that is containing this one, is copied into the second string. This also works perfectly. So here we have used pointers as well as character arrays to demonstrate this program. Two functions we have used character arrays, and two functions we have used pointers, using which we can access the string. I'll just make a summary or revision what we have already done. Whatever the operation we are doing it over here, we have a prototype over here for each function, and in the main function we are declaring two strings, giving a message to read two strings, calling first compare function, compares each string character by character, that is called as lexicographic comparison, that is called as lexicographic comparison, and returns 0 if both the strings are same. So I am capturing this one within if condition, and if they are same, giving a message to the user. Otherwise, give a message that they are not same. Concatenating, combining one string to another one at the end, that is called as appending. Then finding the length, which returns a value, and capturing in a variable len and displaying that length. At the end, copying the contents of one string into another string. I hope the working of string concept is clear. We will see the remaining topics in the coming videos. Thank you. Hi and welcome to another programming challenge. Here in this programming challenge, the problem statement is to convert the cases of a given string using pointers, and if there is a lowercase character exist, that has to be converted into its uppercase equivalent, and if there is a uppercase character exist, that has to be converted into its lowercase equivalent. Let us first of all try to understand what do we mean by a string. A string is nothing but a collection of characters terminated with a special character known as a null character. Say for example, if I have a string, say hello, this string will be represented something like this. Say a string s is there which is storing currently hello. In the memory location, it will be something like this. Each character is placed with one specific index and 1 byte will be occupied in the memory, and a special character is placed at the end of the string. We call this character as a null character. Okay, if at all I have to access the characters of the array, I can access in two ways. I can access it using indexes, or I can access it using memory addresses. Every memory location will be having some addresses. Let us say this is going to be the base address, and this base address will be stored in a pointer variable. So let us try to access this one using pointer variables in this programming challenge, because the programming challenge is to convert the cases using pointers. Okay, then first of all we will be storing this memory address in one variable. Then using this variable we will be moving it to the next memory location and access the contents of this memory location. Similarly, we will move on to the next memory location and access the contents of this memory location, and we will iterate it until we reach a special character known as null character. This is how we iterate and access the contents of a string. Then the second part of this particular programming challenge is, what do we mean by lowercase characters? What do we mean by uppercase characters? See, there are two cases of characters. Uppercases are capital A, B, C, D, so on up to capital Z, and small a, B, C, D, so on up to small z. In the memory, whenever we store a character, its ASCII value will be stored actually. So first of all, what are the ASCII values of each character is? ASCII value of uppercases starts from 65, then next one will be 66, next one will be 67, next one will be 68, and so on. The last one will be 90. Same way, here are the lowercase characters. Lowercase characters starts from 97, then 98, and so on up to 122.
is the last Z ASCII value. Uppercase ASCII value Z is 90 and lowercase z ASCII value is 122. Now, if you closely observe these ASCII values, there is a difference of 32 in between uppercase A and lowercase a value. Now, this one will give you a logic to develop to convert a uppercase A into a lowercase a. Similarly, uppercase B and lowercase b also have a difference of 32 only. If you see, all the characters are having a difference of 32 only. So keeping this 32 value in mind, let us try to convert the uppercase into lowercase and lowercase into uppercase respectively. So here, whenever I want to convert a uppercase value into lowercase, what I have to do is I have to perform addition of 32 such that I'll get its equivalent lowercase value. Similarly, if at all I want to convert it from lowercase to uppercase, then what I have to do is I have to subtract 32. Then only I can achieve its uppercase equivalent of any of the alphabets, that is from either A to capital Z or lower a, that is a small a, to small z. If you remember these two concepts, then we can easily write down this particular program. So there are two things what we need to remember is, to access a string we can use indexes or memory locations. Here we have to use memory locations, that is using pointers. Second thing is, we need to remember the ASCII values of the characters. So uppercase characters starts from 65 and ends at 90, and lowercase characters starts from 97 and ends at 122. Keeping these two things in mind, let us start the program. First of all, I'll declare a character array, that is nothing but a string. Let us say a character array of some size. Then I required a pointer variable which can store the memory address. So this pointer variable should be of character type because we want to store the address of a character. Let us read a string from the user. Using gets method, I am reading a string. Now once we got a string in a variable a, I'll assign the address, that is the base address of the first character into a pointer variable. So here ptr is a pointer variable which is now going to store the address of the first character in the string. Now once we got this address into a pointer variable, we have to move from the first character till we reach the last character, that is the null character. So we can use any loop. I am using it over here while loop. While, that means that until we reach the last character. Say if I say want to access the contents of the array, then I have to use a pointer variable. So star ptr not equals to, until the last character is /0, that is a null character. Until we reach the last character, we have to iterate it. And when we are accessing the first character, star ptr means the value, ptr means the address. So if this ptr, star ptr, that is the first character ASCII value, if it is greater than or equals to 65, because uppercase starts from 65, and star ptr less than or equals to 90, because the last one is, let me put the parenthesis over here for each one. Okay, it is now properly parenthesized. That means that this condition checks for the uppercase of the character. If it ranges from 65 to 90, that means that it is a uppercase character. This type of characters which are uppercase has to be converted into its lowercase equivalent. So that has to be converted into lowercase equivalent. Lowercase equivalent we can get it by adding a value 32. Then we can get its lowercase equivalent. Let us consider if it is not uppercase, then it may happens that it can be lowercase or it can be any other character also.
That means that it can be a space or it can be any other character other than the alphabet set A to Z. That one we will check one more time, that is if. Now this condition is for lowercase. If any character is within this particular range, that means that it is a lowercase character. A lowercase character can be converted into its uppercase character by just subtracting 32 from it. Let us say it is neither uppercase nor lowercase. Then it can be any other character including space also. So let us try to print that character as it is. Say star PTR. We are not doing anything for other characters other than alphabets. Now after doing this, we have to iterate, or we have to move to the next memory location. How do you move the pointer to the next memory location? Using plus plus. Currently, if it is pointing it to the first memory location, so what this PTR plus plus will do, if a string of this particular type is there, say HELLO and /0, if this memory address is say 2000 and if the next memory location is 2001, that means that if PTR is pointing it over here, then PTR plus plus will move the memory location to this one. Then next time PTR plus plus will move the memory location into this one. Like that we have to iterate it until we reach /0. That's what we are checking the condition over here. Okay, let's try to build. As you can see, there are no errors and no warnings. Let's proceed further to run. Enter a string, say hello. You can now check the cases of this particular output. This is the input string what we have provided. This is the only character which was there in uppercase is now converted into its equivalent lowercase, and all lowercase characters are now converted into its uppercase equivalent perfectly. This one is working good. Let's enter another input. Now to this input value, you can easily see what are the uppercases. I am just selecting only the uppercases over here, and the remaining all are lower cases here, which are now converted into its uppercase equivalent. So L is the small case is converted, and capital C is converted into small c, and this capital C also converted into small c. This capital L is converted into small l. Fine. So this one is perfectly working for all input values. Let me just show you the tracing part of this one. The inputted string what we have seen over here is say learn to code in C. If this one is there in an array, then a special character will be attached, that is something referred to be as a null character, automatically placed at the end of the string. And whenever we are creating a pointer over here, so this one is a string A, PTR equals to A means a pointer will be created which is now pointing it to the first character of the string. We says star PTR. Star PTR means the value located at this particular address PTR. Not equals to null. Yes, it is not equals to null, because what is the value available at this one? It's not null. Enters the block because the condition evaluates to true. Star PTR is within this particular range of 65 to 90. As we have seen in the beginning, what are the ASCII value range for uppercases is from 65 to capital Z will be 90. Yes. L range within this particular one only. Yes. That means that it is a uppercase character. Uppercase character has to be converted into its lowercase character, provided if I add 32, then only I'll get its equivalent lowercase character. This one is done for one character, say small l. Once we are done with this one, else part will not be executed because this condition is true and we have done it for capital L to small l.
So ptr plus plus will move the pointer to the next character. So the next character is small e, and small e does not range in this particular part. So here this time for small e, this condition will be false, else part will be executed. So the control goes into this condition. Yes, small e now ranges in this particular one, because we know that small cases ASCII values are, we have capital A, B, C, D, E. Capital A will be 97, then 98, like that. Yes, small e ranges over here. Yes, small e ranges in this particular range, that is in between 97 to 122. So it will convert minus 32. So 101 minus 32 will give you 69. So it will continue incrementing the pointer until a pointer reaches the last character. What is the last character? Last character is the null character. Once it reaches the null character, it will come out of the loop and return 0 will be executed perfectly. Hope those who have done this programming challenge without seeing the solution matches the solution. We will continue with the remaining challenges in the coming videos. Thank you.
Hi and welcome to the next online coding challenge on HackerRank. In the last video, we have seen how exactly the online coding on HackerRank can be solved, and here we will proceed with the next challenge, playing with characters. Let us see the problem objective. The objective of this problem is, this challenge will help you to learn to take a character, a string and a sentence as input in C language. We have three different things over here. To take a single character ch as input, we can use this scanf function and use a printf function for printing the same character. That thing is specified over here, declaring a character, reading a character and printing a character. This is just for one character. You can take a string as input using %s. Read it in a variable s, but it accepts string only until it finds the first space. That is, say for example, if I have, once a space is encountered, your %s in scanf function will stop reading this particular string here itself. It will not proceed to accept this string. We have already came across in the string concepts. So here, in order to take a line as input, you can use this type of format, that is /n using cap operator in %1, then again percentile is prefixed and suffixed, then *c. Using this one, we can read a complete line of text specified by maximum length. Now what we need to take care is, make a note over here, after inputting the character and the string, inputting the sentence by the above mentioned statement won't work, because at the end of each line a new line character is present. So here in scanf we have a /n over here. We will be adding a scanf /n. So this one will help you in reading a next line or a next sentence. So here the task is, we have to print the character in the first line, then print s, that is a string, in the next line, then in the last line we will be printing a sentence. So first read a character, then read a string, then a sentence. Printing it, same thing, printing a character first, printing a string, then printing a sentence. For example, if C is the character, language is a string, and welcome to C is a sentence, then this one should be printed in the first line, this one should be printed in the second line, this one should be printed in the third line. Now let us write down the code here. Let us first of all decide how many number of variables are required. We required a character variable, we required two strings, one for storing a word that is a string without any space. Another one is a sentence. Let us quickly declare the variables. First one is for a character. Next one is for a string of some maximum length. So we need to define this one in preprocessor directive, that is hash define max length to be some say 20. Next one is for sentence maximum length. Now once we have declared the variables, now we will read the character first, then a string, then a sentence. Let us quickly read. First one is for a character, next one is for a string. We have seen over here that this can be handled in a varieties of ways. One of them is a scanf can be used before the last statement. So here we will be using a scanf, and the last scanf is for a sentence. Once we have done with reading a character, string and a sentence, let us quickly display it or print it using printf statement. First one is a character, and immediately the next one is to be printed in the next line, so I am using /n over here. Then the last one is this /n is optional. We have declared a character, defined a maximum length of some size 20, that we are using it over here in both the areas of string as well as sentence. Reading a character, first thing, reading a string, reading. Then here before reading the next sentence we are providing /n, then we are reading a sentence. Same thing, character is printed into the first line, then string is printed in the second line, then sentence is printed in the third line. Once you are done with the appropriate code placed in its place here, then we will run the code. It's passing it into some sample test over here. We are getting congratulations, you have passed the sample test cases. Let us submit the code here. It's passing through some sample tests here, test case 0, test case 1 and test case 2. Congratulations, you have passed and you have earned 5 points over here, and here is the input and here is the expected output. So we have solved this second challenge. We'll proceed with the next challenge in the next video. Thank you. Hi and welcome to another online coding challenge on HackerRank. This coding challenge will fetch you 20 points, which will give you the next star. So let us see what exactly we mean by printing tokens. The problem definition is, you are given a sentence, say S. Print each word of the sentence in a new line. Say for example, the input format will be something like this. The first and only line contains a sentence S, and the constraint of the problem is minimum 1 and maximum 1000 will be the length of the string. And the output format, we need to print each word of the sentence in a new line. Say for example, if we have a string inputted as, there are 3 words in this particular string, so the sample output should be the first word should be printed into the first line, and the second word should be printed into the next line, and the last word should be printed into the next line. Here is a brief explanation given. In the given string there are 3 words. These are the 3 words. We have to print each of these words in a new line. Here are some other sample inputs are provided. This line contains 4 words. Learning C is fun. Each one is separated with a space. So while scanning the string, we need to take care where exactly a space is encountered. So we need to segregate this string with the help of a space. So as we have encountered a space, place this one in one line, and as we have encountered the next space, place this one into the next line, and the next space, the next one into the next, and the last one should be placed into the next line, such that all the words are placed into a new line. Same way, the last input example we have, how is that, will be printed into each line. Now very simple example this one is, we will be using a dynamic memory allocation functions over here. First one, we will be using two dynamic memory allocation function, malloc to allocate the memory. Say randomly we will allocate the memory for some characters, say for example 1024 characters we want to store it first. User may enter some size, so based upon that particular size we will reallocate the memory. So whenever we are allocating the memory dynamically, we need to release the memory using free function. Let us quickly write down the code and see how exactly this one is going to be executed. What we need in this particular challenge is a string. So first of all, declare a dynamic array of characters, that is a string. Now first of all, I'll allocate the memory dynamically. How do we allocate the memory dynamically? We allocate the memory dynamically using malloc function. So I'll be using a malloc function to allocate the memory dynamically. Say some random, I'll be allocating the memory for 1024 bits for each character. I don't know how much exactly the size of the character is. So in this scenario, we will be using size of operator. So size of operator will return the number of bytes occupied. Let us read a string using scanf function. String name is s. So once we are done with reading a string, let us try to find the length of that string. So I'll declare a variable length and I'll call strlen, that is a built-in function of string that is available in a string function over here, string.h. So once we got the length of the string, we need to iterate until the length or until we encountered the null character. So let us make a use of one loop. We can use any loop. I am using a for loop to start the iteration, and I value should be less than length. Until that we have to iterate it. Increment character by character. Now the first thing we need to check is string of I. If this one is equals to a space, that means that we have encountered a word. Once we have encountered a space, that means that we have to go and print into the next line. So for that one, we will be using one printf statement. In this one, we will be using one new line function, that is /n. Let us say if it is not space, that means that we have to directly print. That means that we have to directly print that word in the form of a string. So how do we print it? Character by character. So first of all, I'll use delimiter operator over here, %c, and I have the character to be printed from s of I, and it will print character by character. Once we are done with this, then the last thing what we need to do is release the memory occupied by a string s, for which we have used dynamic memory allocation function. Now one thing we can add to this one is we can reallocate the memory. S assigns realloc function can be used. Now realloc function takes two parameters. One is a string which we have already allocated the memory, so s, and the second one is the length, the size you can say. So I'll be using strlen function used for finding the length of the string plus 1 for null character. Now this reallocate function will allocate the memory dynamically exactly for the number of characters available for the string, plus 1 is for null character. I hope this code is enough for execution. Let us test this one by clicking run code. Yes, it has gone through clearly over here. Congratulations, here all the three cases have been cleared. Now we will submit the code for execution and check how it will be done for the remaining cases. Yes, the compiler message is success and we got the 4th star now. You have earned the 4th star now here in this online coding challenges. So we got a congratulations message. Click continue and proceed further. Here you can see now for the next star we need to earn 300 points, and we have solved this particular challenge and we gain the fourth star now. That's all for the printing of tokens challenge. We will see the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's problem is digit frequency. Let us see the problem definition here. Given a string S consisting of alphabets and digits, that is nothing but the string what is given to us is a combination of alphabets, that is characters, as well as digits, that is from 0 to 9. Find the frequency of each digit. That means that it may be a combination of digits as well as alphabets. We need to find how many times each digits in a given string repeats. Say for example, here input format you will be given a string number which is the given number, and the length of this number is ranges from 1 to 1000. All the elements of number are made of English alphabets and digits, and the output format is print 10 space separated integers in a single line denoting the frequency of each digit from 0 to 9. Here is a sample input. Say for example, this input is a string given to us. This is combination of digits as well as alphabets. So let us see here how many number of digits are there. First time, A is not a digit. So how do you identify that whether it is a digit or not? Whenever we are scanning the string from left to right until the length of the string, go to each character and find out whether it is a digit or not by comparing its ASCII value, that is if it ranges from 0 to 9. I'll come to the ASCII values of the digits very soon. So here is 1. 1 means it is a digit, let us say. So its value is incremented by 1 over here. Actually in the sample output, whatever array we are printing it, all the values are initialized to 0 first. The first 0 indicates index 0 value. Second 2 indicates 1 value. Then this 1 indicates 2 value. Then this 0 indicates 3 value. This 1 indicates 4 value, and so on. The last 0 indicates 9 value corresponding to the digits which appear in this string. Say for example, 1 is repeating or having frequency of 2 here, so we are placing it 2 here. Same way, 2 is appearing only once, so 2 is appearing once. 3 is not appearing at all in the string, therefore it is 0. 4 is appearing once, 5 is appearing once, 6 is appearing once, 7 is also appearing once, whereas 8 and 9 are not appearing in the given string. Here is the explanation. In the given string, 1 occurs 2 times here, and 2, 4, 5, 6, 7 occurs 1 time each. The remaining digits doesn't occur at all. Same thing you can check for the remaining inputs as well. Here is another sample input given. Here 0 is not there in the string, 1 is there 2 times here, 1 here as well as 1 here. So on, we are having 2 more sample strings. This is going to be the output. First of all, let me change the theme over here to darker side and put this one as a, let us see how exactly this one is going to work. Say for example, this one is a input string given in an array, say S. All these strings starts from index 0, then index 1, then index 2 and so on up to the last. So we need to find the length of this particular string, and the length of the string is 11. We will take one more array and let us name this array anything. I am naming it as ARR. Let us initialize this array with zeros first. Now when we are traversing this string from the first character onwards, we will check whether this one is a digit or not. No, it is not a digit because it doesn't range from 0 to 9. That we will see in the code. Even W is also not a digit. Here comes the first digit. Whenever 4 is encountered, because it ranges from 0 to 9, what we will do is we have encountered a character 4 here. When we have encountered a character 4, then this has to be subtracted from character 0 to achieve its decimal value, because the decimal values and its character equivalents are something like this. So for a character 0, its decimal equivalent is 48. So for getting this 4 is a digit. So where exactly 4 is? 4 is here, 52. So its equivalent decimal value will be something like this substituted. I'll substitute here 52 minus character 0 value is 48. So when I say 52 minus 48, I'll get numerical 4. So I'll typecast this one, and its equivalent index position, I'll go to this index position, and whose initial value is 0, I'll increment this value to 1 when I have encountered 4. Similarly, n is not a digit. Let us say 8 is a digit. So when 8 is encountered as a digit, same thing we will apply it over here. So I'll say now 56 minus 0 character value is 48. Then I'll get its equivalent numerical value. So I'll go to this particular index and increment the value by 1. Again I have encountered 8 one more time. I'll increment it 2. That's why here the result is 2 here. Same way, 1 incremented one time and 2 incremented one time, and the last one 1 is incremented one more time, so that the answer is 2 here for 1, and for 2 it is 1, for 4 it is 1. For the remaining one, when we have not incremented, its value remains to be 0 only. So I hope this working is clear. With this particular guidelines and the concepts, let us write down the code and test. For the test cases, let us see the required variables here. We required a string, declare a string, allocate the memory dynamically using malloc function, some random number of size, then I'll use the size of a character to allocate the memory. Once the memory is allocated, read the variable here. Now once you have read the string, we need to find the length of that string. So declare a variable and call strlen function using string as a parameter, which is available in string.h header file. We required one integer variable to iterate it. Now we required one more array for storing the results. So what type of array that one is? That array is of integer type. So I'll declare an array of some 10 size maximum, because 0 to 9 will be the, so I am declaring a static array and initialize that array to be all elements to be 0. So for I is equals to 0, I less than, initialize that array all to be 0. Now for each character we are scanning from first index 0 to the last index of the string. How do we reach the last index of the string? We have length. Here length assigns actually. So for each character, when we are iterating, we need a loop. What we need to do is we need to check whether we are interested only in digits. Remember, we are not interested in characters. So if s of I is greater than or equals to character 0, because it's a character array, as well as s of I if it is less than or equals to character 9. What we have to do here? We have to store its corresponding integer value and increment the value by 1. So how do we do that one? Array name is ARR is the array name. In this array, we need to typecast it to integer. What we need to typecast it? Whatever s of I we are getting it, we have to subtract this value from 0. We have seen this concept. Place it in parenthesis, increment the value by 1. So what we are doing in this for loop is, each character we are checking whether it is a digit or not. If it ranges from 0 to 9, then we are subtracting its value from 48, what we have seen. Say for example 4 is encountered first here. When 4 is encountered, then we say its equivalent decimal value is now going to be 52 minus this one is going to be typecasted into its integer one. So it will be converted into 4. So what we are doing at this particular 4 position, we are incrementing its value from 0 to 1. If it is not a digit, we are not doing anything. That's why only if condition is there, not else part. So if it is a character, directly go to the next one by just incrementing the value of I from here to the next character. So on until we reach the last character, that is the length of the string, we are proceeding it. Hope this concept is clear. Now once we are done with this, we just need to print the contents of the array. For that one, we required again a loop. Print. What we need to print? Print array of I, that is using %d, and after every digit to be displayed, a space is to be printed, because given in that here output format is print 10 space separated integers. So we need to give a space here for array name a of I. And the last important thing is release the memory allocated dynamically. Dynamic memory allocation, we have done it for string s. That's it. Let us quickly check by running the code. Here we need to make it as 10. That's why we are getting a wrong answer here, because it was traversing till length. We have to traverse it this array of 10 size. Let us run the code again. Processing, and here is the sample test cases are cleared. We got the desired output here. For this is the output. Yes, expected output is matched. Let us submit the code. It's processing for the remaining test cases. Congratulations. So we have earned 25 points, and here is the message, congratulations. And now we are ready for the next challenge. That's all regarding the digit frequency challenge from HackerRank. We will continue the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is to sort array of strings. To sort a given array of strings into lexicographically increasing order or into an order in which the string with the lowest length appears first, a sorting function with a flag indicating the type of comparison strategy can be written. But the disadvantage with doing so is having to rewrite the function for every new comparison. So here, to have a better implementation, that is to overcome the disadvantage of this one, so every time we have to rewrite the function for new comparison strategy, a better implementation would be to write a sorting function that accepts a pointer to the function that compares each pair of strings. Now doing this will mean only passing a pointer to the sorting function with every new comparison. You are given an array of strings. You need to implement this function, string sort function, which sorts the strings according to a comparison function. Here is the comparison function, a pointer to a function. You need to implement this function. Here, string sort function we have to implement. This is the first function to be implemented, which takes a two-dimensional array as a first parameter, and second one is the count. Count is nothing but the length of the string given, and returns an integer value, and a pointer to a function will be the third parameter. Here are the three arguments: an array of string, length, that is the count, and the last one is the pointer to the string comparison function, that is the name of a function is comparing functions. And now, apart from this implementation, you need to implement the following 4 string comparison functions as well. Here are the 4 functions. First one is lexicographic sort, returns an integer value to sort the strings in lexicographically non-decreasing order, that is in ascending order. Second one, exactly reverse. Reverse is nothing but descending order. Third one, sort by number of distinct characters. Now distinct characters which does not repeats in both the string. Say for example, if we have A string and B string consist of some sample inputs over here. So all characters in these two strings are distinct. There is no duplicate characters available over here. And the last one is to sort by length. To sort the string in non-decreasing order of their lengths, that is ascending order of their lengths. Ascending order of their length is from smaller to the larger one. So smaller string appears first. So here is, if two strings have the same length, then lexicographically smaller string should appear first. Input format, you just need to complete the function. This is the first function, and implement the remaining 4 string comparison functions what are listed over here. Input, you just need to complete the function here and complete the 4 strings that we have just now seen. Constraint is the number of strings should be in the range of 1 to 50, and the total length of all the strings should not be less than 1 and should not exceed this length, number of characters. You have to write your own sorting function, and you cannot use the inbuilt quicksort function. The string consists of lowercase English alphabets only, so it doesn't consist of uppercases. And the output should be the logged code stub will check the logic of your code. The output consists of the strings sorted according to the 4 comparison functions in the order mentioned in the problem statements. If this one is the sample input, that is the 4 strings, then lexicographically this one in ascending order appears first alphabetically, then comes Q, then comes S, then comes W. So alphabetically this is going to be there in ascending order. Exactly reverse way this one is going to be. If you take it exactly opposite, so this is descending order. So this is going to be in reverse descending order. And the third one is sort by length, and this is going to be, this is based upon distinct concept, that is alphabets which doesn't repeat. Now how do we perform this type of sorting techniques? Let us see the working. The first one, we want to sort the data elements in ascending order. Let us say we have 2 strings A and B. You compare using strcmp function. Strcmp function will returns equals to 0 if both the strings are same. Otherwise, lexicographically, if A is greater than B, then it returns a value greater than 0. That's what we wanted over here in ascending order. So just provide this code here, it will return integer value. Exactly reverse is the scenario in the second one, that we want it in descending order. So for descending order, we can use strcmp of A comma B less than or equals to 0. We are done with 2. Here comes the implementation of the third one, is number of distinct characters provided by both. Let us see this third one in detail now. Let us say we have 2 strings parameters as A and B, and consider A string as, if we assume these 2 strings are passed as parameters, we will count the number of characters in each one as, say, C1 initialized to 0 and C2 initialized to 0. We will take an array, say alphabet 1 set and alphabet 2 set. Let's say these are the 2 arrays what we are taking it to count for distinct one. Since there are 26 alphabet set, we are having an array of size 26 each over here, starting from index 0 to index 5. And let us take the length of both these strings n1 and n2. n1 is the length of the first string, n2 is the length of the second string. Whenever we encountered an alphabet, what exactly the position of alphabet in the first one is, let us check this one here. This corresponds to alphabet A, then B, then C, D, E, F. Increment the value of this one by 1. Same way, then for G, we increment the value of this one by 1. Like that, for each character, we are going to increment the value by 1. Other characters which are not appearing in this string will remains 0 only. Say for example, W is 1. So the bits are changed to their position, flag status are changed to 1 only for these 4 characters, remaining are set to be 0 only. Similarly, this is 1, this is 1, say for P, it is set to 1. So what we have done here, we have initialized C1 is equals to 0 and C2, number of characters in the second one, is going to be 0. N1 is the length of the first string, N2 is the length of the second string. Then initialize this one, we need a loop over here. Say I am going to take a for loop, then another for loop, independent for loops, these two are which are going to initialize their values to 1. Then how do you count these values? Take a for loop now, one more for loop, start an index I and check that value from 0 to again 25. At index 0, check this value is 1, no, not 1. Is this value 1? Not 1. C1 remains 0 as well as C2 remains 0. Proceed further by incrementing the value of I by 1. Then proceed here. Is this one 1? No. Is this one 1? No. This one remains 0 only. C1 remains 0 as well as C2 also remains 0. Then by incrementing the value of this one 2, we got here 1, this 1. So increment C2 as 1. So if we proceed like this until we reach the last index, and we found that the number of characters, the number of times this one is going to be incremented is 1 for this one, 1 for this one, 1 for this one, and the last 4. So here 1, 2, 3 and 4. This one is going to be 2, 3. So we know that 4 is greater than 3. So you check the value of C1 and C2, return whichever is greater. C1 is greater than C2. Otherwise, compare these two strings A and B, whichever is greater than 0, you return that value. So C1 is greater than C2, so return true. Here is the integer value to be returned, that is sort by number of distinct characters. So this is the logic behind the third one to be implemented. And to implement the fourth one, it is just by using the length. Whichever length is greater, you sort it accordingly. So here is the length of this one is greater, you sort according to this one first, then this one next. That's all regarding the working of this one. Let us quickly write down the code. The first one, return compare to string using strcmp. We have two parameters A and B passed as parameters. If it is greater than 0, returns true, otherwise it returns false. Exactly opposite is the case for the second one, strcmp A comma B. If it is less than or equals to 0, returns true, that is in descending order. Now here comes the implementation for the third one. So let us start first by declaring the set of variables. I required the set of variables as count. So C1 initialized to 0 as well as C2 initialized to 0. We required two arrays, alphabet arrays of size 26 each to be initialized to 0. So I'll declare this one as a #1 of some size, say 26, which is initialized to 0 for all the set of elements. Same way, say #2 is a set of elements of size 26, initialized all the elements to 0. Now we required n1 to get the length of the first string. To get the length of the first string, we can call strlen function. Same way, to get the length of the second one. Now how to mark 1? We need to iterate it because there are more number of elements here. So I'll be iterating it for n1 time. For this array, we have a of I. If this value subtracted from alphabet A for that particular index position, we need to initialize it to 1. Same thing I have to repeat it for second one. Here the array name is, we have to use B of I. Same character A is the base character actually. Initialize it to 1. Now once you are done with this one, we have to increment the count. To increment the count, we have to check whether the value stored is 1 or 0. So we have to iterate it again. This time we have to iterate it only 26 number of characters. So that's why less than 26 starting from 0. We have to check of I. If there exists an element, that means it returns true. So I'll increment C1 simply plus plus. Same condition, I have to check it for second one as well. That's all. What we need to do now is we have to return. If C1 is not equals to C2, then we have to return C1 greater than C2. Else return, compare the two strings A and B, whichever is greater than 0. If A is greater than B, it returns true, otherwise returns false. That's all regarding the code for this function. Distinct characters, sort by number of distinct characters, and we have two more functions left out. One function is with length. Length is very simple. You can just check the length by calling strlen function. Strlen function called for A. If it is not equals to strlen function of B, then what we have to return? Return strlen of A is greater than B. Else, if it is not, return same thing what we have done earlier in the last function. Same thing we have to return. Greater than 0 if it is, then returns true. That's all regarding the length, and we are left out now with the last function to implement. Here we need to sort it using any one of the sorting technique we can use, where we need to pass the pointer as a parameter. Let us take a loop to start the iteration. Int I equals to say 1. We know the length as well, so I less than length you can use, that is the second parameter. What you can see here is the second parameter, length. I can use this length and iterate it. Take one j variable, initialize it to 1, and take a character pointer and assign the address of, that is a two-dimensional array address, that is passed as the first parameter, ARR of I. Now we need to compare, or we need to call the function, that is this one, this third parameter one. So if it is greater than 0, returns true, otherwise not. So here is the thing, but we have to repeat this process until j value is greater than 0. J we have to initialize it to I, because every time we change the value of I, j value will change. We will iterate it until j value is greater than 0. If, what is that comparison we have to do is pass the parameter cmp underscore function array of j minus 1 comma address of the first one, what we have stored, where we have stored the address we have stored it in this variable, say p. So use that variable p here and check if it is greater than 0. If it is so, then j minus 1 element has to be placed into j position. So j minus 1 element, that is ARR of j minus 1 position element, should be placed in ARR of j. Otherwise, if it is not, we need not continue, just give break. And since j is initialized to I value every time, we have to decrement it until it becomes 0. So j value is decremented, and after coming out of our loop, ARR of j will take the address of p. That's all. We have done with this functions. Now the time is to run the code and check. Yes, is the message, and it has passed through the sample test case our output, and the expected output is matching. Let us now quickly submit the code. Let us see how many test cases it has. Oh, test cases for this one, almost 25 test cases plus the 0 test case, so 26. Congratulations, you solved this challenge. Compiler message is success, and with this one we have earned 40 points, and now the score has moved to 305, and we are close to the rank of 10,000 now. This time, earlier it was 15,000, now the rank is somewhere around 11,000. That's all regarding this coding challenge. We will continue with the remaining coding challenges in the coming videos. Thank you. Hi, and welcome to another online coding challenge on HackerRank. Today's challenge is permutations of strings. Let us see the problem statement. Here is the problem statement. Strings are usually ordered in lexicographical order. That means they are ordered by comparing their leftmost different characters. For example, if ABC is compared with ABD, then we know that all these three characters appears alphabetically before the characters which appear here. Anyhow, AB appears in the same position, doesn't matter over here. Here is the last character, that is D, is alphabetically less. So lexicographically C appears before D because C is less than D. Also in the same sense, when we say Z is greater than, say Y, because Z is greater than already Y. If one string is an exact prefix of the other, it is lexicographically smaller. That is, say for example, GH is a substring of GHIJ. So obviously it is going to be less than this one. So keeping these things in mind, we will be solving this problem. Here is given an array of strings here. So it is a two-dimensional array. A string itself is a collection of characters. Here is an array of strings are there, sorted in lexicographical order. Print all of its permutations in strict lexicographical order. If two permutations look the same way, then only print one of them. See the note below for an example. Complete the function. We have to complete this function, next permutation, which generates the permutations in the described order. For example, if an array of string contains S of AB placed at index 0, that means this is S of 0. Same way, this is index 1 means this is placed as S of 1. Similarly, this is 2 means this is S of 2. These 6 permutations in correct order are, as we know that since there are 3 strings are there, the number of ways in which these 3 strings can be arranged in among themselves is 3 factorial ways, that is totally of 6 ways. Those 6 ways are AB, BC, CD, then AB keeping as it is, we can shuffle these two, CD and BC. Same way, second one if we keep first, then AB and CD, then again these two can be interchanged by keeping BC as it is, and the last one CD, AB and BC can be interchanged so that we can get a possible combination of 6. There may be 2 or more of the same strings as elements of S. Say for example, AB appears here. So we need not repeat this AB in the result. That means that total combinations of this one is 6. But we should give exactly 3 combinations, that is AB followed by AB and then BC is one possible combination from this one. Then the second one is AB followed by BC then AB. Then the third possible combination will be BC, AB and AB. Although if we interchange these two, again we may get one more possibility, but which results in the same permutation. Again the same thing. If I interchange these two, may results into one more permutation, but it is the same. Same way, if it is giving you the same result, don't repeat it. That is the meaning for this one. Here, where all the elements should be printed, in other words, say S of 0 is equals to S of 1, then print S of 0, S of 1 or S of 1, S of 0, but not both. Here, what do you mean by this one is, a 3-element array having 3 discrete elements has 6 permutations as shown above. In this case, there are 3 matching pairs of permutations. S of 0 is AB, this is S of 0, this is AB, and S of 1 is also AB are switched. We only print 3 visibly unique permutations. These are the 3 unique permutations what we are going to print. Input format, the first line of each test file contains a single integer, that is n. The length of the string array S. Each of the next n lines contains the string S of I. The constraint of the problem is n value should range from 2 to 9, and each of this string should be of length 1 to 10 maximum. S of I contains only lowercase English letters. These are the 3 possible constraints given. Output format, we need to print each permutation as a list of space separated strings on a single line. Like for example, here first input value is n, and this one is now going to be considered as S of 0, and this one is going to be considered as S of 1. Sample output, possible combination ABCD, CDAB. This is one permutation, this is another permutation. Another example, say n value is 3, S of 0, S of 1 and S of 2. There are 6 possible combinations in which we can get this output, 6 possible ways, but since these 2 are repeating, so we need not interchange this one and print the result, only one is to be printed. So if these 2 are distinct, then we could have get one more result for this one, one more result for this one. So totally of 6 possible, but here since these 2 are same, we need not print 3 more, so only 3 outcomes. Here is a small explanation. This is similar to the note above, only 3 of the 6 permutations are permitted here. That is to avoid redundancy in the output. Here is the code. We have to complete this function. In next permutation, returns integer value, takes one parameter as n, number of strings, and S is an array of strings. We have to complete this code here, and given code in the main function is S is a 2-dimensional array of strings. We are reading the value, is already done, we need not do this one. Allocating the memory and reading the strings, and here this function is called in the do while loop as next permutation. Every time this function is called, if it returns 1, then continue the loop and print. That first time printing is already done. Then next time, if the condition is true, next time it enters the block and print the next permutation. Otherwise, if it is 0, then exit the block and release the memory whatever allocated by calloc function. Okay, in this problem, what we will do is we will upload the code file. I have already written the code file, so I'll just use this option, upload code as file. Uploading a file will replace the current content in your code editor. Would you like to continue? Say yes. I'll select file. I'll select the file from appropriate position. I'll say upload. Since my file already contains main function, I'll show you the code over there by running. So I'm removing that main function from here. Only one main function is required. Here is the main function which is provided, and this is the code what I have added, embedded through the file. First of all, I'll show you by running the code, and then I'll explain you how exactly this function works. Run the code. Have passed the sample test cases here, AB, CD, ABCD, CDAB, expected output. Let us submit the code. It's going through almost 41 test cases along with 0th case. So you can see maximum number of test cases we have here. Yes, congratulations is the message. You have earned 40 points, and compiler message is success. It has gone through all the possible test cases successfully. So we are under the rank of 10,000 now. Earlier it was 11,000 before starting the challenge. In the last challenge we have seen this. Now I'll show you the code what we have done. Let us say here n equals to 2 is the parameter, and the character array contains say S contains A, B and C, D if it is the case. Then here is the for loop starting. I is equals to n minus 1 means for one value it's starting. and comparing s of I with s of I minus 1. This is index 0, this is index 1. So when I say s of I, that is nothing but CD. So when we call strcmp function with CD comma AB, yes, CD is greater than AB, so it's greater than 0 will results into true. Enters the block and perform this particular operation. What we are doing it over here, we are making a permutation over here by taking j value as say I plus 1. I plus 1 is 2. So this condition 2 less than 2 false, because our n value is 2. So doesn't execute this part. We have swap operation here, taking t as a string and taking s of I minus 1. Current I minus 1 is AB 0, and s of I minus 1, that is nothing but in place of this 0, I'll write it down here, index 0, index 1. So in this one we will get s of j minus 1. J minus 1 is 2 minus 1 is 1. So I'll be getting CD here in this possible position. Then t is placed at s of j minus 1. That is nothing but here t is copied into this particular position AB. One combination we got it. For I, nothing is initialized here, I less than n minus 1. So current value of I 1, less than 1 n minus 1 is false. When it is false, it will not enter this block. So one combination we have generated it over here, CD and AB. One combination AB and CD, another combination CD and AB. When we come down here, it returns 1. Returns 1 means that prints the possible values, that is string CD comma AB. Now here is, if let us say this condition fails. When this condition will be fail, say for example I have a function say BC, BC, both the strings are same. To compare it, then when I am going to compare this one BC with BC, obviously both are same, which returns 0 actually. strcmp function returns 0 when we compare these two strings. So 0 greater than 0 is false. When it is false, comes out of the if condition and then performs this particular swap here and then returns 0. For this 0, one particular combination of BC is not printed, because we need to print BC only one time, say A comma BC, and then BC should be printed only once like this. So for that reason 0 is returned. When 0 is returned here, this will be false. Once it is false, the do while loop will get terminated. That's how the working of permutations of strings is there. So this we have executed in a different way by uploading the code file. I'll attach this code file in the resources. You can download it and check the execution as well. That's all for this. We will continue with the remaining challenges in the coming videos. Thank you. Hi and welcome to another online coding challenge on HackerRank. Today's challenge is querying the document. Let's see the problem definition. A document is represented as a collection of paragraphs. A paragraph is represented as a collection of sentences. A sentence is represented as a collection of words, and a word is represented as a collection of lowercase and uppercase English characters. You will convert a raw text document into its component paragraphs, sentences, and words. To test your results, queries will ask you to return a specific paragraph, sentence, or word as described below. Alicia is studying the C programming language at the University of Dunkirk, and she represents the words, sentences, paragraphs, and documents using pointers. Now, a word is described as a character pointer. So it is nothing but a one-dimensional array. A sentence is described by a pointer, that is a two-dimensional array. The words in the sentence are separated by one space. the last word does not end with a space. A paragraph is described by a pointer to a pointer to a pointer, which is something referred to be as a three-dimensional array. The sentences in the paragraph are separated by a dot, that is one period. A document is described by a pointer to a pointer to a pointer to a pointer, something referred to be as a four-dimensional array. The paragraphs in document are separated by one new line. The last paragraph does not end with a new line. For example, here is the sample text. Learning C is fun. Learning pointers is more fun. It is good to have pointers. The only sentence in the first paragraph could be represented as first sentence in first paragraph. Learning C is fun. Separated over here like this. The first paragraph itself could be represented. So if you place this complete thing using flower braces, that will be considered as the first paragraph. So here individual words, if you place it, it will be considered as one sentence, first sentence. Same thing if you place it within the flower braces, it will become the first paragraph. The first sentence in the second paragraph could be here. First sentence consists of 5 words and second sentence consists of 6 words. The first sentence in the second paragraph will be learning pointers is more fun, and the second sentence consists of 6 words are here. The second paragraph could be represented as learning pointers is more fun. Finally, the document could be represented as each paragraph here, one paragraph, then second paragraph. Collection of these paragraphs all together is nothing but a document. Alicia has sent a document to her friend Tudora as a string of characters that is represented by a character pointer, not as a document. Help her convert the document form by completing the following functions. So we have to complete these functions, and the first one among them is get document. So we will be given the data in the form of a character pointer, that is a word. Then we have to convert it into its document equivalent. Then the remaining functions, kth paragraph. To return this one, the kth paragraph, you will have the parameter as document and k as the integer value. Then kth sentence in mth paragraph. Document will be passed as a parameter, k and m will be the remaining parameters, and kth word in mth sentence of nth paragraph. Then you have all these 3 values passed as a parameters. To return kth word in the mth sentence and in the nth paragraph. This is the input format. The first line contains the integer. Remember this input format. The first line will be containing the integer, that is the paragraph count, how many paragraphs it contains. Each of the next paragraph count lines contains a paragraph as a single string. The next line contains the integer q. Here, what is the q is? Q value is nothing but the number of queries. Each of the next q lines or group of lines contains a query in one of the following format. 1k. The first line contains 1k, the next line contains an integer x, the number of sentences in the kth paragraph. Each of the next x lines contains an integer a of I, the number of words. So these are the input formats. If it is starting from 1, if it starts from 2, 2km. The next line contains an integer x, number of words in the kth sentence of the mth paragraph. So it will be kth sentence in mth paragraph, and the last one, the only line contains 3kmn. This query corresponds to calling the function in such a way that kth word in the mth sentence of nth paragraph. This is the constraint of the problem. The text which is passed to the get document has words separated by space, sentences separated by a period, that is dot, and the paragraph is separated by a new line, that is slash n. The last word in a sentence does not end with a space. Last paragraph does not end with a new line. The words contains only uppercase and lowercase English characters, letters. No other special characters are allowed. Number of characters in the entire document should range from 1 to 1000, and the number of paragraphs in the entire document should not exceed 5 and should not be less than 1 as well. Output format is print the paragraph, sentence or word corresponding to the query to check the logic of your code. Here is the sample input. Here 2 specifies the number of paragraphs, 1 and 2. So the first query here corresponds to returning the second paragraph with 2 sentences of length 5 and 6. How do you reach this particular one is, here is the query corresponding to this one, the first query that is going to be there. The first query corresponds to returning the second paragraph with 2 sentences of length 5 and 6 each. The second query here corresponds to the first sentence of the first paragraph. It contains how many number of words? 4 words. The second query corresponds to returning the first sentence of the first paragraph. Second query corresponds to returning the first sentence of the first paragraph, which contains 4 words. And the third query here corresponds to returning the first word in the first sentence of the first paragraph. Here is the first method, that is kth word in mth sentence of nth paragraph, and here is kth sentence in mth paragraph, and here kth paragraph. Apart from these 3, we have to write down get document provided the input as a character array, that is word is given as the input. To complete these functions, let us see what has been given. Let us see, these are the things which are provided. Get input text is given, print sentence is there, print paragraph function is there, then main function which contains, here get document is called with the text what is inputted by the user. If it is type 3 query, then this is the processing. If it is, then kth sentence in mth paragraph is processed, else the last processing is here. Now this is the code what we have written over here, and we will upload this file. The first function is here, kth word in mth sentence of nth paragraph. To understand this particular thing, let us first of all describe what exactly a document consists of. Here is, a document consists of multiple paragraphs, say paragraph 1, paragraph 2, paragraph 3 and so on, and number of paragraphs are there, where each paragraph consists of multiple sentences, sentence 1, sentence 2, sentence 3 and so on, where each sentence consists of words, word 1, word 2, word 3 and so on, where each word consists of a character array. So a word is nothing but a one-dimensional array. So a one-dimension array, here collection of one-dimension array, this one will be a two-dimension array sentences. Collection of two-dimension arrays over here, it will be a three-dimension array. This one is a four-dimension array. That's why you can see here, when we are returning kth word, we are returning a one-dimension array from a document. Document consists of a paragraph. Paragraph is again going to be collection of sentences. Sentences is a collection of words. Word is now consist of a one-dimension array each. Say we want to extract kth word from document. So there can be n number of paragraphs here, given nth paragraph, mth sentences, number of sentences we can have, kth word, so some number of words. We want to extract some kth word of
mth sentence in nth paragraph. This can be written something like this, because indexes starts from 0. So here n minus 1 of m minus 1 of k minus 1. Return is a word. Now when we ask for kth sentence in mth paragraph, kth sentence in mth paragraph, then it will be m minus 1 of k minus 1. And the last one, only you want a paragraph, only you want a kth paragraph, then you return only this part. So this is just returning a one dimension array here. This one is returning a two dimension array, this one is returning a three dimension array each. Okay. Apart from this, we have to implement one more function. And here is that function is get document. Is a pointer to a pointer to a pointer to a pointer. It's a 4-dimensional array what we have to return. What we are doing it over here is we are taking paragraph count and initializing it to 1, because every document consists of some paragraphs, paragraph 1, paragraph 2, paragraph 3 and so on. Whenever we are encountering one paragraph, we are incrementing this value by 1. How do we encounter a paragraph? Whenever we have a separation, that is /n is there, each paragraph is now separated with /n. So paragraph count will be incremented. And accordingly, we are taking one array here, a 4-dimension array answer, in which we are allocating the memory dynamically for that array, and here we are going to place each paragraph by calling a function getParagraph with a text that is passed as a parameter from starting position to the ending position. That we are going to start from 0 first, then whenever there is a /n is encountered, that means that one paragraph has been encountered. So this getParagraph function has to be implemented. How it is done? Let us see here. Here is a getParagraph 1. First parameter is the text, beginning index, ending index, from where to where we want. Then every paragraph will have a dot. Dot is used for separating a sentence. So paragraph is a collection of sentences. Say sentence 1, then dot, then sentence 2, then dot, then sentence 3, then dot, and so on. So here each dot is now going to have a count increment for a sentence. How many number of sentences are there? Based upon this one, we are going to allocate the memory, and starting index to the ending one we are calling get sentence now, because we want to extract now the sentences. So the only difference in the function implementation over here is, there you have get paragraph, here now you have get sentence is called internally. Let us see now how get sentence works. Here is get sentence. In every sentence, sentence is a collection of words separated by a space. Here is the space. Count how many number of words are there. Whenever there is a word encountered, you increment the value by 1 here. So 1, 2, 3, like that you are going to increment and find how many number of words are there. Based upon that you allocate the memory dynamically. And here you can see we are calling one more function internally called as getWord for the following text from starting to the ending one. And finally here is getWord function, which is taking the text from the beginning position to the ending one, allocating the memory dynamically based upon the size of the word, and placing that text into the answer and returning that answer here as a character array. So what we are doing, we have written a getDocument function. GetDocument function is calling internally getParagraph. GetParagraph is internally calling getSentence. GetSentence is internally calling this one getWord. This is the getWord function what we have here at the end. So this one we have to implement actually, getDocument. So document is a collection of paragraph. We have written a paragraph function separately and calling internally here. And again getParagraph is calling again getSentence. GetSentence is again calling getWord, where we are actually returning the words. This is how the working of this challenge. Let us try to run and check the working based upon the input provided. Build the code, check the logs. Here is the input what we need to provide. First one say 2, and the second line is the first paragraph. There are 2 paragraphs. The 2 means here there are 2 paragraphs. Learning C is fun is the first paragraph. So here completes the second paragraph. And the next input is 3, and the query now contains 1, 2. From second paragraph we want the second sentence, and how many number of words? 5. Here you can see the first output, sample output is here first. So until this one we have inputted. So 5, 1, 2, 3, 4, 5. That is the output, sample output 1, 2, 3, 4, 5. Now we will input this 6. That is from the same thing we want 1, 2, 3, 4, 5, 6. This 6. Let us give this 6. Here you can see it is good to have pointers. Here you can match the output is the output. So till this point we have done. Now the next input values 2, 1, 1. 2, 1, 1. Then how many number of words? Here is the, till now we have inputted this one. So we got this one. Learning C is fun is the output. And the last input value what we have to give it is 3, 1, 1 and 1. Yes, perfect. It is giving you the output as learning and learning over here. So this is the input and this is the desired output, and this is the output what we got it. Perfect. So what we will do now is we will upload this file. So now let us upload code as file. Say yes, select file and say upload. We will remove the redundant data here. Okay, now we have uploaded the code file. Let us run the code and check the output. Yes, congratulations, it has passed the sample test case. Let us submit the code. It's having total of 5 test cases. Congrats, you just solved all functions challenges in C language, and you have earned 60 points. Can see 45 more points to get your gold badge. So your querying the document submission got 60 points. That's all regarding this challenge. We will continue with the remaining challenges in the coming videos. Thank you.